Hello and welcome to a new set of tutorials in the famous CAD software SolidWorks. So in this tutorials we're going to use the SolidWorks 2014, the newest in this year. So SolidWorks is a very famous and most used since it is strong CAD software, user-friendly with interactive interface. So here you have your first interface when you are starting your SolidWorks, and here you have the file, view, tools, help. The file, you have the new open, the view, the toolbars, and they are still shortcuts until we enter the part editing or start a new part. So here you have a quick shortcut, new and open, and here at the end, if you open, you have the option where you have the system options. We are coming to this options later in this tutorial. And also you have the add-ins. So SolidWorks has add-ins, not only its main job to make 3D modeling, also you can perform some specific studies like simulation, routing, and also you have some tools that they are already made that you can easily insert them into your assemblies like bolts, screws, and so on. Also you have another add-ins. So for example, if you want an add-ins, to start an add-ins, you just pick it from your menu here, and if you wanted to start up with that, you can check it. So I keep it unchecked because that would save some time in starting. So now let's start a new part. To start a new part, you have the new, or from file, new. So you have three main types of parts or files. The part is a simple 3D you are creating, and then the assembly, to assemble what you have created in the parts and assemble your final product, drawing a 2D presentation it is a last stage to represent your products to client or the manufacturer. So let's select part and then OK. So here's the new part interface. Here you are able to minimize it, and here you have your part, and to the left you see your part 3. And as you notice here, you have the simulation icon is in here because in the beginning we started it. And also we're going to talk about the units because it is important to choose your units. So now let's go to the options menu. From here, if you take this option, this time you will notice the document properties. You have the options here. You can try to have a quick look on them, but the most important now, we go to the document properties, and then you go to the units and choose the system you want. So we are going to use the millimeter gram second system in all our tutorials. So when you are done, click OK. So when you are looking here at the bottom, you'll see the used units, and you are able to change them quickly to other system. So I'm going to keep them to millimeter gram second. Also, if you look into the interface, you have these quick icons. Right now we don't have any drawn part that we can use them, but they are easy to use, and they are like the zoom to fit, zoom to area, the section view, and how you are viewing the orientations of your parts, the isometric, normal tool. So if you notice, this one is the normal tool, which bringing your part to the normal to the face you select. And here you have on this under the classes you have different options. We'll be familiar with them when we starting our parts. So in the next tutorial we're going to start the first sketch and see the sketch menus, functions and tools. Tutorial number 2. In this tutorial we will start our first sketch. So this is the first tutorial we're going to start working with SolidWorks. We said to the left you have the part 3, and the most important things to look at right now are the planes. So you have 3 different planes and you have the origin. So if you remember in the mathematics, you have the origin with the coordinates of 0, 0, 0. Front plane, you can imagine it like the ZX coordinate, top plane, the XY, and so on. So these are the views or the planes where you are able to start your sketching. So depending on the orientation of your parts or how you want it, you can select the plane you want. So once you choose your plane and click on it, you will see this sketch. So that means you are able to insert a sketch on that plane. So let's click on it. Now we are able to make a sketching. So the sketch menu here is activated if you go to it. So you have the sketch tools. So it is starting from line, the simplest tool, the corner, and so on. So we're going to have a look on the sketch tools in the next tutorials. So now let's start with the line and let's start from the origin. So SolidWorks is user friendly, so it gives you marking to you and helping to choose your points. And if you look at the bottom, you will see the coordinates of your points. So if you put it on the origin, you will get a 0, 0 or coordinates. So now you can see your coordinates here. So let's start from the origin, and now you can see the length of your line. So that is a helpful tool, so you know the approximate length instead of making small lines or bigger lines and then redimensioning them. That might miss your sketch. So you can take it to be, for example, 100 millimeter, and when you click, you're selecting your point, you are still able to use the line tool. So when you are done, you can click escape or right click select to end your line tool. So another thing to use with the line, let's select the line, pick the point where we want, and if you notice this yellow relation appears to you, that means this line is vertical. So when you are drawing, you have some relation as well. For example, now if you hover over this line, you are able to select the middle point, and you see the relation appear next to that, tell you that is a middle point. So we can pick it. So now we know there's relations. So if you make it like this, you have this relation, it is perpendicular to that line. So they are very helpful tool to help you sketching in an accurate way. So if you want to show the relations on your sketch, you said on the glasses here you have the view sketch relations. When you select it, so you'll see the relations in your sketch. So you have the midpoints here, you have the perpendicular relation and intersection here. So if you want to delete so before deleting a relation, if you want to pick that point, try to move it so you are able to move the whole part. So, and this continue to be in the middle. So let's click this point, right click, delete, or simply click press delete on the keyboard. So you deleted that relation, and if you pick that line, so you are able to move it freely from that line. So the relations playing an important role in your sketching. So sometimes you need to see for the relation if you are not able to correct some or move some lines or so on. So now let's return that relation, put it, so we made it again here. So let's hide the relation again. So in the next tutorial we're going to continue talking about the sketching, how to use the line in another way, and adding the dimensions. So see you in the next tutorial. In the previous tutorial we knew how to start a new part and sketch. So let's do it again here as a repetition. Let's start a new part, click new part, okay, and then we're going to start a new sketch, this time in the top plane. So click on it, sketch. So now we are able to start sketching. We have our sketching tools. So let's pick the line again and show you some tips how to use the line. So let's start from the origin, and you know about the relation from previous tutorial. We have vertical relation here, have horizontal, and again vertical. And if you continue, you will be able to continue making lines, but if you return back, so you'll notice the icon is changed to be double circle. That means you are able to start drawing an arc. So you can find a place where you want it. So now when you are done, so you can continue drawing your lines. And again, if you go back, you are able to create an arc, and if you back again, you will be able to draw a bigger arc. So it depends on your type of sketching. So again, here we are closing our sketch. So if you notice at the sketch, you have some lines are with the black color and the rest are in the blue colors or dark blue colors. So that means these lines are defined and the rest they are not defined. So in this case, these lines having a starting point and or ending point for this line on the origin, and as you know, the origin is a defined place. So on the rest they are missing something to be defined. So to do the definition, you need to make some dimensions. So here comes the dimensions smart dimension tool. So if you click on that and select the line, you'll be able to add the dimension you want. So let's add 60 millimeter and then press enter. So let's again choose the diameter or dimension for this line, and if you hear roll below, you are able to change the dimension, or if you click on the arrow, you can also change the dimension, or simply click the value you want. And here you have 2T, that is the name of that line. So in the advanced tutorials you'll be able to make the dimension parametric or controlled by some equation or so on. So but for now, let's just select the dimension to be 120, click on, then OK. So we are able now to continue adding more dimension until we define our part. So you notice now the lines are changed. So here, if you look at the bottom, you'll notice that the sketch is underdefined. So that means you are still need to define your sketch. So let's add some more dimensions. This is the last dimension. Okay, and here you look fully defined. So that is important if you want to make a good sketching, to define your sketches. So this is a user-friendly way to tell you if you are missing some dimensions or not. So if you added your dimension, you are still able to re-edit your dimensions by double-click on it, and you are able to change, then click OK. If you want to delete a dimension, click it on the keyboard, delete, or right click, delete. So you see here the line is here not defined. So let's delete more lines, select, delete. So there is another way how to define your sketch, but it's not used very commonly because mostly you are adding your dimensions, you know, dimension you want. But sometimes it can be used. If you go to the display, delete relation, expand that menu, you will see the fully defined sketch. So if you click on that, SolidWorks is going to calculate the missing dimensions and add them to your sketch. So calculate. So you have now there are no solution because it is overdefined. So let's undo, click and delete, and let's delete all the dimensions. Again, let's go to fully defined sketch, calculate. So SolidWorks automatically make your dimensions. When you are done, click OK. We have this sketch from the previous tutorial. So if you notice to the corner, you have this X and the exit sketch icon. So when you are in the sketch mode, so you'll notice that is appearing here. So when you are done with your sketch, you need to exit from the sketch mode by clicking on that icon. So when you click on that, so now you are outside the sketch mode, and you notice the color is changed. And when you are done with your sketch, you will notice to the left that your sketch has a name on the left tree. So you are able to rename it by right click, and then you can and then you go to the feature properties and write the new name, and here you have descriptions. Okay, or a faster way, just one click on that, then you are able to rename that sketch. You can type first sketch, then press enter. So when you are selecting your sketch, you'll notice the dimensions are appearing on that sketch. And also one thing, you are able to edit your dimension outside the sketch mode as well. So you can, so this is a new feature in the new SolidWorks versions, that they are saving times. You are able to change dimension here directly. So and here you have the icons. We said we're going to use them along with the tutorials. Here you have the zoom in and zoom out. So if you here select an area, we're able to zoom and then zoom out. So now you have the 2D sketch that is ready to be working with further. For this tutorial now, I'm going to show you a fast or quick way to start to work with your sketch. If you go to the feature, these are the 3D modeling tools. And for just quick, a start for your SolidWorks, just if you extrude, and you need to select a sketch. So let's select that sketch, extrude it. So now you are able to extrude. So this is a very fast start to give you an idea how you're going to use your sketches. So either you can extrude, revolve, sweep, cut, and so on. We are going to talk about this feature in the future tutorials. In this tutorial, we're going to continue talking about the sketching, and also going to talk about how to use the mouse. So in the previous tutorial, we created this fast 3D model or extrude, and now I'm going to show how to use the mouse. So the mouse is the most used way to rotate, move, zoom in, out your part. So to rotate your part, just on the middle wheel, keep clicking on that and then rotate your mouse. You notice the icon of the mouse change to rotating mode. So the wheel, keep continue pressing on the wheel and move your mouse. To zoom in and out, also with the mouse wheel, we can roll up and down to zoom in and out. Also you can use the keyboard arrows to rotate your parts. So now let's show you another thing. There is also view orientation for your part. Here if you click, you will see the view or plane where you are able to choose your plane. So if you don't see this cube, so you can activate it with this view selector. If you don't want to see it, just deactivate it. So if you hover here, so you are able to choose how to view your part from top, plane, side, left, front, and so on. So here you can select how you're going to see your part. So these are important for the future modeling, so you are able to use that view or surface to make more sketching. And this rotate, and also you have an important icon, the normal too. So that is giving you the normal view. So for example, select this face, go to normal to, so now it's showing you the normal to view. So now again, let's get back to sketching, because sketching is important as a first step before start making 3D models. So here we have this extruded part, and if you expand it, you will see your first sketch here. So this extrude use that sketch, and again you are able to get back to your sketch and edit again. So if you click on it, here you see edit sketch. So it is not inserting a sketch, it is edit sketch. If you click on it, let's go to normal 2. Now you see your original sketch. So you are able to change the dimension. Click OK, and then exit as we learned before. So now you have the extrude already updated to your new sketch dimension. So let's again, if you select that face, we said also before you are able automatically to change the dimensions. If you want to get back to the sketch, also you can select it or double click on it, select normal 2, and as you notice that the features menu deactivated and the sketch is active, that you are in the sketch mode. So we're going to continue talking about the sketching. We already talked about dimensions and the line. In the next tutorial we're going to talk about the rectangle. So we're going now in the next tutorial, you're talking about the sketching before start working with some feature. Tutorial number 6 in SolidWorks. Let's start a new part. And as we said, today we're going to talk about rectangle. Let's select the plane to start our sketch as we learned before, and now we are in the sketch mode. So the next after line is the corner or the rectangles, and if you hover or expand that menu, you have the 5 different types of rectangles. So the first corner rectangle is you are picking the corner points to create your rectangle. So first point, second point or second corner point, then you're having your rectangle. And also you are able to select the type of rectangle from the menu to the left. So if you select this one, now you are able to make the center point rectangle. So the center point rectangle is a very helpful tool, will be used in many of the example. So we have a list for hundreds of examples in SolidWorks. You can find that playlist in the links in this channel. So now let's use the center point rectangle. Now you're making that rectangle. So let's again select a center point. Let's first make a 2 corner point again here. And if you want to make a center point rectangle with the same corner rectangle, kind of not easy job to find, and then you're going to dimensions many times until you get to your centered rectangle. So let's Ctrl Z to undo what we done, then select the center point rectangle. Here if you hover over there, you see the middle point, and if you hover here, you will see also the middle point too. So now we have the center point of this rectangle. If you select it, very simply you are creating a rectangle in the center of that rectangle. So you can see how helpful that rectangle is. Also, you have a third type of rectangle, 3 points corner rectangle. You notice that rectangles are horizontals, but you can make your own orientation or angular view to your rectangle. So you can select 3 points and create rectangular or with an angle, a rectangle with an angle. So you can see or understand the idea of this angled rectangle. And here again you have the center point rectangle with an angular, so we can select any point and create a central rectangle. And the last one is the parallelogram. This is not a rectangle, but it has a parallel edges, as you remember in the map. So these are the 5 different types of rectangles. And one last thing I want to show you, in the line menu, if you expand it, you have a center line. So center line is easy to understand. It is for making a center line. And if you remember in the engineering drawing lessons, this type, it has dot hash that indicates a center line. So you can make it here, so that indicate we have a center line for that rectangle. And if you select one of these lines, always again the line, make a line. Here in the option you have, if you select it, here in the option you have for construction. If you select that, so now you have a construction line. So this line can be used as a reference for your sketching and drawing as a helping tool. And also the center point can show you some references in your sketching. So this is all about this tutorial, and see you in the next tutorial. Tutorial 7, we're going to continue talking about the sketch tools. So let's go to the sketch menu and let's try a new way to start a sketch. So now we are not in the sketch mode, and you notice not all the sketch tools are activated. Let's select a slot here, and now you'll notice that SolidWorks give you 3 planes. You can rotate with the mouse, as we knew how to rotate. So you see you have 3 different planes shown to you. So maybe can give you a better viewing to the orientation. So let's select the top plane here. Now we are in the top plane menu. So let's click on the normal to here, or from the orientation menu, normal to. So we are normal to the sketch. So in this tutorial we're going to talk about the slots and circles. The slots, they are quite easy to use. If you see the explaining figures here on SolidWorks, and let's select the straight slot, simply select 2 points, then your slot is done. You have a center point slot. You can make your slot depending on your center point. So select that point. Now you have another slot, circular slot, where you are able to make your slot in on an arc. The last one is the center point arc slot. So select that as a center to be of your slot, and you can create it that way you want. So now you have that slot. So now when you are done, okay, so the one is more used is the next, which is the circle. You have two types of circles. The one you are able to make it from the center point, or you define it by 3 points. So let's start the first circle. You can select the center point where you want to draw your circle, and then your circle is done. And dimensioning, we learned how to add the dimensions. Just you click on that circle and add the dimensions. Dimensioning the slots also on the same way, but you have 2 dimensions need to be added to the slot. Let's add 50 here, and let's add the second dimension to be 150. So let's add the relation here. If you click that point, you'll notice that relation icons appearing. You select constant. Okay, your slot is defined. So we're going to make a tutorial about the adding constraints. So for now we have this circle is made. Now let's start making a circle tangent in 3 points. So let's click this line, this circle, so now we have 2 lines selected. They are inside these 2 lines. And then the third one, you can select that arc or that point, or you can select this point to be clear to you. So now you created your circle inside 3 points you are selecting. So let's try it again. Let's make a center point rectangle. Select the 3-point circle. Select this line, this line, this line. Your circle is inside or tangent with these 3 lines. Tutorial number 8. Let's start a new sketch on top plane. Now let's go to the next sketch tool, the arc. If you expand the menu, you have 3 different types of arcs, and this time you don't need to draw a whole circle. You can just draw your arcs. So let's try to make a center point rectangle in the origin, and now let's activate the 3 points arc. So here you see the 3 points arc shaded in here, and you can see a hint how you can use that, or where you place your points. The first point, second point, and third point. So here you can select first point and second point. Now you can specify the radius of your arc. So you are done, click there. So you are done. So the second type is the 2 points arc, and this time you are not able to change. In this case, 2 points, you are not able to change in the radius of your arc. So you have only one choice will be defined to be as a tangent. So let's select this 2 point, first point, second point. Let's try. So here you see your arc. So you can select a different place. You are able to see your arc. So here is your arc. So it gives you an arc with the radius between these 2 points. So this is the only way to get that arc. Let's try to use it with 2 lines here. Let's select the 2 points arc, select this point, So this is your arc. And you have a third type where you can choose your center point, then start to draw an arc from that center point. And now let's move to polygon. It's also quite easy to use. Polygon, then choose the number of edges, 3. If you select 3, simply you're going to create a rectangle. So this is a very fast way to use polygon to create a very fast rectangle. And there is 2 options to make it outside the circle or inside the circle. Here you can change the number of your polygons, edges, and then one thing, you can add the dimension for your polygon. And one thing I want to say, if you want to define it, you can select one of the edges, deactivate the smart dimension, select one edges, add a relation, make horizontal, then make this point to the origin, center point. So you define your polygon. So this is a way how to define your polygons. The next tool in the sketch menu is the spline. Actually one of the, you can consider is the most difficult one to be used between the sketch tools, and it is one of my favorite tools, and it is flexible and can draw many shapes, especially in creating some complicated surfaces. So in the spline you have 4 different types. So the equation driven curve is quite advanced, where you are able to add equation to control the shape of your spline. So it's quite interesting. And the spline on surface, will be using it on the surface tools when we're going in the stage. When we are ending with the sketch tools, features tools, then we're going to use the surface tools. And now we have 2 splines. The first one is this, and you have the second style spline where you have points and edge, where to control the spline shape. So let's first choose the first type of spline, the simple spline. And now let's select a sketch. We didn't start a sketch, spline. Now if you create a spline with 2 points only, now, and then we are done, right click, select or escape. So you'll notice it is a straight line, but still you are able to control it, change its shape. So let's draw another spline with 3 points, 1 point, 2 point, third. Right click, select. If you click on spline, you'll notice each point has 2 important things. You have the handle and you have the direction. So if you select this, you are able to change the size of the handle, and the other one, you're changing the direction of that spline edge. So you have 2 things here to think about: the size and the handle. So let's do it here again. So now we are able to select, change size, direction. Also, you are able to move the points. Sometimes it is healthy practice to use as less points as possible in the spline to be more simpler to use. So if you select your spline, right click, you have another options to add for your spline. So you have insert spline point. You select where to add a point, so you have inserted a point. When you are done, escape. Click escape, then you have your new point added to that spline. And in the spline you can add dimension as well. You can select 2 points and add dimension between them. This is one way to control your spline. Also, we said you have size and direction, so you are able to add dimension for that. So let's add a size for your handle. You can add 50. You can notice the different, and also you have an angle. So let's draw a line here, simple line. Select smart dimension, select your spline edge, and this line you have an angle to add to your spline edge. So there is many ways to control your spline, and you are also able to add relations too. So if you select that point, just deactivate the dimension by clicking escape. Select this point, so you have some relation can be added. So let's try select this handle. You have add relation horizontal, so you have a horizontal relation added to that spline. So you can try to review what we said, because spline is quite needs some practices to be able to use it in a good way. And now you have a second type of spline with the guiding line as a way for more control to your spline. So you notice your spline is contained inside these guiding edges or lines. So if you select that point, from that point you are able to control your spline. So as you notice, you don't have the handle and the size as shown in the previous type of spline. So let's, for example, add a line, smart dimension, select this point and that line, so you can add dimension to your guiding let's add midpoint relation here. So this is an idea how you can work with your spline with two different ways. So I hope this tutorial was useful and gave you an idea about the spline using control them in adding dimension. Tutorial number 10, the next tool in sketching. Let's start new part, start sketch, and choose the ellipse, the next tool in sketching. And there is 4 different types. Here in this menu you have the ellipse, partial ellipse, parabola, and conic. Let's start an ellipse. The ellipse can be done with 2 directions, the horizontal and the vertical. So once you are selected your first direction or horizontal direction, then you start with your vertical dimension or vertical direction, and in the smart dimensioning you can add dimensions in these 2 different directions. So here's the first and second dimension 75, and you have also relations. So let's talk some relations. Let's deactivate the smart dimension tool. Select this point, this point, this point. So when you are selecting these 3 points, you can add a relation, horizontal relation. When you are done, okay, you define your ellipse. So we are talking about the relations with the sketching. So the relation is an important tool for defining and making your sketches. So let's try the second type of ellipse, partial ellipse. We are doing partial ellipse, the same idea as the arc in circle. Now when you are done with your partial ellipse, so this is how it looks. So you are able to move your sketch if you click on that, but in this ellipse you are not able to move it because you have a midpoint and the horizontal, or you have this intersection relation or coincident with the origin. If you click that and delete it, your sketch ellipse is undefined and you are able to move it. So let's move it again and add origin, and you notice the relation is activated. So here you can add dimension on the same way. Second direction, and you need one more dimension, the gap in the partial ellipse. Select these 2, make a gap of 34. Let's delete that. Let's select these 2 points. In adding dimension, the way you are moving your mouse, the way you're showing the dimensions. So if you make it horizontal dimensioning, you have 31.47. So if you make it parallel to the gap, so you have it 34.8, and if you make it vertical, you have 14.97. So you have to know exactly which dimension to add. So I make it parallel to the gap, I can add 35 here. Let's add one more relation. Let's make it vertical to the origin. Select this point, and here you have a vertical relation. This quick menu, and one last dimension between the origin so you have your ellipse. To fully define your ellipse, fully define, calculate. So here is your ellipse is defined. So now let's move to the next. In this menu you have the parabola and the conic. The parabola is something you should be familiar with. You start with the center point of your parabola and then you start drawing it. So it's quite rare to be used unless you have some special sketches. And the next one is conic. So you see you need 4 points to create your conic. 3, 4. So it's quite interesting way to make a conic in the end of that rectangle. Let's make one. Instead, for example, that I'm making an arc. So this is a brief tutorial how to use these conics and parabola. Good morning. Let's start a new sketch on the front plane. And let's go to the next feature in the sketch menu. We have the sketch fillet, and if you expand it, you have sketch chamfer. So to use the sketch fillet, we can do some sketches here. Can make 2 lines. Can make a rectangle. Now let's activate the sketch fillet. Here you need the radius for your fillet. Let's make it 5 millimeter, and then either to select the 2 edges to create the fillet, and then right click on the mouse or OK here, or you can directly select the corner. Let's make it 10 here. Then run down OK. And let's show you one thing else. Let's activate the fillet, and here we have this corner selected, and we choose dimension each fillet and keep the constraint corner. And now instead of selecting each corner, you can right click or selecting. You can see that pencil. Now you selected all the corner included in that, and then OK. So this is quite faster. And now we use or check the dimension each fillet, so we see the dimensions in each fillet. So for example, let's make another example. We have many corners here. Let's fillet, use this, then select all shapes. So in one click you made all the fillets to all these parts, so by selection. So when you go to the right click, you can see the type of selection: box selection or lasso selection. If you select box, you'll be able to make box selection. So now let's go to next menu. We have the sketch chamfer. So it is almost the same idea, but it's creating a chamfer. So let's make 2 rectangles. Activate the chamfer. So in the chamfer you have 2 types: either to select the distance, 2 equal distance, and here you have to check it, or the angle distance. Let's first use the equal distance. Select this edge. It's not working in the case of the chamfer. So let's just select the corners and apply the chamfers, and here you see the chamfer equal distances, and when you are done, click OK. And you notice these red icons, that means they are driven or associated with other dimensions. In this case they are equal. Let's again chamfer, select and check the equal distance, and here let's make two different distances, shows this, and let's reverse. Let's click OK, then chamfer, make it 10 or 5 by 10. So you have two different distances. Again, let's create the last rectangle and select chamfer. This case, let's choose the angle. You can make 30-degree angle, 2 millimeter. Okay, this time 60 by 5 millimeter. Okay, so here you see distance is 5 and 60 millimeter, and here too. So here are the different cases of the chamfer. Tutorial 13. Let's move to the next feature in the sketch menu. We have plane, text, and point. So we're going to see the plane, insert the plane into 3D sketch. In this case, we don't have a 3D sketch. What we have is a 2D sketch. So let's exit this sketch and show you what is the 3D sketch. When you go to the sketch here and expand the sketch, you have sketch, which we are already using, the simple 2D sketching, and you have 3D sketch. So we'll try to make a lesson on that. It will be almost using the same tools like in the sketch, but on 3-directional way. And also you can find the 3D sketch icon in the Weldment tools. So this is the 3D sketch. It is a very nice tool in SolidWorks that you can create in a 3D directions. So let's go to the sketch. Here it is sketch. We are back to our sketch here, and let's use the text. So in the text there is nothing special. Here is the curves where you can use the text. Let's select this line, so you have the line selected, and you can type the thing you want, and here you can make it bold color, italic, little rotation. So it is quite word work. And here you can in the middle or to the left, under or up, or to reverse. You need this reverse in case of molds or getting the negative. And let's click OK. Let's try the text on a curve. Let's select this curve, this line, right arrow to works. So you see the arc and line, they were selected, and you have your text on them. So So let's try to reverse direction. And when you are done, okay. So you are also able to make a text on curves. So the next option, we have the point. The point also is a useful tool, can be used to insert points, helping points in sketching or references or so on. For example, we can make a reference here. So we have this point is a reference. We can use it to draw a line, for example, from here to this corner. And also you can insert points on lines. So you can see that relation, the intersection relation shown. And as well you can add dimension for your points. Let's make a dimension from this point to this point. And also you can make dimension for points in space. So this is the tutorial about the text point in SolidWorks. Let's start a new sketch on top plane, and let's go to the next feature. We have trim. If you expand it, you have trim entities or extend entities. So let's first work with the trim entities. Let's create some intersecting lines. So now we have these three lines, and now we have the excess line in here and here. So let's try to trim that line to look better. You can use the trim. So in the trim you have 5 different types of trim. The easiest one to use is power trim. It is automatically detect your trimming object and do your trim. So to use the power trim, just keep clicking on the left mouse and make a line. So you are trimming, and again holding the left mouse button, move, then you are trimming. Control C. Let's activate trim. We have power trim. You can also trim both of them at once by clicking or drawing that trimming line. And the next one is the corner. Let's make Control C. The corner, this is from its name. You have to select 2 lines, then you're going to trim the corner to that corner. So let's again select this one, so we have that corner is trimmed. Let's make another line, trim corner, this line and this line. So you are trimming to that corner which you used. And you have different types of trimming. They are quite need some selection or some kind of special sketches, but the most used are the power trim, can do most of the job. So let's have an idea how to use trim away inside. We have these 2 edges. Let's make lines. Let's activate the trim and trim away inside, so you can understand from that or from the figure the type of trim. So let's select this line and this line. So we have this so you're trimming the inside. So Control C. So let's trim away inside. Select that line, this line. Now you are able to trim everything in between these two lines. If you select that, so you are trimming. Control C. Let's try the next type. Trim away this line. Select. So now you are doing the opposite. Trim away outside. And now you have the trim to closest. So make Control C. Trim to closest. So if you select that edge, so it will be trimming to the next closest edge. So this is about trim. And now let's try to use the extend. The extend is trying to extend your lines more. So let's have this shape. And now you have this edge is short, and we need to extend it to meet the second edge. You can use that with the extend entities. And now you notice you extended that line to be one long line. So you have your triangle. Now you can trim. Use power trim that edge. So you have your triangle. And also let's try to extend these lines. Extend, select that line. You extend it to the next edge. As well, this line. So I guess now it is clear the trim and the extend entities feature and sketching. Tutorial 15. Let's start a new sketch on the top plane. And in this tutorial we're going to talk about the convert entities, an important and time-saving tool in sketching. So to let you understand the convert entities working, we can try make some different examples. Let's try first make a sketch here. Can be any kind of sketching. So we have this sketch done. So let's exit from that sketch. So we have sketch 1. And let's try to make a sketch 2 on the top plane 2. So we have top plane, insert a sketch the same plane as sketch 1. And now if we have to make the same sketch as in sketch 1, either to start from scratch, draw lines and follow the paths. And if you have complicated sketch, it can be not easy work to do, but you can do that in just few clicks. So you can select these lines and then convert entities. So now we have two sketching that they are lying on each other. So maybe it's quite unlogical they're having two sketching in the same plane, but it is an example to show you how to convert entities, because it should have, in logical cases, you can be two planes parallel to each other and you want to make the same sketch on two different planes parallel together. But we still didn't take the lesson about inserting planes and drawing on reference planes, but this is the idea how you can use the convert entities to convert an existing sketch instead of drawing it from scratches. So let's exit this sketch. So we have two sketching laying on each other. So if you press that and click hide, so you have the second sketch still there. So also you can convert entities if the second sketch on a different plane parallel to the sketch. For example, we have that sketch on the top plane. Let's make the sketch on front plane. So we are inserting a sketch. Let's make it normal too. Now you are able to select these lines and convert them to sketch. Convert entities. Now let's rotate a little bit here. So now you have that projected line which represent the converted entities from sketch 1. So this is another example. And now also let's show you a different example. Let's extrude one of the sketches here. Okay, now let's just insert a sketch here. We didn't take that lesson, but let's quickly do it. If you select that face, you have the sketch or insert sketch on that plane. Now you are able to select these lines, or even you can select chain, convert entities. So you have these selected lines converted. So let's Ctrl C, select them again, convert entities. So you have that sketch on that face, on that 3D face. Exit. Let's try to hide the extruded or solid face. Now you can see you have two parallel sketches to each other. Tutorial 16. Let's start a new sketch on top plane, and let's take the next feature in the sketch menu, the offset entities. To use the offset entities, we have to create a sketch. So let's create rectangle, center point rectangle, and let's make fillet. Okay, so let's activate offset, and the offset is making is duplicating the existing sketch, making some sketch parallel or offset to it. And here you have the option add a dimension or to reverse the offset place, or by directional you can create sketch on both sides. So let's change the offset to be 2 millimeter, and okay, so you have created your offset. So it is time saving. You don't need all the time to create an offset. If you wanted, you can just use the offset entities. Now you can make an offset from one of these sketches or offset sketches. Let's uncheck the bidirectional and make base construction. Okay, so when you check the base construction, it make the original sketch to be for construction, and that one that you made, the one you will be used. So in the offset, you can create an offset and delete or make the original one as construction and start working with the new offset sketch. Tutorial 17, mirror entities. The next after the offset entities, we have the mirror entities. Is also a time-saving tool which is eliminating the time for creating a new sketching by using some type of mirror, as well as the convert and offset. All these are sketch manipulation tools. They are time saving and so on. For example, if we want to make the same sketch like this one to be on the opposite side, so that need some time to be created, but you can do it by mirroring this sketch on a mirroring line. So let's try to make a line here to be parallel to this edge. Escape. So this line can be a mirror line, so we can convert it into construction as well. Now we have a mirror axis, and let's activate the mirror, and here entities to mirror, you can select which part you want to mirror. So I want to mirror so let's make sure that we are in, and here you are selecting the edge you want to mirror, and here you have the mirror about, which will be the mirror line. So you notice that we made the same sketch mirrored on that line. Okay. The same way we can mirror the whole sketch. Just activate mirror entities and select the whole sketch by selecting box. Mirror about. So when you are done, okay. So we made a mirror copy from that sketch. So let's try to make another line to make it inclined, that like this. Let's convert it into construction. Also, we are able to mirror this sketching on that line. So let's make mirror, select this, and uncheck copy that line. Okay. So you see, when we didn't check the copy, we are having only one side to be used. So let's do it again. Mirror entities, select, make sure that you are not selecting the mirroring line, mirror about, and let's check copy here. So we'll have two copies, the original and the mirror. Tutorial 18, we're going to talk about the next feature in the sketch menu, the linear sketch pattern. Is also a sketch manipulation tool which saves times and creating copies and instances from existing sketch. Let's start the sketch on top plane. Let's make a rectangle, and let's make here circle. Okay. So one note, we have here the mirror and the linear pattern, but if you go to the feature, you have also the mirror and the pattern, but they are different because this one in the feature mode you are working on the solid or 3D parts, but in the sketch it's working on the 2D or sketch level. So let's activate the linear sketch pattern, and here is the x-axis is selected, the distance between the instances and the number of instances. So we selected 2 here and 10. Let's make the distance to be 20 millimeter. Increase the number of instances. So you see you are creating copies or duplicating that existing circle instead of drawing them all the time. let's set distance between to be 30. So when you are done, you can click OK. So again, let's try to make an instance on that direction. Let's activate the linear pattern edges. For example, let's delete this, select, so it is not able to select that direction. So now let's just here deactivate the direction one because we don't want to make it one. So now it is deactivated. Now let's make the direction 2 is the y-axis, and here the linear to pattern, clear selection, and select this circle, the number of instances, so we can make 6 instances, and the spacing 20. Here we can just delete this line, we need only the circle, and to change the direction you can click on that arrow, or here you can make the change the degrees, but on the arrow is easier to make that direction. So when you are done, click OK. Also, you have one option down, instances to skip. So for example, you don't need all these 6, you need some of them, so you can activate instance to skip, and you notice there is points shown in that circle. So if you select that circle, so it will be skipped. So now let's make another example. Let's make the pattern to be not on the XY or in the X direction or Y direction, to be something in between. So in this case, there's a angle manipulation. Let's linear sketch pattern. Let's select entities to pattern, this circle, and here you have the angle. You can set it into 30-degree angle. Let's make the instances to be 5, spacing 30. So you can flip direction there. So if the angle of 30 is not the one we need, we can make it 290. Here also you can change to the angle you want. Instances, you are done. Okay. So we showed you 3 different cases how to use the linear pattern. In the previous tutorial we talked about the linear pattern, and there is a different type also called the circular pattern, where you are able to make the pattern on a circular shape. So here we have the origin, it will be the center of the circular pattern. Let's try to make a circle here, and let's make some instances in a circle around that origin. Let's activate the circular pattern. Now you have that circular pattern around. Here we have the point 1, which is the origin, and the number of instances can change it here, either to use equal spacing or not, and you can also make pattern around 270-degree angle or less. And okay, if you want to make a circle pattern not on that center point, just make another circle pattern, and let's change the direction, the place of that center circle. Here you have the coordinates of the new circular pattern circle. Now let's make instances. Then they are done. Okay. Tutorial 20. In this tutorial we're going to talk about the next feature in the sketch menu. We have this sketch from the previous tutorial. Let's enter that sketch mode. Hit sketch. Now we are in that sketch. So here you have the move entities. Let's activate and move the entities we want. So let's select all these and all these as well. So we have all these entities selected. Now let's move them. So here from 2, let's activate the parameter of movement. So let's select start point, end point. So you are moved that selected entities to that point, new point. So again, let's select the entities. We can make Ctrl A, that we can select everything. Let's move entities. Start point is this one, and let's make the end point be, for example, the origin. So here we move our entities, but as you notice, we moved the entities, we didn't keep the original ones. So we have the copy entities. In this case, it keeps the original one. So entities to copy, either to select some parts from there or all the sketch. I'm going to select everything by Ctrl A, and now let's activate start point and end point. This is start point, and let's make another point. We can make a point from before to be a reference and selected. Even we can select that point. Now we have 2 copies from that. So it is also can do the work of linear pattern. In case the linear pattern didn't work, it was complicated to move some instances in some different places or direction. So this might be easier to make the copy and move as you want. Tutorial 21. In this tutorial we're going to talk about the rotate entities. We have this sketch from previous tutorial, and let's see how to rotate this sketch. To go to the rotate, in the move entities expanded, you have rotate entities, and entities to rotate. Here you are selecting the entities which you want to rotate. You can keep the relations. We talked about the relation before, and you have an idea how the relations are. And we are going to make a tutorial for relation as well. So let's select the outside edge. So we have the outside profile is selected, and the center of rotation, you have to select the center of rotation, the origin where your profile will be rotating. And I'm going to select this point. So let's activate this field, select that, and now we are able to rotate. So you can notice how you rotated. So now we already made that outside profile is an offset from inside, so that means there are some connection between. So let's try if I'm checking this can't fix anything. So now we remove the relation. Now we have no relations connecting that outside profile with the inside. So now we can continue increasing the angle until we get to the angle we want. Let's try 180, and here we have this rotation 270, and this is rotation. You are done. Okay, so now let's try to rotate the whole sketch. We can do that by clicking Ctrl A. Ctrl A, you are selecting all the sketch, and then rotate entities, and here the entities to rotate, they are all selected. Now let's check the keep relation, because in this case we will rotate the whole sketch. So, and now let's try to find center fillet of rotation to be this point. And now let's rotate it 120 degrees. When you're done, okay, so now you see you are able to rotate the whole sketch. The next tool is the scale entities. We have this sketch from previous tutorial. So imagine if you want to scale this sketch, drawing it with a smaller scale or bigger scale. It will not be easy to make all these sketches. It will take some time to draw that manually all the time. So you have, for this reason, the scale entities. Expand the move entities menu. Here you have scale entities, where you are able to rescale your entities. So let's first Ctrl A, select the entire sketch, okay, or Ctrl A again, scale entities. We have the entities we want to scale, they are all selected here. Scale about, we need to pick a center point. For scaling, let's make this point a center point, and the scaling, let's make scaling to be 2 times bigger. And if you check copy, it will keep the original sketch. So let's check copy here, and you notice here you have the copy, and also you are able to make instances from that. So we have now, you see the bigger scale shown, and click OK. So we have the original small sketch, and then we have the bigger size sketch. Let's Ctrl Z to undo, and let's try the other way to make a smaller scale. Scale entities, let's make 0.5, half the size, without checking the copy. Let's select the center point. You can select it somewhere in the space, and here you have your smaller sketch. So this is rescaling for the half size of your sketch. Also, you are able to rescale some part of the sketch with the same idea. Hello to another important tutorial in SolidWorks. We talked before that we're going to make a tutorial on relations. So in this tutorial we're going to talk about relation in details. We talked before briefly, but now we're going to talk about relation. This is the next feature in the sketch menu. So let's start a sketch on top plane, and here we have the relations menu. You have display, delete, relation. If you expand it, you have another options as well. So now we don't have anything here. Let's draw some random lines. So we have two random lines here without having any relation or any definition or relation. So for that case we can add the relation. So the relation, they are kind of defining some type of constraints in the sketch. So here, if you expand the display and delete relation, you have the add relation. Right now, if you go to the display or delete relation, we don't have any relation to show. So let's add relation first, expand, add relation. So now it's asking you to select entities. So let's select this line, and when you select that line, here showing you if there is existing relation. In this case we don't have any relation, the relation available to us to make. So we have the horizontal, vertical, and fixed. So if you select the horizontal, you will make your line horizontal or vertical. So you cannot add them together because they will be over-defined. So delete first the horizontal. Now your vertical relation is working. So when you are done, click OK. So let's activate the add relation one more time and select this line. So we have these two lines are selected, and here you have the available relations, either to make them horizontal, vertical, or so if you select vertical, you'll make the second line to be vertical as well. I'm going to Control C, and I want to join these two lines together. So I'm going to clear selections here, try to find another selections. You can select this point instead of the whole line and this point. So we have these available relations. So we want the merge relation, and then you are done. So without closing, before clicking on OK, you are able still to add more relation. So let's add more relation between the origin and this point. So select this point and the origin. So we have these 2 points selected. We have the 3 type of relation we can add. We're going to select the coincident. So now we have the center point and this line are intersecting. So when you are done, click OK. Now you can go and show the relation, display and delete relation. Here you see the relation associated with point 4. So here you have the entities to select, and if you expand it, you can select all the sketch or some options or selected entities. You can pick all the sketch. You will have the vertical and the coincident relation available here in this sketch. So now you're showing your relation. Also, if you go here with the glasses, you have an option to view sketch relation. So if you activate it, your relation will be all the time showing here. And if you have many relation, it can be kind of not showing the real sketch clearly. You can deactivate them and let them work when you want. So one last thing, you are also able to delete relation. Here you can display our delete. This one is selected and you see it here on the sketch. Delete. Also you have other option, suppress. For example, if you select this relation, is selected here, suppressed, and now you have this relation is suppressed. So that means it has no effect right now unless you're going back to activate it. So let's go back and display relation. So we have this coincident relation is suppressed. So uncheck this one. Okay, so your relation is back to work, and now you are not able to move it from the origin. Done. So let's show some other type of relation. Let's draw a circle. And okay, you can also add the relation without choosing this add relation option. You can simply select that circle, control, select this line, you have it selected, and here is the tangent relation. You can apply it. Let's draw another circle. There's also another way, faster way to do. You have this circle, select this line, and this small menu is appear. It's showing you some relation that you can add. So make tangent. Okay, so let's make another line here. Select this line, and here you have some of available relation. So if you make collinear, you have the collinear, and okay. And this again show the relation. Pick one of them, click delete, so you are able to delete from the keyboard as well. And again, you can move freely your entities. So I hope this tutorial was useful and that you understand more about relations, this important topic. In this tutorial, we're going to start working with the solid models or 3D modeling after we finish the talking about the important tools in the sketch entities. So before working with feature, it's better to have a good knowledge in the sketch entities and feature. So the basic to make a good solid modeling starts from making good sketches. So let's now start working with the features or solid features. So basically they are for creating the 3D models. So we have the extrude, revolve, sweep, loft, and so on. We're going to deal with all these features in the tutorials. So first feature is the extrude boss. So let's start making a sketch. As we know, let's make circle, rectangle, and let's make slot. We have three different profiles. Let's exit the sketch, or without exiting the sketch, you're still able to work with the extrude. So here is the extrude is activated. So now let's select extrude feature, and now you notice you are extruding your part. All the drawn sketches. And you see this arrow, this is a quick extruding option. When you select that arrow, you are able to expand it or change its direction downward. So it's kind of quick way to create extrusion. And sometimes you need to make some quick solid models without having exact dimension. So that is a quick way to make it. And now let's move to the left menu. Here you have the type of the extrude. Blend is just you can move it the way you want, and here you have other options. You have up to vertex. For example, if you have another body in front or other edges, you can select the vertex, and if you have a surface in front, you can also select that surface and up to body. But in this case we have the mid plane, you can start working with it. So if you pick mid plane, so you notice you have your extruded is in a mid plane. So if you select the mid plane, you notice the second direction is not activated because it is extruding in two directions equally. So let's make blend extrusion, and here you have the distance you wanted. So if you type 70, you have 70, the exact value you want, 80 or 50 as you want. And if you want to change the direction, you have the flip or this icon reverse direction. So you have on the other direction. So let's make it back there, and here you have the draft on or off. So when you are making extrusion, this first make okay, let you see how the extrusion looks like. Now you have this extrusion parts, and you can edit the existing extrusion. You can click on it, and here edit feature, so you are able to edit that feature again. So here you have the draft, you can apply some draft. So you can, let's make the angle to be a little bit there, 10 degree, so you understand this angular extruded part. So this is the idea of draft. And here if you select the draft outward, so you are drafting outward. Now let's continue to direction 2. You are able to make a second direction for extrusion the same way with the same options if you want to have a draft or not. So here we can make it 20, not necessary to be equal, and the draft you can make it 0 or deactivate it again. So now you have extrusion in two directions. Okay, so this is how it looks. So let's back again, continue talking about extrusion. Let's edit feature, and now here you have the selected contours. That means you are able to select some of the sketching to be extruded, not all the sketch. For example, we have sketch containing many profiles, but we want to extrude some of them. So let's select what we want to extrude. So it should be closed profile, and let's extrude both of these, and we have the options we already talked about. When you are done, click OK. Just we're going to talk about appearance, because I wanted to change the color in this tutorial, but I want to show how to change the colors before asking how this color is changed. So I want to show how this is done, because I will be changing colors in the next tutorials, so that will not be strange for you. So to change the color, you have this edit appearance menu here. If you click on it, so you'll be able to select the colors you want. So now here you are selecting the color for the entire bodies, and here select geometry. Here you have select part, and you have select faces. So if you select faces, you are able to change the color of the face. So let's here delete that part. Now select the faces you want, so you'll be able to change the color of that face. So now if you don't want to that face, you can delete it. So this is how you can apply the colors, and here you have the values, these colors, and so on. And here if you have surface, but in this case we don't have surfaces, and select bodies and so on. So the body is almost close to the part, but the body is selecting only one body, not the whole parts. If you select part, it's going to select, so it will consider all these bodies as one part, but in the bodies you are able to select these separated body. For example, let's now make green and make and select that body. So selecting that, change its color. Also, there is another way to change the type of the material. You go to the edit appearance in here, and here you have the appearances, plastic, so on. If you say and drag it, or just select body, select, double click, so you will be able to apply the appearance. So let's take this body, select the whole body, or from solid bodies, you can select it from there. Now you are able to change color. So this is a quick tutorial about changing the colors, because in the next tutorial, when we're going to continue to talk about the feature with when you have different colors, you know how we change that. So we'll select our main tutorials. We continue to talk about the feature in here, and that will be in the next tutorial. In the previous tutorial, we know that we can insert a sketch by selecting the plane and inserting a sketch. And here you're going to show another way to insert a sketch. Is not necessary to be on the main planes. So you can insert a sketch on any flat surface you can see. So we have these parts from the previous tutorial, and we have flat surfaces on the top of them. So if you pick that surface, you'll notice this sketch icon, the same when we are clicking on planes. So if you pick that icon, and notice here you have the exit sketch, that means you are on the sketch mode, and here you have your sketch features, which we talked about them before. So go to normal 2, and now you can sketch normally as we learned before in creating a sketch. So let's pick a center point here. If you hover over this line, you see the center point, and here is center point. So the origin, so make a center point rectangle. We are done. Okay, exit. So we have a rectangle on the top of that plane. But now if you select that surface, you don't have that sketch icon. Here you have edit sketch, means the original sketch engaged in that surface, which we made before for creating the extruding part. So this is not inserting a sketch. But if you select that surface, you have this sketch icon. Now you are able to create a sketch in that surface. So you can make it normal too by clicking on the icon. If you don't see it, you can go here and normal too. So you can make a circle in the middle of that. So if you are not able to see this center line, you can create a center line from here, make a circle, and you make it on the center of that line. If you want to add a dimension, you can do it. It's not the purpose of this tutorial. When you are done, exit. So we have sketch on that surface and on the top of that surface. So now it is important that you know we can insert sketches on surfaces which we are able to work with them further. So in the next tutorial we're going to talk about the extrude cut, and we're going to use these surfaces or these sketches we already created on these surfaces. Tutorial 27, extrude cut. We have these parts created in the previous tutorials, and we made also a tutorial how to change the colors and inserting those sketches, as you see also have been done in the previous tutorial. So if you didn't catch these ideas, you can review the previous tutorial. And now in this tutorial we're going to talk about the extrude cut. We will keep the revolve pose in the next tutorial. So we use the extrude cut because it have the same work like the extrude. And if you are familiar with the inventor making only one option for extrusion and cutting, so they are almost the same work, but in this extrude cut it is removing material. So let's activate the extrude cut, because that sketch was selected before, so now it's created a cut on that part. So the same, we have the mid plane cut, the same extruding feature. So let's try to make it through all. So it's going to cut through all the body. And if you make it blend, you are able to make a distance. If you make it a distance inside, click OK. So you have that cut. Let's edit again. Select it, edit feature, and let's select this time up the next. It will be the same work as through all. So if you make up the next will be that edge. So you have a preview here. And let's make up the vertex. You can select that vertex. So you will see in this, click OK. So you'll notice how that cut looks like. Let's edit it, and let's try to make up to surface. So we have this surface. Now we are extruding to that surface or cutting. So up to body, if you have another body in front of it, you can select that body to make that cut. So in this case I'm going to make it up to next. Okay, and we have this extruded cut. So now let's select that sketch from here, and then go to extrude cut, and let's try to make the same we did in the extrude. Here you can make an angle for drafting, so you see how is your cut looks like. And here the one is the direction 2 if you want to cut in second direction, but in this case it will not work because we don't have another side. So let's just uncheck direction 2. And the thin feature, you are making a cut like only an offset surface. So here is the distance. You can make it a thickness of 5 millimeter, and I have to make 2 direction or mid plane 2 direction, but in this case we will use 1 direction because we have only 1 direction for cutting. Now let's deactivate the draft to be able to see the cut here. So let's click OK. Now notice how you cut it in the part. Let's edit that feature. Let's deactivate the thin feature, and let's make it blend with. Okay. So if you couldn't be able to edit the cut because of some closed feature, you can delete, right click, delete, yes, but you still have your sketch there. Extrude cut, and let's see the selected contour. The same idea like in the extrusion, you have this contour, you can select it, and you have all the bodies or selected bodies. For example, if you have different bodies, so you can cut through one body, not all the bodies. So we will try to cover this example. Now let's just make that cut. Let's insert a surface on that part as we learned. Insert. And now let's use the convert entities. We had a tutorial in the previous tutorials how to use the invert to convert, and now it is an example to how to convert that surface, that profile. So now we converted that circle into profile. Now you are able to extrude. So let's extrude it, and here have the merge result. So this is another thing we didn't cover, but now it is shown because you have different bodies. So if you select the merge, it will consider all the part as one body. So let's now keep it merge. Okay, here notice you have 3 bodies, this one, second one, and third one. But let's edit the feature here and uncheck the other one. So you have now SolidWorks consider that as separated bodies, and now you see 4 different bodies. So let's insert a sketch on that surface. Let's make a circle. Okay, let's go to extrude cut, and we said we want to show you the selected bodies, either all bodies or selected bodies. So now let's make it through all selected bodies and uncheck that one. Here you can select, so you can select that body. Okay, so you'll notice the cut only in that body, not all of the bodies. So I hope now you understand more about the extrude cut and extrusion and the other options in there. In this tutorial, we're going to talk about the Revolve boss feature in the features menu. We have these sketches from previous tutorial. Now let's show you what the meaning of revolve. So revolving is to revolve a sketch around an axis. So let's select that sketch, revolve. Now you have the selected contour. Either we can revolve all these sketches or one of them. So let's select the axis of revolving. We select that axis. So you have all the sketches are revolving around that axis. Click OK. And now we have a rebuild error. So let's now try to fix it with making selected contours. So you have to be a logical type of revolving. So now we revolve that part with selected contours. You learned about it in the extrusion. We learned how to use the selected contour. So okay, so the revolving is working. So you have to think about the type of sketch you are going to revolve. So let's make Control C and activate revolve. Select the sketch and this time use this axis. So now let's try. Click OK. So this time the revolving, all the sketching is working because it has no zero thickness inside the material. So you have to think about which type of sketching are working and which type will not work. So now you have this sketch. They are solid parts and you can make like pipes. Let's edit this and continue about revolve. Here you have the selected contours, or you don't have the thin feature activated. So let's make Ctrl C to undo. Select the sketch, revolve around that axis. You have thin feature. We already talked about the meaning of feature. Thin feature, let's make 20 or 3 millimeters. So we have these kind of pipes. So now let's try to make an angle here, 270. Okay, so we have an error. Let's try to build it again. Revolve. Select thin feature. As you notice, it didn't work with the center rectangle because that will generate a zero thickness feature. So we can fix it with selecting contours. Select that contour and that contour, and that's it. Let's make an angle of 220. Okay, so this is an important issue in SolidWorks, to be able to understand the logic behind your shape and what parts are not logical to be done and creating errors. So now select OK. So we have these pipes created by Revolve boss. The next feature, the sweep boss. The sweep boss is need to sketches the profile and the path to sweep your sketch. So let's first make a sketch on the front plane, and let's make circle and exit that circle. So we have the circle drawn on the origin, and let's make a path for sweeping that circle. So think about the path should intersecting with that circle and be perpendicular to that circle. So let's select the top plane. So we have that plane is perpendicular to that circle, and insert sketch in that plane, normal 2. And here you can start the path for sweeping that circle. So we make it lines. So let's now activate the sweep. We also could use the spline. So the path here is selected as sketch ribbon, and the profile we can select that circle. So we sweep that part. And the option, you have different option. For example, keep normal to the path. So in this, so you have this normal to path. So let's edit that feature again, and you can twist along the path. So for the twisting, you need some kind of angular path to twist around. So let's go to the guide curves. So in this case, you have only one curve, so it will be enough. If you have different curves, you can select from here. It's quite advanced, and then OK. So let's make undo and started from before. Let's edit that sketch and make that line to be, let's remove that horizontal relation, as we know how to deal with that. Make that line to be kind of inclined. Now activate the sweep, the profile, the path. So now you change that way of sweeping. Thin feature, you already know about it. OK, and here you have your sweep path. In the previous tutorial, we created this part with the sweep boss. But what if you need a different thicknesses around the sweep path? For example, you need that radius to be bigger than the rest of the parts. So you can make different type of sweeping or lofting with this feature, the lofted boss. So for creating lofted boss, we need to have different sketches on different planes, so that we can be able to insert or loft between them. For example, you can imagine this part, this sketch is on that plane, and that edge on a different plane, and that is on a different plane. So that means we need to insert planes. So in this tutorial, we're going to talk about inserting planes. So let's start a new part. And here you have the reference geometry icon. If you expand, you have plane. So let's try to make 4 planes parallel to the top or front plane. So select the front plane, plane. So now you have this menu. So these are the reference to create your planes. You will be able to use them in the future when you are start creating parts and so on. So you'll be able to have different type of planes, either to make it perpendicular to that plane or parallel or coincident. So I want to make it parallel and make a distance of 80 millimeter, and if you click flip, you're reversing the direction. And number of planes we want, we can insert 4. So you have 4 with the front plane, and if you have other parts or references, you can select them to insert the orientation you wanted to your part. So when you are done, click OK. So now we created these planes and ready to insert sketching on them, exactly as inserting on front plane and so on. So here you notice these planes, the created planes, they're having the same icon like these planes. So in the previous tutorial we start learning sketching on the original planes, and then we learned how to sketch on the parts or surfaces, flat surfaces on the parts. Now the third case of start sketch is on inserted planes, so that we will show you in the next tutorial and have example of the lofted boss. We inserted those planes in the previous tutorial, so now we will use these planes to insert sketching on them. So to use the lofted boss feature, so select the plane from here, sketch. So now you are able to insert a sketch. Let's sketch a circle, exit sketch. Also you can select the plane from here and insert a sketch exactly as the original sketching normal tool, or you can keep that view and create rectangle. Okay, select that plane. Let's first exit that sketch, select that sketch, and let's again insert another profile or circle, that origin. And okay, exit sketch, select another one, sketch, let's make a rectangle, exit. So now we are able to work with the lofted boss. Let's activate lofted boss. Here are the profiles we need to loft, so you can select them from here. So you notice now you are creating a loft, but here there is something. When you are dealing with the loft, you have the orientation points. So sometimes you need to manipulate these points, because these points are changing the twisting of your loft. So let's make this loft, this point here. So now in this case it worked, and let's change this point to another place. So it didn't work. Let's try here, and let's try to put it in that corner. So you notice the difference lofting according to these twisting points or the guiding points. By changing to that part, when you are done, you click OK, and here you have advanced option to use a guiding curve as well. So you have points, also you can use the guiding curves, but we can make it in the next tutorial. And now click OK. So you created these shape or verse with the lofted boss. In this tutorial, we're going to show you a trick in changing the order of your work or feature. So everything you create in SolidWorks is arranged in orders. For example, we inserted these planes. So we have these planes here, and then we work with the loft. So the loft is after the planes. And you cannot, for example, start the loft without the planes. So the loft is coming after the planes. But now let's try to make another example for the loft and showing you as well the order of working. So we want to make a profile to be lofted not on a parallel plane to these planes. So let's find top plane and insert a plane reference to that plane. So you can make this as 170 to let the loft be able to be created. Now let's insert a sketch on that plane, normal 2, and let's make a circle here. So you have to be logical in your not making a circle here, so that can be difficult for the loft to create that. So let's make it here, circle, exit sketch. So we have a profile here. So notice we insert the plane 6, then insert a sketch, so there is an order for your work. So let's now edit the loft here, edit feature. In the profiles, let's add the created profile, but if you look here you can't find that profile. So it is, if you even expand this tree, you are not able to select this sketch because the order is not in the right way, because we created that sketch after that loft. So logically that loft will not see that plane. So in this case we can show you this trick to drag these features to be before the loft. So you do that, select the feature you want, and notice you are able to place it before the loft or in any place. So when you are working with this type of changing order, sometimes it will not work due to some relations and complicated figures and so on, but this case it is logical, it will be working because there is nothing can prevent change that order. So now we have the plane 6 in sketch, order it before the loft. So let's edit that loft, edit feature. So now you are seeing that profile. So let's select it also with the rest of the profiles, changing the point that it will work. You are done. Okay, so here we have this lofted part. So in this tutorial we learn how to change the order in order to make some more feature to work. And in lofting you can also loft a profile, is not necessary to be parallel to rest of the profiles. Tutorial 33. In this tutorial we're going to talk about the guided lofted boss or the advanced lofted boss. We have this profile created in the previous tutorial when we inserted planes and the sketches. We turned the planes off, that they are hidden. So here is show and then when you click on the glass hide, we hide the plane, so we'll be able to work on the sketches. So now we want to make a guided line so that the loft will going to follow. So let's insert a sketch or a guiding line on a plane that is passing through them. So we choose top plane, insert sketch, number 2. So now we can start making a spline intersecting with these profiles. And if you found it kind of tricky to intersect with the profiles, we can try to project or convert the sketches. So convert entities, and then you convert them into construction. So now we have a reference for the sketches here. So now let's insert a spline in the shape we want. This is intersecting with the profile as we see here. So when you're done, right click, select. So we have our profiles and we have our guiding curve here. So let's exit sketch, activate lofted boss, and here let's select the profiles. Let's be sure that we selecting it. Okay, so this is the original lofted boss without any guided curve, and here in this menu the guided curve, let's activate it and select this curve. So when you are done, you will see the results. So you have the lofted boss follow that guided line. So let's try to insert another guided line. So let's edit this sketch, and here we have another spline. So now we have two splines. You can decide the shape how you want and make them, but here we show you the idea of the guided lofted line. So exit, activate the lofted boss, select the profiles, for the guided line select this one, click OK, and then select the second one, OK. So you have two guided lines and it works as well. So this is the idea how to use the guided lofted boss. In this tutorial we're going to talk about the hole wizard feature. We have this part from the previous tutorial, and let's try to activate the hole wizard. And when you activate the hole wizard, so it will guide you to create your hole with its size, type, and standard. So here when you activate the hole wizard, you see the different types of holes here, and the standard which you're going to pick. I'm going to keep it ISO, and here also the types of holes, the size, the diameter, and so on. So let's select this type, and when you select the type, select the standard, and then here you have the size. So it's like to make it M6, it means diameter of 6 millimeter. The fit normal, here either to use it through all blend. If you choose blend, then you have a distance to add. So now, after choosing the type, dimensions of your hole, next you go to positions, where you can select the place or position of your hole. So here we can pick a hole, and then you can try to make 2 holes here or 4 holes. And then when you are on position, you can start the smart dimensioning. This is an important step to add a dimension to position your hole. So I'm going to add 25 here and 25 on the other side. So also the rest of the holes. So now we added the dimensions to all of the holes, so we have our holes in the accurate places. So when you are done with dimensioning and the hole positioning, then click OK. So here we created our holes. Also, there is another idea that you can use with the hole. You can create one hole, and if you have many holes, like 10 of them, you can use the linear pattern to make different copies or instances. So in the next tutorials in the future, we're going to use the linear pattern for the feature level. Tutorial 35. In this tutorial, we're going to show you some functions for displaying your product or viewing your parts. So that might help you in modeling and seeing some type of feature which are hidden inside. So here, if you hover here, you have display style, and when you expand it, you have different type. So you have shaded. Now you have your product with that shading line, and here you can have it without any color, and this one is helpful to show you the hidden line inside. So show you here the holes and the hole inside this vase, and last one is showing you the inside with normal lines. So this is the display style, and also there are the cross section view, which can make a cross through this part. So activate the cross section, because we have the right plane is selected, so you'll have cross section through the right plane, and in the arrow you can move that cutting plane. So you are done. Okay, so you have a cross section, you can see inside the part. So let's deactivate, and now let's try to select a different plane. So we have these planes created before. Also, you can select one of them, and on the arrow here you can move and see, for example, the thickness of the hole through this face or anything else. It's a simple way to use the section view. So when you are done, uncheck it, so you are back to your normal view. In this tutorial, we're going to talk about the next feature, Revolved Cut. So it works the same way like the Revolve, but this feature removing material. So let's create a sketch on the right plane, normal to, and let's make center line from to be the revolving axis, and let's make or draw so we have this profile we draw, and we're going to move the material from inside this vase by revolve cut this profile. So let's go to revolve cut. So need to close the let's add another line, sketch line, let's go to revolve cut, and here you can see the cut. So let's change the shading. Okay, so you can see the cut inside this material. Also you can create a cross-section cut or cross-section view. So here you see the cut inside this vase. And section view onto, so here we have the vase. Sweep cut. The sweep cut is working on the same base like the normal sweep, but this one is removing material. So let's try to make two profiles, as we know from the sweep, one for the profile and one for the path. So let's insert a sketch on that plane, on that surface. Let's make a circle, exit, and let's make another plane or another sketch to represent the path. So here we have this top plane can intersecting with this profile. So let's insert sketch on that, normal to, we can have the cross-section view. So let's try to find a path. So let's start from that point. So we have our path here, but we can do one thing else. Control C. We have this line is from the face edges. So let's try to select this and convert entity. So we have this curve already done. So after projecting this edge, so let's exit this, and now let's try to sweep cut this. So we have the sketch is selected and the profile will be this one. So we created that cut inside the face. When we are done, we can expand. So we can have a look by changing the view style. So we like having a water bath inside this vase. So this idea can be developed further for more creative idea. So let's change the view style. The topic of this tutorial will be the lofted cut. So let's show a cross section of this vase, and now we have that revolve cut inside this vase. And maybe someone saying he want to have a better cut, more smoother cut than this one. So let's try working with this. So working with this vase will give chance to try some techniques for learning as well. So not just showing the lofted cut and that's it. So we have here some inserted planes. We can try also to use them as well. So let's show them. And here we have plane here, a plane here, and so on. So what we can do is select that plane, insert a sketch, select that circle, convert entities. So and let's select that plane, insert a sketch on that. Let's show the inside circles. We can convert entities this circle. So we have a problem here. This is open. So Ctrl C. We can instead select that circle. Now let's move to the next plane. Insert sketch. This one we can select that circle. Convert entities. Select that plane and that circle. Let's first insert sketch. Select circle, convert entities. So we have 3 or 4 different profiles on 4 different planes. Let's show, change the space style, make cross section. Okay, so let's now try working with the lofted cut. Let's select that one, that one. So we have more smoother cut in here. So we fixed this area here, but still we need to make more smoother cut in here. But now it is clear how to use the lofted cut, and in the next tutorial we showing you how to use the guided lofted cut to try to include these areas as well. In the previous tutorial we used the lofted cut to make that smooth cut inside this face, but still we couldn't cut through these rough edges here because the profiles didn't pass through this. So we'll try to fix this issue by using the guided loft cut. So now let's insert sketch on a plane that intersecting with these profiles which we created in the previous tutorial. We have the top plane, so let's insert a sketch on there, and let's try to first delete that cut or this loft. And start from scratch. So top plane, sketch, select spline, so in this case we are not sure if that spline is passing through. So we can try do is to convert entities. Let's delete this one. Select these profiles, and here convert entities, construction, so here we have some reference segments which we can use to insert our spline. So let's try now. Move spline, so we are done. Exit this now. Activate the lofted cut, select the profile, and the guided curve to be this. So we also can add on the other side, but for now let's okay. So we tried so this cut might be look smoother. So this is the idea how to use the guided lofted cut. Tutorial 40. In this tutorial we're talking about the fillet. In the earlier tutorial we used the sketch fillet, and here we have the other front fillet which is dealing with the 3D models or solid parts. So let's first hide these planes, select them, hide. So the fillet, let's activate the fillet. So you have different types of fillet. You have a constant size, variable size, face fillet, full round fillet. So in this tutorial we're going to talk about the constant size, and the item to fillet, and then you will have the radius of the fillet. So let's make a radius of 4 millimeter, and there if you have, you can connect or connect radius, so it's kind of manipulating the circular, making more curvature while using these. So I'm going to keep it with the circular, and let's fillet this edge. So by selecting it, you'll be able to fillet all that edge. You are done. Okay, so let's try also make a fillet for that edge. You're done. Okay, so you have a curve. You are able also to add a fillet to it. So now let's try a different case. Fillet. So let's select that edge. Now you added a fillet to that continuous edge, and we are done. Okay, but if you have many edges and keep selecting all the time, might be taking some time. Control Z, let's undo with that fillet, activate it again, and here you have the face fillet. So in this case, you are able to select two faces. This is a face and second face, third face, so you see the different colors. So this is also a useful tool for creating a face fillet. In the previous tutorial, we used the constant edge fillet to fillet this edge, but as you see, the fillet, it doesn't look that smooth. So let's try to find that fillet and delete it, and try with the variable fillet. So we can try to make that fillet to look better by using the variable fillet. Let's activate the fillet, and here you have the variable size. So item to fillet, let's select that edge, and when you are selecting that edge, you will notice there is point shown in that edge. So these points you are able to select and add the fillet radius on that. So let's select that point, and here when you click, you are able to add the radius. Let's add 1 millimeter here, and let's select that one and add a radius of 5 millimeter, and we have here 5 millimeter. Let's add 10 millimeter. So double click here, let's add 5. Select that point, let's add 5 millimeter, and this one add 1. So we have now created our variable radius. You can also manipulate a little bit here. So let's increase 30, and here we can add 20. So you see that no preview, that means that fillet is not working. We might add here bigger fillet 5. It's not working. 22. So now we created that fillet. When you are done, you can click OK. Also, you are able to add more points by selecting this number of instances, and here the selection smooth transition. If you change it to straight transition, it might not work because it's going to be a straight on that curvature edge. So let's keep it smooth and add some more point. So we have 5 points. So when you're done, okay. So now you have your rubber fillet. The next type of fillet, the full round fillet. So if you expand the fillet, you see here the full round fillet. So when you click on that, it will require you to select 3 sides. So now let's try with this cylinder. You have to select 3 faces that can have chance to be rounded. So this is second face, third face will be in the bottom. When you are done, click OK. So now we created that ball by making this face round, full round. Now let's try here. Select that face, the second face, third face here. So you are making full round edge by that option. So now let's try with the hexa polygon. Let's try to select that edge here. Let's try make 2 edges, 3 edges, third side here. So if you notice we didn't get any preview, that means these edges are not allowed to get rounded. So to unselect some of them, you see that dot, you can click on that, then you unselect it, and here you have that edge. I'll right click delete or click on that point. Now we have the full round preview. So when you're done, click OK. So you can try to make it on the other side. This is first edge, this edge, third edge, this edge, third here. We have no preview as well. Let's try to unselect some of the edges. Here we have preview. So we make it another rounded fillet, but it changed the shape geometry. So let's try to delete that edge and select that edge instead. So here we have that full rounded fillet. Hello to new tutorial in SolidWorks 2014. Let's start a new part. Okay. And let's create any sketch. Let's make a block, extrude it, Okay, so we have this block. In this tutorial we're going to talk about the chamfer. If you expand the fillet menu, you have the chamfer. So when we are talking about the chamfer, you have to remember three types of chamfer. You have angle distance, distance, and vertex. So angle distance, you have to specify the distance and the angle. So let's put here 30 degree and choose that edge. So here you will notice the distance here is 10 and this angle is 30 degree. Change it to 60, so you will change that degree, that angle to 60, and that distance is 10. So here is the first type of chamfers, where you are able to make an angle distance. Let's go to the next type. We have distance. So it is almost the same results give you, but here you are using the distance instead of using the angle. So if you select this one, so you made here 5 to 10 distance, and that means you have an angle of 30 degree if you remember in math. So this is if you want to make it distance to distance, make it 15 here. So you see here you have that distance, horizontal distance is 15 and the vertical is 5. Okay, so let's try to make the next type of chamfer. We have the vertex. So in the vertex you have to specify three distances. Let's make the first distance 5, 10, 15, and select that vertex. You see you created that chamfer in that corner with these three different values. And now let's try to fillet it or to chamfer the whole face. Let's make a distance to distance 5 to 5 and select that face. So you notice you are able to select one edge, not the whole. Face. So now let's try it in that face. Click OK. You're not able to chamfer a face as the case of fillet. That means you need to select edge by edge. The next feature, the linear pattern. So let's create a hole here to work with it. Hole. So let's select that simple type and let's make it 5 in diameter and make it through all. Okay, so let's select position here. Okay, so we have that hole is created. Okay, so now let's try to make this hole along that edge and that edge. So if you want to make all the time this hole, repeating it all the time, so it might take some time, but in linear pattern you can make many instances. So here feature to pattern is already selected, the hole and the number of instances, let's say 4, and here you can select the edge or the direction. Okay, so let's make this 5 or as you want, and here you have the distance Now you created 5 holes. You can change the distance and so on. And when you are done, click OK. So if you want to repeat this pattern as well on the other side, you can do it as well. So let's click on linear pattern. You have this feature is already selected. Select that edge and make the distance of 30, or let's make it 10. Okay. So now let's try select this hole and make it on 2 direction, pattern it on 2 direction. So let's select linear pattern, select that, and we have 5 here. You can see it, and then you can select the direction 2. You have the second direction, and then you are able to select that edge. So let's make the number of instances to be 10. So you'll be able to see these 210 on that direction when you are done. And now here, if you go to instances to skip, for example, we are in direction 1, direction 2, you are able to skip some instances. For example, we have these are already repeated, so you can just click on that dot, so you are able to skip these instances. So when you are clicking on that dot, you are skipping from repeating that instance. So that's it. When you are done, click OK. So you have this button in 2 direction. So we made this the previous process in one step, 2 direction at the same time. Now the next feature, the circular pattern. We created this disk for showing you the circular pattern. Expand the linear pattern menu. Here you see the circular pattern. The circular pattern is doing the same work like the linear pattern, but on a circular reference. So let's try to find the reverse direction, but here you can select the edge, any circular edge or cylinder. So for example, you have selected the edge. If you select that face, you are also able to select it, and if you select that face, you are also able to select. Now we have the angle for revolving or the circular pattern. The number of instances, let's try to type 10, and here you have equal spacing. Feature to pattern, we select the cut, that slot cut. So now we created 10 instances as you see in the preview. And here, if you go to the skip instance to skip, the same idea, you are able to skip what you don't want. When you are done, click OK. So now let's try to make a linear pattern for that and make it on the other side. So let's try to make an edge. So sketch there. Let's try with the line. The line might not work, but we have a line. Let's make a linear pattern. Select that edge, so we have that line is selected. The feature, make 2. The feature to linear pattern is circular pattern. So here you see you created that pattern. Increase. So you see that pattern is created there. For example, we can make the reverse direction, and the feature to pattern, can clear that and select only that cut. So let's increase distance. So here, right, 225. Okay, so we made that line, and we made from that line a linear pattern. So now we can create a circle pattern to make that slot here around the second half of this disc. So let's click on that line, edit it, and convert it into constructional. Okay, so now let's circular pattern, feature to pattern will be that linear pattern, number of instances 10, the reference will be that edge. So we can increase the number of pattern, so to 10. So now we are able to create that disk. The next feature, now we will take the mirror. So let's activate the mirror, and now I will show you one idea in using the mirror. The bodies should be connected to each other in order the mirror to work. So let's find spread plane. More about it, let's insert plane, reference to that plane. Okay, delete. Let's make the distance. Okay, so now we have that plane. Activate the mirror, feature to mirror. Let's select that body, the plane one is selected, click OK. So you'll see there is an error in that, or warning in that mirror, and you don't see your mirrored part. So let's try to make a sketch here or in that plane. Let's make a circle, extruded, mid plane. Okay, so now we have this cylinder. It should connect the mirrored part. So let's delete that one, or we can do something, we can move that here. Now you can see here you are able to mirror that disk. Now you can see that you can edit the mirror, we can mirror the other stuff as well, you can mirror the circular pattern and so on. So here you can see your mirrored part. In this tutorial we're going to talk about the next feature in this menu, the curve driven pattern. So from its name, that you are able to create pattern according to some drawn curve. So we have this plane inserted here. Let's draw a disk on it, normal to. Let's select line here, feature, extrude, pin feature. Okay, so we have a disk here. Let's make it thinner. Okay, so now let's insert a cut on that shape, on that disk. Insert, let's make a rectangle this time. Feature, extrude cut, Revolve. Okay, now let's make a curve with the spline. Can make the shape we want. Okay, so we have this curve. You can edit furthermore. Okay, so let's activate the curve circuit, the curve pattern. We have sketch 7 is already selected, which is that spline. We have the number of instances. Let's make it 10. The distances will be 10 as well. Feature to pattern, we can select it from here. If you are not able to select, you can go and find it. So here we have this pattern along that curve. Make it clear. Let's increase the distance to 40, and let's make the number of instances to be 30. So it's quite memory consuming, but now we are able to create that pattern along that curve. So here we have, can also edit and make it for construction. Okay, then set. So now you see when you convert it to construction, it didn't work. Just again edit the sketch. Stick that line, make it normal. Back again. Can do is to hide that sketch, that plane. Here you have your circular or curve pattern. In this tutorial, we're going to talk about the next type of pattern, the sketch-driven pattern. So let's remind you with this part, what we have done so far. We created the circular pattern and then made a linear pattern, and again circular pattern, mirror this part, and created a curve-driven pattern. So this time we're going to make a sketch-driven pattern. Let's click on that surface, insert a sketch, normal to. So in order to make a sketch-driven pattern, mostly it should be points. So the pattern will be following that point in this sketch. We have a point. Let's create some points here where we want to see more cutted rectangles. So we couldn't cover this part with the curve. Now you can select the sketch driven pattern. Now the place of the point will be the new pattern parts. So when you are done, so we have that sketch here. Let's exit that sketch. So we have sketch 9 containing these points. Now let's go to sketch driven pattern. You have sketch 9 is already selected, feature to pattern. We need only that rectangular cut. Now, so let's find it. Here you have it here. So let's activate this part, select that. Now notice you created rectangular cut on this point you made. You are done. Okay, so here you see your sketch driven pattern. In this tutorial we're going to insert a new coordinate system. You know that the origin here is the original coordinate axis of the SolidWorks, where it starts from point 0, 0, 0, but sometimes you need to insert coordinate system to be a reference for some sketches that we're going to use the coordinate system in the next tutorial as an example, how to use it as a reference. So let's try to make a block here. If you look here, this is point 0, 0. I'll give it some dimension to be 100 by 100 by 100. Now let's extrude it. Okay, so in principle the origin is in that point, but now let's insert a new coordinate system. To do that, go to reference geometry, coordinate system. Now here it'll ask you to choose the new origin, so let's pick that origin. Now you see the new coordinate system. This is the X, Y set by default, but here you are able to select another. So let's select this to be the X, Y be that one but on the reverse direction. So here we have X and Y, and Z is fine here. Okay, so here you have a new coordinate system. We're starting from 0. So you will wonder how you're going to use that. In the next tutorial we're going to use the table driven pattern, and the coordinate system will be helpful in that case. So see you in the next tutorial. In this tutorial we're going to talk about the next feature, the table driven pattern. In the previous tutorial we showed you how to insert this coordinate system. So if you didn't attend that tutorial, it is good to see how we inserted that coordinate system. And now let's activate the table driven pattern, and here you will notice it will ask you for a file to read from. So now if you browse, the types you will need is a SolidWorks table or text file. So in this case we're going to use the text file. I'm going to open a text file to show you how it would look like. So here we have 3 different points. So these have coordinates 1 to 2, x1 and y2, 20 to 10, 30, 50, and let's add. And if you remember the dimension of this block is 100 by 100. So let's try to be inside this range, and this one let's make it 40 by 80. The next one let's make it 0 by 60, and another point let's make it 60 by 0, and the last point can make it 80 by 80. So let's save it, close here. This is back to table driven pattern. Browse, let's find our file. Here we have it, and now SolidWorks inserted these points exactly the same we wrote. Now here the coordinate system, you can select this is our coordinate system, and here notice the new points, point 0, it will turn into 50 50, which is the original coordinate system values without this inserted system. Now, and the rest will be the same. The feature to copy feature. So now just cancel this for now and create a feature to be pattern. Just draw cut here. Okay, now back to table driven pattern. Browse for the table. Coordinate system will be picked from here or from tree. If you look here, you will see the points which we picked. So here is, for example, the 60 by 0, and here 0 by 60, and so on. So here are our points which we made them here. So just click OK, and now you made that point or that interesting pattern according to the point you made. So I think this type of pattern is an interesting and can open the door for more advanced sketching and modeling. In this tutorial we're going to talk about another interesting type of pattern, the fill pattern. So from its name, it is filling an area and make it a pattern according to that selected area. So either it can be a sketch or a face or whatever. So let's try to activate the fill pattern. Here the fill boundary, let's select that face. So now this face will be the filling boundary, and as you notice we have these holes from the previous tutorials. So let's see how it will be. Now we have the type of arrangement of the pattern, the feature to pattern. We can select that cut from here. So here you notice that it filled that empty area, but it didn't interact with the already found cut. So this is the type of arrangement. You can change it to be circular or more arranged, so on. And here you can make the distance between the instances. So let's keep it to 0. So this is the fill pattern. So when you are done, click OK. type Ctrl C or delete that one, and let's try another fill. Let's create a sketch here and make a slot here. Okay, exit. Let's go to the fill pattern, the fill boundary, select that sketch. You are able to select it. Now the feature to pattern, let's select that cut. So you fill it that slot with this cut, so you can make distance between this and here. You can make 2 that can increase or make 20 to decrease the number. So it is up to you how to make it and how you want it. So you can play with these values until you get your required pattern. So the idea is that you are able to select a sketch created from that face, not the whole face. When you are done, okay. The next feature coming here is the rib, but we will keep the rib for the next tutorial because we will show you how to use the draft, then the shell, and then there will be a need for the rib to support the draft and the shell we created. So let's try to make a box here. Very quick box, extrude it. Okay, so we have that box. So now you are able to make a draft. If you remember from the extrusion, you have the draft angle that you are able to create an equal drafting sides from all the sides. But with the draft, you are able to create a draft in some parts, not in all of the faces or edges. So let's click on draft. Here the neutral plane and faces to draft. The neutral plane is the neutral plane method, which you are selecting the plane which are not going to move or any change, and faces to draft, let's select that face. So the draft angle, let's type 10 to be more clear to see, and here you have the direction of the draft. So in this case, draft outside. So let's click OK. You see we made a 10-degree draft on that edge. Let's edit that feature. Click on that arrow, reverse direction, so it will be a draft inside. So here you have this. So also you are able to select many faces. You have the neutral face, you have only one face to select, but in the faces draft you can select 2 faces, for example, or many faces. And let's click OK. So you drafted these 2 edges 10 degrees. So this is the neutral face draft. In this tutorial we talk about the next type of draft, the parting line. So we have this draft from previous tutorial. Let's delete it. Yes, and now let's activate draft. The second type is the parting line. So if you understand the idea of the neutral plane, which we have that neutral plane and this draft plane, and that would be the parting line, which is separating between the plane. So either to select the neutral plane or parting line, and then you will be able to select that direction of the pole. Here you can select that parting line, you can select that line. So here you are going to create a draft of 10 degrees. So if you click inside, if you click OK, you will get that inside. So let's edit it, and let's reverse this drafting, click OK. So we created that outward draft. Let's try it again. Draft. So the pulling direction, that is the line which is going to change in the angle, and the parting line, which is going to be the, if you imagine the hinge, so that will be the axial of the hinge where this face going to rotate, or that line going to rotate. So parting line, let's select this, move that face outward. So this is the line of the hinge or of the door axial. So imagine that as a door. So select this as parting line. The direction of the pole, imagine that will be moved outward. So this line going to move that direction in 10 degrees. So pulling line, you will see, and here is the direction. Let's make it 30 degree. Okay, you make a 30 degree inside draft. To change direction, click on that, you make it outward, outside. So here you have the parting line idea for creating drafts. The next feature, the shell. We have this box with different drafted edges. We have created that with the draft from the previous tutorial. So now we made this type of box. So let's make a shell. The shell is to make a hollow inside that box. So if you click on the shell, make the thickness of your box, let's make it 4 millimeters. The face to shell, you can select that. You have the shell preview, you can see a preview for your shell. So, and you can make it outward. So you will keep the same volume you have and just creating a shell outside. So here you have your box ready. So this is the shell function to create this hollow shape and boxes. In the previous tutorial, we created this plastic box, and as you know, the plastic box have, or covers have, rib inside to support them, because this box with this design might be not very strong, and here come the function of the rib to create a supporting parts for your boxes or other products. So you need first to create a sketch for your rib, and from there you are able to create your rib. So let's try to make a rib in the middle of that box to support these walls. We can pick this surface, insert a sketch, and let's pick a line normal to find the center point here. And if you go to the feature, you'll find the rib is activated without exiting the sketch. that means you are able to work with rib. So now that line is ribbed. Here you see the direction of the rib and the thickness of supporting rib. If you want to change the direction, you can click here, or you can click on that arrow. So let's see if we will get the right direction. So it's not, so you select, it should be normal to the sketch. So we have that sketch. So now we should flip downward. Okay, now you have that rib is created, so you know the idea or the meaning of the rib now. So if you want to make another type of rib, to make it on the side here, you can do it either to insert a reference plane in the middle. So let's see if you have a plane is pathing from the middle. We have the right plane. Let's insert a sketch in there and make a cross-section view. Okay, normal to. Here we have this cross-section, and let's draw a line. Try to find place for that rib. Okay, now let's go to rib. You can see the shape and the direction of the rib. So I think now it is on the right direction. And here you have different type. You have from one side or both sides, or second side, we make it in the middle. Click OK. Now you have that rib. This back to the normal view, and here you have your rib. Now we will deal with the next feature, the wrap. The wrap is for adding some extra detail or decoration for your part. We have this box. Let's start to make a sketch. You see the work of the wrap. So let's draw a slot in that. Okay, when you are done, exit your. So we have a sketch parallel or in that surface. Let's activate the wrap. You have three different types. You have the impulse. It will be drafted or extruded outside, impulse inside, or just a sketch. So let's select the face where we're going to show the wrap. Should be parallel to the sketch. And now you have the thickness of the wrap. Make it 3. Okay, you will see here the wrap. If you edit that wrap, reverse direction, so it will not reverse because the type is impulse, or the impulse is always outside. So if you make it thick impulse, okay, you'll make it inside. You will etch it inside. Now let's try to make like scribe to be only a strip on that surface. Now we're going to deal with the next feature. It will be the dome. Here you will see the next feature is the intersect. This icon is newly inserted in SolidWorks 2014. Before it was the dome in the place of the intersect. And you, in the previous versions, you need to go to the insert feature to get to the intersect, but now you see it here. So it's quite advanced. We will keep it for the next tutorials. Now let's take another decorational feature called the dome. So here I have the features menu where you will have all the features. So we already talked about the fillet, chamfer, drag. And then we have the scale, the dome. So now we're going to use the dome, and the dome is to create like elliptical surface on a surface. So it's kind of bolts. If you can see this feature on bolts and many other products, so it's kind of saving time instead of creating it manually. So let's select that face. Here you have the thickness of the dome. Let's make it 2 millimeter, and then you will see the dome. We reverse the direction, so it will be the dome inside. So if you look here, the field surface is sinking inside. Let's edit that and make it 5 millimeter and reverse the direction, then click OK. So it's not seen a lot, but here you can see some kind of dome. Let's edit, make it a little bit. Now you can see when you are changing this. So you are done. Okay. So here you have dome. You create a dome for your part. For extra decoration, you can add the dome for that tab. Let's change it to be in pose. Insert features, dome, select that, surface, and here you can see the dome. Let's decrease. Okay, make it 10, and here you have the chance to make it continuous or not. Here you have that shape for your plastic box. In this tutorial we're going to talk about the scale feature. The scale feature, you are finding it in the insert, features, and here you will find the scale. And the scale, for example, let's say you have this box and you want to create another box, plastic box, for another customer to be 2 times bigger or 2 times smaller. So creating this box from scratch will require some time. So you have 2 choices to do, either to be with equation, and it is quite complicated for this, or easier with using the scale. So the scale, you will be able to scale your part directly. So let's choose centroid. The centroid is going to rescale it on its, keeping it as a center, and you have uniform scaling. Let's say you wanted 2 times, so here you have your part is 2 times bigger. Let's make it, rescale it again, feature, scale, and you have the second option. You are going to scale it around the origin, so it will not see a lot of difference because this part is quite placed near the origin. Let's make it quarter the size. So here you have rescaled part. So if you want to redo that shape, so it's better to use the scale. That will save you a lot of time. And now let's insert a coordinate system as we learned in tutorial number 50, and let's insert it in that part. The x-axis, let's make it that, click OK. We have our coordinate system, insert, feature, scale. Now we're going to scale about the coordinate system. So let's make it 2 times bigger. So you have your coordinate system as a reference for your scaling. In this tutorial, we're going to talk about the next feature, the freeform. The freeform is your first step toward the complicated surface modeling. So now we created the dome here on that surface, and we created a wrap, and they are quite uniform shaping. But what if you want to create your own shaping to the surface with some kind of curves, bubbles, or whatever? So let's try to do this on that face by using the freeform tool. Go to the insert, feature, freeform. So select first the face where you want to make your freeform, and then you will need reference lines and points where you're going to make your deformation. So first let's add line. You can add that line or curves by add curves. They are control curves. So if you move on your surface, you will see that you are able to create this line. If you flip the direction, you will make the lines on the other side. Let's flip direction. Let's make two lines. And after creating your curves or lines, you need points in order to be manipulating them. So go to add points, move over your lines, but if you move in other lines, you are not able to add any points, just in your inserted curves. So let's add a point here, 1 point here, and let's add 1 point here. So when you are done, you can go to the deactivate the point, add points, and now select your line. If you click on that point, you see 3 arrows. In these 3 arrows, you will be able to free move your points. So here you make a deformation that side or on that side, or make it upward. So here we have your free deformation. Now let's move to the next point, and by the same way you can make that deformation. Now go to this line, so be sure that you are deactivating there, and you are able to show the coordinating or controlling lines. So we got a mess here, so you need some practicing to get your best shape. So this tool is the tool showing you how you are able to deal with. So when you are done, click OK. So you have just kind of experiment how you can deform your part. So it's quite not logical, but you can delete it. So this is the idea how to use freeform, and hope this tutorial is useful. In this tutorial we're going to talk about another detailing tool for the faces and surfaces, which is deform. So the deform is creating a deform in your surface, and it's quite easier than to control than the freeform, because the deform is kind of uniform. Deformation is closer to the work of the dome. So let's select this face. You have 3 set or three types of deformation. You have the point, curves, and so on. So if you click on that surface, you're going to pick a point where SolidWorks is going to create a deformation. So here you see your deformation, and you are able to change its radius. And so if you have a look here, so you see how is the deformation is going, and here you can increase the peak of your deformation, and here you have the three types of your deformation, make it wider or something in between. So when you are done, click OK. So you'll see that you created this deformation in your face. In this tutorial, we're going to talk about the next feature, the split tool. You can find it in Insert, Features, and here you see Split. So to split the body, you have now we have only one body. If you look at the tree here, solid bodies, we have only one body. So to split the body, we need some kind of splitting tools. So we can try to insert a surface in the middle, or in the place how we want to split this part. So let's try to split into two halves, cutting in this direction. So let's try to find a plane, cutting in the middle, and insert a sketch there. So normal tool, let's try to make a center point rectangle. Be sure that it is cutting throughout this part so it can be able to split. So now you have choice either to make a surface. Since we didn't cover the surface topic, we can just simply extrude it to a very small thickness. Let's make it 1 millimeter. So here we have one whole body. If you look here, we have only this whole body. Now we can try to split that body through that surface. Go to the Insert, Features, Split, the Trim tool. We will use that face, and then click Cut Part. Now you have these two parts generated to you. So here you can select what to keep and what to remove. So if you select both, so you'll keep both parts. So if you look here, we have two splitted bodies. So you are able to delete one of them. So let's go to the Edit Body, remove that body. So you have splitted that body to two parts. So let's try to edit and make and separate that surface down from these parts. If you go to the Edit feature and Merge Result, you can uncheck that, and when you look here, you have three separated bodies. In the previous tutorial, we splitted that body into two main parts, and third part is the splitting extruded surface here. So now, after we could split this part, we are able to delete what we don't want. So to do that, you can go to the Insert, Features, there you have delete body, so you can select that body, for example. Or first, let's try to delete this part after we separated it in the previous tutorial. So if you don't know how we split that part, you can see the previous tutorial. So when you're done, click OK. So we deleted that part, so we have now these two splitted parts. As you see here, if you want to delete further more parts, you can also repeat that option, features, delete body, select the body, delete, so you have that part. So now you are able to save them in separated files. Save this part in one file and the other in a second file. In this tutorial, we're going to talk about the next feature, the move and copy. But before going to that feature, I just want to add one note to the previous tutorial. We could delete the splitted part, but you're still able to get them back. If you look here, we have delete body 2, delete body 3. So if you right click delete, so you will undo with that process. If you make here delete, yes, so you are undo with that process, so you have that part again. So let's just delete this part, the feature, delete body, plus extrude. So now let's try to activate the next feature, the move and copy. So here we have feature, move and copy. You have to set for moving. You have to enter the values manually to be more accurate, or just free movement. And in the copy, if you check the copy, will create copy of that body, so you'll make two bodies. So now let's select the body we want to move or rotate. So as you know, we split that body, so this is nice feature, the split, so you are able to rotate that part. So let's rotate that part, and here can move it. When you are done, click OK. So here you could move it, but you couldn't rotate it because it has some kind of relational with that body. But now you are able to separate it, move it there. So let's try to move it further. Insert, feature, move, select that body. So let's try to move that side. Okay, and here you have it in a different place. So now let's try to rotate them. Insert, feature, move and copy, select this part. Let's try to rotate it in that direction, and then when you're done, click OK. So from one part to two different directions parts. In this tutorial, we're going to show you how to save each part separately. So we now splitted this body. We created it from the previous tutorial, and we worked on it until we reached to this part. Now we're going to save it in different files. So there is an option to do that. To go to the insert, here save bodies. When you click into bodies, it shows you two different bodies. Select the one you want to save, and then click OK. So now it will save it as body 1. If you decrease the window, you see it here opened in separated file. Now let's go to the part. Let's save the other part as well. If you go to the insert, feature, save bodies, this time let's save that body. Okay, either save it here or you can select it and try to find it here. Okay, can save. You're done. Okay, so here we have it. So now you are able to make it in different part files. This is original, and here we have the two separated files. Hello to the first tutorial in surfacing. In this tutorial we're going to be having an introduction about surfaces. So let's start a sketch in one of these planes, and to reach to the surface place you have to right click on this bar here, and then you have surfaces. So surfaces is a toolbox by itself in SolidWorks, which have some tools working with surfaces. They are quite familiar with the features we were talking about in the previous tutorials. So, but in this toolbox they are in the surface level. If you are familiar with the inventor making only one tool set, for example like the feature in SolidWorks, and there are options always for creating the surface. So in inventor they are one set, but here they are two different toolboxes. So here we have the surfaces, and also you can reach to the surfaces from insert, surface, and you have your surface tools. Okay, now let's start making a sketch. Let's make very simple spline, exit, then exit that sketch. So now we have this line. If you go to the feature, try to extrude it, so you will extrude it like a solid body with a thickness. You see here the thin feature is activated, so you can make it 1 millimeter or smaller, then okay. So here you have a body or a solid bar. So if you look here to the left, solid bodies, so this is considered that extrude thin as a solid body, but the surface is something different. So let's delete this extrude and go to the surface instead. So let's activate the surface tool, and if you look here you have the extruded surface. This activated, select that. Now you have a surface. Let's just try to find this arrow here. So now we extruded that surface. When you are done, okay. So the difference now, if you look here the left tree, you have a surface body. The surface has no mass, no volume, just it is a view to a surface. It's because in the future you are able to add thickness and so on after working that surface. So this is the first introduction about surfaces. the next tutorial we're going to continue talking about the extrude and contours. So see you in the next. Continue to talk about the extruded surface in details. So here we have this spline extruded from previous tutorial. If you want to edit the surface, simply like before, you can click on that feature, edit feature, and then you are able to add a dimension. So let's add 20. So exactly the same option like the 3D or the features extrude. Now you have 20 here. You can increase to 30 and so on. If you want to reverse the direction, here you can reverse direction, and you have some option up to vertex, up to plane, or so we knew from previous examples that if we have a second body in front, that we can extrude that surface as that reference, either a vertex, surface, whatever, but here you can choose the mid plane. We are able to extrude in both sides. So let's make it blend. Now here you have direction 2. So you can extrude in 2 directions with 2 different distances. So we have 30, we can add 50. But if you choose the mid plane, you will get 50 in both sides, or 30 on both sides. And now let's go to the draft. You are also able to make a draft in the surface. So let's add 30-degree draft. So here is clear what the meaning of draft. So you are drafting the surface as well. So let's add a draft here for many degrees, and then activate the draft 20 degrees. So here you have drafted 2 directions with 2 different drafting angles. The extruded surface icon, we used it in the previous tutorial. Now let's try some advanced extruding. Let's try to edit the sketch here and make another space or another profile. Okay, so now we are in that sketch. Now you go to the edit extrude, and in the contour you can select some contours. So the clear selection here, and now you have both profiles. They are extruded, but now we are able to select some contours. So if you hover over that closed area, you are able to extrude that area. If you hover over here, you can extrude this area or that profile. So let's select that, click OK. So you are able to extrude that contour for that profile. So this way is able to make some complicated shapes which are not easy to make with the normal sketching. So you can try to intersect with different profiles to create some special shapes. So let's try to extrude the other profile. Go to the contour, clear, and select that contour. Okay, so we extruded that contour. So in the next tutorial we're going to talk about the revolve surface. So see you in the next tutorial. Welcome to a new tutorial. Let's start a new part and change the In this tutorial we're going to talk about the next feature, the Revolve surface. You remember we talked about the Revolve boss, and now we have Revolve surface. Let's start making a sketch with center line. Let's first choose that front plane and make shape of bottle. So okay, so here we have a very quick half of a bottle. Now let's insert center line and add a relation to be vertical, and then can add some dimension. Okay, so now after we have these dimensions, we can now activate the revolve. Revolve, you have the line selected, line 7, which is the center line, and it revolves that profile around that line. So here you can make it mid plane or up the vertex or so on, or blend and the angle of so how much you want it. You can make half revolution, you can make it a full revolve. In direction 2, the same way like we talked before in the extrusion. We made 3 tutorials about extrusion, talk about the direction and select contours. So this works on the same way. So when you are done, click OK. So here you have the bottom, very quick and fast to create with surfaces and the revolve. In this tutorial, we're going to talk about the contours and revolving. So we make this tutorial to show the contours and revolving because it might be kind of tricky to use. So now we have this profile made. Let's make an offset from that. Solid sketch, edit sketch, and now we have the offset. Let's try to make an offset of 1 millimeter or 2 millimeter from that. Click OK. Close here, profile, close here, fine. Here we have a closed contour, and let's try to make another contours. So now I make some circle here. And linear mirror it on this. Let's deactivate this as we learn. We make it just one. So we deactivate it in that direction, and here we can make 5 reverse. So we have this. Okay, now we have these close contours. Now let's try to trim. Surface revolve here. So you are able to select some contours. Select the line of revolution and the contours. You need to select some closed contours. Try to find a closed contour here. So here we have closed contour. So now we are able to select the contour from the front. Profiles. Tutorial number 71. In this tutorial we're going to talk about the next surface tool, the extrude or swept surface. It is not activated here. So let's start some sketches to make a swept. So let's start this. Profile, exit, and try to find another profile to be perpendicular to that profile in order to sweep. So we have to plane, make an spline. So here you can decide the shape of sweep. Let's exit. So now you notice the sweep surface is activated. You have two surfaces, the profile and the path. So let's activate the sweep. The profile is here selected to be the path, so it's not the right selection. So you select sketch 1 as profile. The path will be this. So when you're done, click OK. So this is the very simple sweep choice, and you can try to edit and see the different options. So here you have fully path, so it will give you a very simple sweeping, and you have keep normal constant, so it will, the profile will continue being constant the whole sweeping way. So if you click OK, so you see the difference between exit or edit. Here you can also twist along path. So here you can see the twisting when you are increasing. So we can make it 90 degree, or just make another angle. Here you can revolve the twisting direction. Let's edit again. And here you have twist along with the normal constant. Try 50 degree. And let's try to make another option or another trick with this twisting. If you go to edit, follow path, you have twist along the path, and you have either to select with degrees or with turns. For example, if you can select turns, 5 turns, click OK. So you are twisting and making this special rod. So there are many options to create your almost any shape you want on SolidWorks. In this tutorial we're going to talk about the lofted surface. It works pretty similar to the feature loft. Let's insert some reference planes as we learned in the previous tutorial. Let's make 2 more with the front plane. Let's start with the front plane, making a sketch. Select the center point slot and exit. Let's go to the second plane, insert a sketch. What we can do, we can make a trick, convert the entities, then rotate it so we can select. In the center of rotation, you can select the origin 90 degrees. So we'll uncheck the keep relation. So you are done. Except go to the third plane, sketch, select the first sketch and convert entities. So we have these 3 sketches in 3 different planes. Go to the lofted, you have sketch 3 selected, select sketch 2 and then sketch 1. So when you are selecting, you are also need to care about the points you are selecting. So it's not just select, because selecting a point can decide the shape of your loft. So now we have the uniform loft. If you change the point place, that can create some twisting to your part. So that's why you need to understand or know where is the loft. So sometimes it became not working. So you have to choose, and now we are on the uniform lofting, just the same path points. Okay, so now you created your loft. In the previous tutorial we created this simple loft without having any guiding lines, just selecting the sketches. In SolidWorks you are also able to select some guiding lines if you want your loft to follow some specific path. So let's try to delete this loft, and now we have these 3 sketches. We will try to insert some guide. So we can find a plane where we are able to have a path intersecting with all these sketches. So let's start a sketch on the right plane, and then can make normal to be sure that we are intersecting with the sketches. We can make projecting can convert these and convert them to constructional and make a spline. So here we created a path, exit, go to the loft surface, clear selection, and the profiles we have to be sure we are selecting our sketches. So this is the simple loft. For regarding curve, you can select that curve, then click OK. So you notice it was not able to create that loft, so you can move to the other option to be sure that we are selecting. So we have another advanced option. We will use it for the first time in this set of tutorials. We can go to the 3D sketch. If you go to the sketch, you have 3D sketch. So a 3D sketch is not associated with any planes, so it is moving free in the space in 3 directions. Let's select a spline, select this point, so now we are sure it is intersecting with that profile, and then select another point, then third point, and you are done. Select. So we have, since it is a 3D sketch, so it needs some extra control to see where its path is going. So let's try to see this path. This is intersecting this point here. Try to delete that relation. Make sure that this point is intersecting with that sketch. So when you are done with your 3D sketch, you can go exit, select the lofted, clear selection here, select the profiles. Third, for the guiding line, select the 3D sketch. So here you notice that your lofted guide is working. Now you have your special or unique lofted surface. Tutorial 74, we're going to talk about the fill surface tool here, and before it we have the boundary. We will make it in the next tutorial. The filled surface is doing the same job like a boundary, but the fill surface is quite easier. It fill the gaps and the surfaces. For example, let's activate the boundary. Let's select that and click OK. So you'll find it needs more inputs to create the boundary surface, but let's now activate the fill surface. So it's going to fill that profile. So if you select that, you'll see a preview which is going to fill that surface. Also, you will be able to select some guided curves, and the type, you have the tangent, but in this way it not work when you're going to select the tangent, because you can't see this surface is perpendicular to that surface. so we can try do it in the next tutorial. Now let's select the contact. You have that surface. Okay, you fillet that surface. So this is a way to complete your product. Very quickly fill the surface with one click. Tutorial 75. In this tutorial we're going to talk about the fillet surface. Let's show the surface tools box, and if you don't know, here you can see right click and you have the surfaces toolbox. The fillet is come here later, so we use the fillet in this tutorial. It is quite easy and it will be also useful for creating a fillet to the next tutorial when we're going to use the boundary surface. Let's start a sketch on the front plane. Let's make circle and center point, rectangle, let's trim very quickly with power trim. Okay, now exit, or even before exiting you can extrude that surface. Extrude. Okay, now we have this extruded surface. We can make these edges smoother with make a fillet. Let's make a fillet here. You can have the 10 degrees or 10 millimeter distance. Select that, you are able to create that fillet. So you can increase, let's make it 50 and make 50 here, and then you can make another 50 here. So when you are done, click OK. So you have this shape. In this tutorial we're going to talk about the boundary surface tool. We have this profile created in the previous tutorial. It contains many separated sections as you see. So let's activate the boundary surface. Now you are able to select the boundary surface and create that surface. You can select this edge and this edge. So here you have your boundary surface is selected. You can also select that edge. In this case will be different. Let's cancel, make a boundary surface like this edge, so you are able to create that boundary surface between these two edges. So when you are done, click OK. Tutorial 77. In this tutorial we are going to talk about the two direction boundary surface. So it is a first step to advanced surfacing. Let's start make a sketch to let you understand the idea between two directions boundary surface. So let's select the front plane, insert a sketch there, normal to, and let's make two lines, or simply convert these two lines. Then we have these two lines on that surface. So let's exit that sketch, activate the boundary, select this line. When you are done, OK, and the second line, OK. So we have two lines. When you are done, click OK. In this case you're not able to see that. Okay, let's go to boundary surface again, select the line and this line. Here you see that boundary surface it's created, but as you notice it created a straight boundary line and didn't trim around that fillet. Let's edit that boundary, and in this case you can select the direction too. So this is second direction here, and here second direction. You created exactly the same closing boundary surface. To fill this gap, if you want a very simple surface without any complicated edges or so on, you can simply select the easy way, the fillet surface. So you are able to select the boundary edges. Select the edges. Last one, you have your fill surface. Okay. So this example show you the boundary and the fillet and the use of them. Tutorial 78. Let's start new part. In this tutorial, we're going to talk about the next feature, the planar surface. Let's bring the toolbox, the surface toolbox here, and let's make a sketch on the top plane, like some so make a circle. So we have these three surfaces or three files, succeed, and extrude them with the extrude surface. Okay, so now if you want to fill some surfaces, you can use the planar surface. The difference between planar surface and fillet surface, the planar give you a planar, a plan or flat surface to close, but with the fillet you have chance to select directions and so on. So let's activate the planar surface. Here you are going to select the boundary of your surfaces of where you're going to create your planar surface. Let's be sure that we are selecting the right edges. And as you notice here, you don't have any other choices, just select the boundary edges. You have no chance to make directions or whatever. So now we have our planar surface created, and we fillet that surface. Again, we can activate with the same way you can create planar surface. So it is not necessary to select a closed loop. You can create a planar surface on some part of your surface. So let's again activate planar surface, select this circle, and here you have your planar surface. Let's rotate these parts. Here we have another choice to fill all these gaps at once with the planar surface. You have two choices. Let's try the first one. We can choose a plane is parallel and intersecting with these profiles and create a sketch on that. So and draw rectangle that is covering these surfaces. Okay, then make a planar surface, then you closed all the profiles and you having this extended sheet. And you, in this case, you are able also to trim after that the excessive, if you don't want this excessive surface. Let's undo or delete this planar surface and make the second way to fill all these gaps at once, we have that sketch we made at the beginning. If you select it and select planar surface, SolidWorks going to fill all these profiles in that sketch, and then you are done. In this tutorial, we're going to talk about the offset surface. We have this part created in the previous tutorial. Let's try to make some offset surface. From its name, you are able to duplicate a surface you are choosing and make an offset from it. So let's try to select that surface, activate the offset. So simply you created an offset surface, that, and here you have the distance you choose, and then you have also to reverse the direction, as you see here. So when you are done, you can click OK. So offset surface, it can make some kind of designing for your surface. For example, you can offset some parts to make it like appearance, changing the appearance, and then deleting the original surfaces. So let's try to make another offset on these connected surfaces here. Let's select offset surface, clear selection, and select this surface, and then last one. You're done, click OK. So you created your offset surface. Let's try it once again on that cylinder. Offset, clear selection, and that cylinder. Select the top plane, top, select this surface. And then we are able to fill the surface between these two with some kind of fill surfacing. So let's try to review the filled surface and try to fill that surface. Let's select filled surface. In this case, the planar surface will not work because planar, we said, taking flat surfaces. If you pick, you are not able to select only closed profile. So let's select the filled surface and this edge, that edge. So you see that surface is created to fill this gap. Okay, so you fill in that surface. In this tutorial, we're going to cover the delete face tool here, and later on we're going back to the freeform and rolled surface tools. So let's activate the delete face, and from its name you are able to delete some surfaces. So let's select that surface, and you have three different options. The simplest one is the delete. Sometimes according to the geometry you are not able to select the rest. So let's select the delete, and here when you are selecting that face, it gives you some option what to delete with it. So all surrounding, all outer, and so on. So let's select that. Then you are selecting that face. Okay. So let's try to make it on this. Activate the delete, select that one, delete, let's select delete and fill. It's not going to work because you need to select some more faces. So deleted and filled at the same time, so it has no result. So let's try it on that. then okay. So again, it has no result because it filled with the same surface. So we can do is delete and fill, select and select the all tangency. Okay, you'll notice the change in here. Now let's try to delete this single surface. If you try to delete it with this delete face, select that face, delete, it's not going to work. So you need to make another option to delete that single face. Go to the insert, feature, delete body, select that face. Okay. So the delete face is having some options to delete some loops and so on, but in case of single face, you can choose delete or from features delete body. So if you select that, it's going to select all the surrounding. If you select that selection and select that face, then you are able to delete that surface. Tutorial 81. In this tutorial we're going to talk about an interesting surface tool, the Freeform tool. We have these parts from the previous tutorial. Let's undo the deleting we did in the previous tutorial. Simply select them here, delete body, delete face, right click, delete, yes. So now we are back to our normal shape. Let's just delete this face, feature, click body. Okay. Now we can try to activate the freeform. The freeform is making some free transformation to your surface according to the design you want. And in this case, you are able to free by yourself or having some guiding sketch. So the face, you are going to make some deformation. You are selecting that face. There is two things you have to think about for creating your deformation: the curves and the points. So you need curves and points. So let's try to add curves. You are able to make that direction or other direction if you flip direction here. So let's keep it with the first option. I'm going to add two lines. When you are done, add points. So the points will be the places where you're going to create your deformation. So now uncheck or deactivate the add points. Now you are able to select the curve, the point, and move it. You have the arrows. So go to the next one. So you are able to move it in many directions. Then go to the second line here. So here you are creating your deformation. So when you are done, click OK. We can try to do it in that face. Create some transformation, add some lines or curves, add two curves and add points. Also, you are able to change the angular. If you see that small surface here or small face, you are able to select that and move that plane direction. You are done. Okay. In this tutorial, we're going to talk about the ruled surface tool. Here we see it in the toolbox. So the ruled surface tool is extend the edges with some surfaces. Let's activate these, and you have many options. The most used, the first two. So if you select that edge, you are extended that surface. So now we are extending it upward, and if you make it normal to the surface, you are able to make it normal to the surface. So this kind of extending the surface. Here you can flip the direction, and as you remember, we made an offset of 10 millimeter. You can increase that, but the gap here is 10 millimeter. So when you are done, you click OK. So you have some trouble here to connect with the surface, so we can decrease to 9 millimeter. Then click OK. Let's flip direction. Okay. So we have a problem because these extended surface, they are intersecting with each other. So let's flip direction. When you are done, click OK. So let's try to make it on this circular edge. Ruled face, normal to the surface, flip direction, increase. Okay. So this is the idea of ruled surface. So now, for example, we can extend that cylinder here, ruled, extend, make it tangency. In this tutorial, we're going to talk about the knead surface tool. So the knead surface is combining the surfaces. For example, we have this product, and in reality, it is kind of one part. So you can imagine this drink can. So this is made from one part. So, but in this surface, or in this tutorial, it is separated surfaces. So if you select here, have that surface, and here you have a separated surface, and this is a separated surface. So it is important to show the type of connection between your surfaces. So these, if they are one surface, so you should knead them. And also it is good idea to knead your surfaces to decrease the number of surfaces you have. In this case, we have 16 surfaces, and we said these surfaces we need to combine them. So let's activate the knead surface, select that surface, this surface, and that surface. You can also select that one too, and then click OK. So if you notice here, you decrease your surfaces, and here you have only one surface, they are combined together. So if you look here, you have the surface knead 3, you have all these parts in one surface. Let's try to do it again here. Each surface, this one, the rest Okay, and further we decrease the number of surfaces. So also we can select this plane, meet it with this body. Okay, this planar, need body here. Need it with inside body here. Okay, and so you are able to combine your surfaces and decrease the number of surfaces, so it can be easier to handle, and also decide which parts are combined together or one sheet of surface. In one of the previous tutorials, we used the delete body tool to delete some surfaces, but in the previous tutorial we made some combining to the surfaces. We made some neat, and let's try to use the delete body and see what will happen. Go to the feature, delete body, select that surface. Okay, so you'll notice you're going to delete the whole neat surfaces, combined surfaces. So that is proof that they are only one part. So the neat surface is combining your surfaces to make them one single surface. So Ctrl C to undo, and if you try to do it with other surfaces which are combined with the rest, so it's going to delete them as one unit. In this tutorial we're going to talk about the extend surface. In the previous tutorials we talked about the rolled face, and we saw that we couldn't make it inside to extend these edges, these whole edges to the inside surface, because they are overlapping. So you have other option is to extend surface. So in this case you can select that surface, and here you have the direction of the extending. You can extend it upward, or you can change it to linear, so it depends on how you want this extended to be. So you have a distance here, you can make it 10, then you are extended that surface, and you are able to extend the surface parallel to itself. You can select that edge, make sure that you are selecting the edge, the one. You can select this edge, and you see you have that extending parallel to the surface. And here you can pull that arrow direction and at a distance, or to be more sure you have up the point, so you can extend it and select that point, so you are extended that edge to that point. So, tutorial 86. In this tutorial we're going to talk about some common tools found in the surfaces toolbox. Here you have the reference geometry toolbox, which are also found in the features menu, and also you have the curves menu, which are also found there. We're going to talk also about the curve menu in this series later on. Now we're going to try some tools. In the reference you have the axis, the point. We already talked before about plane and coordinate system, and also in this tutorial we're going to talk about the helix. So let's first try to insert the point, reference point. You can select the center on a face, center on an arc, or intersection. Let's try to make the center on a face. So if you go to there, you are able to select that center point and this center point. If you select that surface, and you will see you have a point in there, so you have a center point. So when you are done, okay, so you have that point, reference point, and that center face. Let's try another type of points. You can intersection, you will see intersection between this line, you will see you have an intersection point. Click OK. Let's try another type of point. You can arc, center, you can select that arc. Now you have that center point in the middle of that arc or cylinder. Now go to the axis. To insert an axis, you can have an axis, you have point 3, and then you can make it type or on line edges or two planes or point on plane. So in this case you can have a point, then click OK. You need another face, you can select that point and that face, then click OK. You created that center axis. Also you can insert center axis through the planes in here. You can select front plane and the top plane, go insert axis, you will have an axis between these two planes. Now what we want to talk about now is the helix. Helix, you need to create a helix, you need to have a circle. So let's try find circle. That's it. Create a sketch in here, select that circle, convert entities. So okay, when you have that circle, you will be able to insert a helix. So here you have a helix. You can type the pitch, revolution 5, and whatever your spring you wanted, and start angle, or you can reverse its direction. Okay, so the helix is a useful tool. You are able to create threads, springs, and many things with the helix. In this tutorial, we're going to talk about an important tool in the Surfaces toolbox, the trim tool. So let's activate the trim tool and try to delete these outside flanges here. Now here you have the trim tool, or the trimming surface, or the main body, which is going to be used as the trimming tool. Here we have selected that body. You can see it shaded in blue, and the rest of the body you can see, you can select it in yellow. So these bodies, so this body, main body shaded in blue, will be used as the trimming tool. And here you can select the keep selection or remove selection. I'm going to select remove selection, and here you are able to select this surface and this surface. So when you are done, okay, if you have problems, so let's your selection and select that body. Okay, so we have now trimmed that outside flange. Now to make it more clear, let's try to make another surface. Let's make on the front plane sketch normal to, let's make an spline. So let's say we are going to change the type of the bottom edges of these boxes to be kind of curved. So we have this surface, let's extrude it on mid plane. Okay, so we have this surface and we have these boxes or cans. So now we have many options to do. You can trim the excessive parts here. trim the down parts and so on. So let's try this example and see what we can do. So the trim tools, you can select this surface. So remove selection. Now we are able to remove these parts. When you're done, you can select OK. So now you could trim the bottom edges of these cans and make it circular. So now let's try to trim this surface. So you have option to delete this surface. Let's try to insert and go to features, delete body, select that surface. Okay. So now you deleted that surface. But when you deleted that, you deleted the covers of this. So you can now make a planar circle, surface, or filled surface. In this tutorial, we're going to make the opposite of trimming surface, the untrimmed surface. So it is making the filling, the trimming surfaces. So let's try to untrim this edge here. We have this part from the previous tutorial. Just click untrim. Here the selection of the edges, select that edge and that edge. So now it's going to fill that gap or untrim. So if that was trimming surface, now you are doing the opposite and fill that gap. Okay. In this tutorial, we're going to talk about the next feature, the fillet. We already used the constant fillet in the previous tutorial, and in this tutorial, we're going to use the variable fillet. So let's activate the fillet, select variable fillet, variable size, and then select where you want to apply your variable fillet. So let's select this edge, and now you see you have points. These points, you are able to add a fillet radius to one of these points, and also you are able to add more points. So now let's try to add some fillet values here. So let's add 1 millimeter here. Click on the second point, and add 5 millimeter. Third point, add 7 millimeter. And then this one can add 5 millimeter plus 1. And the last one, let's add 1 millimeter. So when you are done, click OK. So you have your customized fillet applied to this edge. So if you are not able to apply a fillet on one of the surfaces, you might need to knead the surfaces. For example, we already may combine the surfaces together. So if you are not able to make a fillet, so try to knead the surfaces, then apply your fillet. So here you have your variable fillet. In this tutorial, we're going to talk about the next type of fillet, the face fillet. Activate the face fillet, and now let's apply it on these two faces. Select this face, and second face, this one, add the radius of fillet to be 20. Then you apply your face fillet. As you notice here, this surface didn't fillet with that surface. Click undo, and let's try to fix this. We need to combine this surface with the rest of these surfaces. You do that with knead. Select that surface and these already combined surfaces as we did in the earlier tutorial. Click OK. Now apply the face fillet. Select this first set of faces and this is the second one. OK. You notice now you are able to fillet that surface as well. So you have to think about this extended surface is 10 millimeter. So if you made the fillet bigger than that, it might not work. So let's try to edit that fillet. Let's make it 12. So you notice it didn't work. So let's make it 10 again, or smaller, it will work as well. Let's try to make another example for the face fillet. Select the face fillet, select that face. This is first set, this is second, this is third. Still select one face at once, change. Okay. The next tool set in the surfaces toolbox is the references. We already talked about the plane and coordinate system and so on. They are the same work as the ones we used before here in the features menu, the reference geometry. So now let's move to the next menu, the curves, or this menu. This allows you to further advance work with your surfaces. In this tutorial, we're going to talk about the split line. So split line, you are able to create a sketch, spline or line, and from that sketch you can split your surface. Let's try to make a sketch on a plane that is where we are going to cut that surface. So in this case, in the front plane, insert a sketch, normal to, so let's create a line, a cutting line or the knife. Then we are done. So we are done with this line. You can add dimensions and so on, and go to split line. So it is activated here, selected, and here you are having the current sketch. This line, the surfaces where you are going to split this surface. When you are done, click OK. So this line is moved like knife through that surface and split it into two parts. So now you are able to work with one of these part alone. You can delete that surface or trim it. The next tool is the project curve, an interesting tool in SolidWorks. If you are following us in creating this part from beginning, you will remember that we have a deleted surface have been created before. So if we go to the tree, we can pick that deleted body here and undo by deleting that. So now you would remember that extruded spline. So if you don't have it, you can simply create a spline and extrude it. So we have this extruded surface. Now we'll make another sketch to project it on that surface, because it has quite some sharp edges. We want to make it looks a little bit better. So let's try to find a parallel plane to that extruded surface where we are able to project a curve on it. So we can find the top plane, insert a sketch on the top plane, normal to. So now we can select the shape of our So we can make that shape. So when you are done with the shape you wanted, and it is matching that extruded surface on the top of it, click OK. Now we are able to project that sketch on that surface. Go to or exit sketch first, then go to project curve. Sketch 6 is already selected, which we have clicked already. The surface where you're going to project is this surface or this face. So you notice here you have your projected curve on that. Click OK. Now when you are done with the surfaces toolboxes, it's time to see your surfaces work. Now it's time for the surface quality. So you have the zebra stripes tool. To get there, go to evaluate. You have zebra stripe. So the zebra stripe is showing you the flow and continuous of the surfaces. So here you have the zebra stripes. So this extruded surface looks okay, and here you can see the flow of the stripes, and from there you can imagine what can be not smooth or have lower quality. For example, here we made a fillet. You can see the smooth between the stripes, and when it comes to the top surface, it might need some working to make that zebra stripe flow more smoother. So zebra stripe is a good tool to show your surface work that might not be seen with the normal eye, but with the zebra stripe you can see the flow of your surface. So here you can see you might need some kind of fork to make this freeform surface smooth with the rest of the body. So can now deactivate, and here you can see this edge needs some work to make it smoother. You can apply fillet or whatever. So now we can talk about another tool for your surface quality, or the thing they are not clear to see by the eye. So we talked about the zebra stripes in the previous tutorial. Now you have the curvature tool, which measure the curvature in your parts. So here if you look at this black curvature, that means you have, and hover over it, you have a curvature of 0. That means this surface is flat. Now here you can look, this green, this give you the value of the curvature. So this is blue. Here you can see the flow of the curvature between the planes. So this part is flat, and here you can see the transition is smooth between the two colors. So this is a way to know the quality or to measure the curvature of your surfaces. And here you can see the green and black. You don't have any transition colors. That means you have a straight transition. So in this case it is okay because it is not a spline or something, but here you can look at the variable fillet. We have smooth transition between the curvatures. If you want to see more curvature, you can apply here some kind of fillet to make the transition between the black and this green grade colors to be more smoother. So this curvature tool is quite interesting to measure more your surfaces quality. Tutorial 95 in surfaces for SolidWorks. This tutorial will be the last in the surface section, which will be about adding thicken for your surfaces. So when you are done with the creating your surfaces with your surfaces tools, which we already discussed, and check the quality by zero stripe and curvature, and time to add the thicken, because right now you don't have any actual body, it is only surfaces and they are not ready to be manufactured or measured as a mass. So just add some thicken to your surface by going to insert, both space, you have thicken, so you can select the surface you want to thicken, then you see the thickness you want to add. You can add 1 millimeter. Here you have the type of thicken you want it to be outside or in the middle or inside. So we have this body is selected. So okay, so we add some thicken to that body. So you have, if you look here, you have a thickness of 1 millimeter to that edge. Again, we can apply it to the rest of the bodies. Insert, dispose, thicken. You can select the curvature, then add a thickness of 1 millimeter. Okay, so you have here thicken 1 millimeter. Then you can continue the rest of the body. Just select this body and add thickening of 2 millimeter. Make it in between, and here you have the merge result. So we can keep check it, so it can merge this surface with that surface and make it one body, or uncheck to make it separated bodies. So click OK. If you go up in the tree, you will have solid bodies here already appeared. So the thicken, they are actual bodies, but not in the surface. So the surface, they are only surfaces, and when you add some thicken, you have an actual body with mass. So you can see your parts here. So now I am done with this tutorial, and hope this section was useful, and the next section will be the next tools, the Weldments tool. So we have a series for discussing the Weldment toolbox. Hello and welcome to the very first tutorial in the SolidWorks Weldments. On the list, it is tutorial number 96. So we're going to continue to talk about the SolidWorks toolboxes, and now let's move to the Weldments. Let's start a new part. Okay, and the Weldments, its word comes from welding, so you already know what the weldings is. So to find the Weldments toolbox, right click on the toolbar here, and then you will find the Weldments. So far away there down, maybe you don't see it, but you will write Weldments. So click on that, you will find the Weldment toolbox. Also you can find it in insert, Weldments, and here you have your Weldments tools. So in this set of tutorials, we're going to talk about the Weldments and each one of these tools and functions and how to deal with them. So I hope these tutorials will be helpful and let you learn more about the great software SolidWorks. So see you in the next tutorial. This is tutorial 97, the second tutorial in Weldments. The first tool in the Weldments toolbox, you will find the 3D sketching tool. So the 3D sketching tool is not only with the Weldments, you also find it in other places. For example, in the sketching here, if you start the sketch, you have 3D sketching. So 3D sketching is, now it is, we worked with that before, but this is the first time I am using it with a tutorial to show you how to use it. So the 3D sketch, it is different than the original sketch. The original sketch, you are creating two-dimensional sketch in one of these planes. For example, let's make a center point rectangle. So you are able to work in this plane, that front plane, it might be the y-x plane. You are not able to move in the third dimension. But if you want to make another, you want to make a table, for example, and you want to make legs, so you need to insert another plane. So for example, you can go to the feature plane and you want to insert a plane parallel to that line. So let's find a parallel plane. So in this case will be the right plane and this line. So, and we can make it parallel here, and then okay. So we inserted a plane here, then you can insert a sketch on that plane, normal to, and insert two lines. Two lines here and one line here, and they are equal. So exit the sketch, and then the same process on the other side to create that table. So you can imagine how it is kind of many steps to work with this 3D table, but here came the 3D sketching work. So it makes this job more easier because you are able to create 3D sketch in 3 dimensions. But it needs some attention when working with it, because it is kind of, you need to control the direction. So let's delete this sketch. First let's exit this one and delete those sketches and start with 3D sketch. So click on 3D sketch, or from a sketch here you have 3D sketch. So now we are in the 3D sketch mode. Let's select center rectangular. We need that to be in the y-x. You can look at the compass here to have an idea in which plane you are drawing. So now we are in the xy plane. So as we remember, when we created a 2D sketch, it was on the xy. And a second thing, when you want now to draw a leg, so they will be in a different plane. They will be in the zy plane. So in that case, you need to change that plane by clicking on tab. So now we are in the zy plane. So you are able now to insert the table legs, and can add, or you can add an equal relation to them. And now let's move to the other side. Select line. Now we are in that plane. Make sure that you are parallel to the axis, and then one line here, so you can see it is parallel to the axis, and again you can add equal relation to them. So you see, you created that table in only one sketch, which called the 3D sketching. So if you want to work or make this sketch on the 3D, on the 2D sketching, you will see it is require many steps, inserting planes and so on. So you created that table in a matter of few minutes. In the previous tutorial, we talked about 3D sketching. We created this table by 3D sketching, as you see the 3D sketch here. And exactly like the previous sketching, you are able to rename it and add a name for it, for example. And to edit it also, you can click on there. Here you can change the name if you want. 3D table, and if you click on that, you have edit sketch, exactly the same like the 2D sketching. You are able to edit again your sketch. Let's add some dimension here. So let's make a table with 1 meter wide and give it 600 leg size. And when you are done, you can click exit sketch. We have this sketch. Now let's start working with members. So weldments is actually members, structural members, which are going to be welded together. So the structural member, they're having different types. Let's start the first icon. So when you are adding this icon here, that means you are able to start working with the weldments. So it is an important icon to show you that you are in the weldments tool. So now our 3D sketch is ready. Our weldment environment is activated. So we are ready to work with weldments. In the next tutorial, we're going to show you the different types of members or structural members that SolidWorks offers you to work with. So see you in the next tutorial. The third tool after the weldments icon is the structural member. Here you are able to start working with the weldments. Let's click on that. Structural member, you have the standards. You have the NC inch or the ISO. I'm going to use the ISO, and you have many different types. You have the C channel, L channel, and so on. All these structural members and in the size. So let's first select the angle iron and select the first the group, and when you come to group, you're going to select which group you're going to apply your weldment set. So when you are clicking on them, then you are done. Okay, so let's zoom into it. You can have a look which type you already selected. Let's edit the feature and change the type. We have the same group selected. Let's select the C channel. Okay, so the C channel didn't work. Let's add the size first, and now you are there. So here you have your C channel type. And again, let's have a look on the second or third type. You have the custom, and you have pipe size. You have a different size. Also, you are able to add your customized sizes if you want. That is depending on the license you have. You are able to edit in the SolidWorks setting. So here you have this type, this edit type, the rectangular tube, this one which I was looking for, and here you have the different types. Let's select this type. Now you have this set. So when you are done with selecting, you created these weldment structures, and you can also add another group. Let's either to add a new group by again selecting this structure member icon. Let's make it 5 here, size, select, and then select the new group we want, which are the legs. Okay, so we have two set of groups. We have the pipes and then we have the structure member. But as you can look, maybe you need more working or adjusting to the corners and the shape, how they would look. So that we're going to talk about in the next tutorial. In the previous tutorial, we created this table with these structure members. So maybe you need to change the type of the corner, not as the default selected by SolidWorks. We can edit that. You can go to the group set. You want to edit it, edit feature, and if you move down here, you have the corner treatment. So if you select this type, you will be able to rotate or to make this type of corner. So click OK. You can see a look. You have a look in here, so you might see a better look to your structure. If you are not this type you want, again you can change it to different, change the gap opening, and then click OK. So here this again edit feature, and the next line here either to merge the members or keep them or keep a gap. Let's try to merge these. Now you don't have any single gap between them. That depending on the design you want. Let's again edit that feature. Here also you are able to add the gap. In this case you're not able to add the gap between, so you should simply cut here, and you can be able to add a gap between these two members. So here you can have a look in there. This is tutorial 101. We created this structure table in the previous tutorial. Let's try to edit again this first group of members. Let's eliminate the gap, make it merged. Okay, so now we have this shape. Maybe it doesn't look that perfect. Members locations, we can try to work with that. Let's edit the edit feature and see the next options we have. Here you have the allow protrusion. If you click on that, that will eliminate the first corner, so it will not start from the first corner. You can have a look here, but this, so you know the meaning of allow protrusion, but we don't have it. We don't want to have in this case. So let's move to the next option, is to rotate the members. Then can rotate the members, so you can make it 90 degree. So you rotated your member 90 degrees, so you can try to make 45 degree. So this shape might be better than before. So you rotated your members to 45 degree. Okay, so we will have this shape. In the previous tutorial, we could rotate the members to have these straight members as we wanted and as the normal tables look like. But here we still have a problem that this member is intersecting with this weldment, and in reality you can imagine this type of weldments should have a hole in there and welded, but it is not logical because normally this member should laying outside here. So we need in this case to relocate the first member group of members. Let's edit that member and try to locate the profile. So you remember we have this group selected, so this group representing the members here. So for this case you need to go to locate profile here and select where exactly these members should lay according to the group selected or according to the sketch. Now we have our members centered in the center of that sketch, and if you hover over here you have the chance to select other alignment tool or where to locate. For example, let's select this point. Your members are laying inside your sketch in the middle of the vertical length. Click OK. So you have look here how your profile will look like, but still is not the shape we want. We can again edit the profile and find where is the point or we want to locate our profile. So to get that table leg centered, we can select this point, the center to the middle. So first we should select locate profile, select that point, click OK. So now you have your leg is on the right place. So this is in the future going to be welded with these bars. So now we fixed that intersection by locating your profile. In previous tutorial we created this table and we fixed the corners and intersection legs. Let's try to add a supporting member in the middle for that table. So in that case we need to edit these structure members. We have the structure member is in the top here where the center member should belong to. So let's edit that feature, and if you look here we have these edges are selected. We can try to create another edge in the middle and select it with this group and see what will happen. Let's edit the 3D sketch and add a center member. Be sure it is in the middle. Okay, let's edit this members and try to activate here. Select this. You'll notice the structure couldn't update and selected that edge. For this reason, we're going to try to make a new group. So start a new group and then select that structure member, click OK, then you have that member, and you notice it is not intersecting with the other members. It is perfectly located, but now we can rotate that member and treat it furthermore. So edit feature. When you are editing that feature, it contains two groups. We are going to work with the second group, the center member. Now let's try to rotate it 45 degrees. Okay. Okay, when you find the angle, and again, as we learned before, you need to locate your profile. Edit that member, select second group, locate profile, and here we want, can have a look here. Okay. So we have our member, center member in the middle of that table. Welcome to this tutorial. We have this table from the previous tutorial made, and we show you how to use the different options to get your perfect alignment to your members. But also there is another icon in the members or for the weldments. If you remember, in the beginner tutorials, we have in the tree list, we have surface bodies and we have solid bodies, but the case of weldments, we have a cut list. It's called a cut list. It contains all the members you have. So there is a third type now, you know, it is a cut list. So we have surface bodies, we have solid bodies, and we have members. And if you look at the cut list, you would notice this green dot on that. That means you need to update your cut list, because we already working with this table and re-edit it and added new members. So you need to update that cut list. So right click on that, you have update. You click on that, you will see your cut list is updated with arranged cut groups. So you have the cut list contains 4 items here, and we have the second group, then the third group, which we added it to the structure member 1. So here you have an arranged view to your members. Welcome to this tutorial. You remember we have this table from the previous tutorial. In this tutorial, we're going to talk about the next feature here. We have trim and extend. In this tutorial, we're going to talk about the extend. Let's try to make a gap between these members. Go to the first structure member. As you remember, we have this type. We are able to create a gap. So we will create this gap so that you understand the type. Okay, we have this gap of 10. So we have this gap. Now let's try to extend this gap. Click on extend. You have body to be trimmed or extended. In this case, this bar. Now, in the trimming boundary, you have 2 options. Either select body or face plane. Let's select first the face, and this is the face where we're going to extend to. Now you have the preview. Now if we select the second option, the bodies, you are able to select the whole body here, but the difference here, you are able to select this type of ending. And in the welding gap, in this case, if you choose this type, you don't have a welding gap because this will be intersecting with the body, but you have this straight end, you have a weld gap. You are able to get or make a gap for inserting the welding material. I'm going to use this. Okay, so this is the extend feature. Tutorial 106. In this tutorial we're going to talk about the trim and members. We remember that we fixed these leg members by locating the upper profile of the members and locating them above that member or the leg. So let's get back to that situation, the original situation. Locate profile and select the original point where it was before. Okay, so now we are back to the original structure combination when you have this leg is intersecting. So if we don't want to change the members location or locate profile for the case that you have some sensitive structure and you don't need to locate any profile, then you can do the second option to trim that part. So we go to the trim, bodies to be trimmed, of course this leg and this leg and those 4 legs. And now the bodies, you have a low extension, of course, and the bodies, and you know the difference between the face and planes. Let's try to select the face to be that face, that face, that face, and that face. So when you are done, just uncheck the weld gap here. Okay, now you trim these legs to this face or this plane level. The next feature in the Weldments toolbox is the extrude feature. And if you look at that icon, extrude both and the original extrude in the feature menu, it is the same icon and they are doing the same function. So actually it is the same tool. For example, you can insert a sketch on the top of that member. Click on that, insert a sketch, then you are able to create a sketch there. Activate extrude and extrude it. Also you can insert a sketch on that face, convert entities, extrude, so you are able to extrude and create a gap for that. So the extrude tool, it is the same job like the extrude we learned before. So let's just delete that gap because there was a special function or tool in the Weldments that creating gaps to close your members. In this tutorial we're going to talk about the feature we said about it in the previous tutorial, the end gap. So Weldments has a special tool for creating end cap for your members. Let's activate the end cap, select where you want to apply your end cap. So this is the first preview for the selected end cap. Here you have the thickness of your end cap. Make it 2, or you can simply keep it 5, and you can make it inside. Okay. So as you notice, it changed the alignment of the member, so it scattered some of your member. Now let's try it on the other side. See the other options we have in the end cap. Let's select the end cap, select this side and make it outside this time. Here you have thickness ratio. If you want to keep it 3 millimeter or just keep it 1 millimeter. So you have now, if you have the thickness ratio is 1, that means it's going to cover that. Or it's going to make a 1 millimeter to 5 millimeter ratio outside. And if you want to chamfer this excess, you have this option to chamfer. So you can make it 13, 5, and until you get to the gap or the cap you want. The next function in the Weldments toolbox is the gusset. The gusset is also called rib if you are familiar with the feature toolbar. So it is almost the same but with different names. So in the Weldments, if you need extra support to your table here, you can add ribs or gusset. Let's activate the gusset, select where you want to add it. So select these two edges or faces, so you have your gusset inserted in that place. So you have different types of gusset, and you are able to change dimension of it and where you want to locate it. So you can see how this gusset is located. So you can sit on that edges, and if you want to move it or change that location to be in the middle, you can select here, select that middle thickness, and then you have your rib in the middle. And in the thickness here you can add the thickness you want. So I keep it 5 millimeter. It's okay. So when you are done, click OK. So you have this shape or this gusset inserted. You can do the same thing here. Select this face, that face, and we have already these options selected from before. So again, in this tutorial, I'm going to discuss about the rest of the tools in the Weldments toolbox before going to the last stage, which called the weld bed. So the next feature, you can look Extrude Cut, Mold, Wizard, Chamfer, and Reference Geometry. We already talked about all these features in the previous tutorials. They are exactly the same like the ones in the features menu. You have the Extrude Cut. If you look at the icon, it is the same with the same description, exactly with the whole wizard, chamfer, and the references. So let's try to activate the whole wizard. Try to make some holes to your members. And here we have the different type of holes, which we already talked about. So you can select this normal type, ISO, and make it the through all. Go to positioning, find the position where you want to add hole, add some dimensions to it. Can increase the hole diameter to be 10, then okay. So we have this hole in that member. You can also use some of the features menu tools. You can activate the linear, you can combine them with the Weldments tool to reach to your required So this is the idea of how to use some of the rest tools. They are exactly that. You can combine with these both tools to create your required shape. This is the last tutorial in the weldment section. Now we are ready to send this structure to the welding process after we are done with the completing the structure as we want. So we have this table now is ready to be welded. So for that reason we need to specify the type of welding and how much you want to weld and so on. You go to the weld bed that tells the technician the way to weld your structure. Now we have these strips inserted to this structure, so these strips can be the places for welding. Now we can select the faces where to insert your weld. So select this face and this face. You have that weld inserted there. So you can try to weld in this way for all your reps. And in the selection, you have also the amount or the radius of welding. Let's make it 5 millimeter. So that means will give you a radius of 5 millimeters if you are familiar with the theoretical part. So if you select both sides, it's going to select on both sides. So I'm going to keep it on both sides. You have all around, you can weld all around the edges. I'm going to make it both sides, and I guess it is that too much weldments to be added. So we can try to make it spot welding. And in the define weld symbol, if you are familiar with the types here, you can select, but I'm keeping it to the default. The length, for example, weld length, we have, as you remember, we have this strip with the length of 35 millimeter. I'm going to decrease it to be 30 millimeter. So you have it here. You can change where to the exact place. So if we make it this 30 from 30 or 25, and here we make it 5 millimeter. So you have that weld is in the middle, so you're going to weld 10 millimeter or 5 millimeter offset from that member with the length 25, and there in the intermediate weld you can select to be spot welding, so we can make it a gap, and weld length, so we can make a gap of 1.75, so we can make the spot length to be 2 millimeter with 5 millimeter gap between. So I guess this type of weld is enough, and that will be repeated on the rest of the ribs we have. So by this way you're going to weld that structure and be ready for using in the workshop. So now we are done. So here you can have a look there. And if you hover over there, you should see the sign of the weld. So this icon here is going to show the technician how to weld that side. Hello and welcome back to new series of SolidWorks tutorials. We finished recently with the series of Weldments, and in this tutorial we're going to start a new series talking about the assemblies. So we remember when we started the SolidWorks, when we start making new parts, you click into new, you have three options. You have the part, assembly, and drawing. And now we're going to talk about assembly and see how it works. And later on we will going to talk about the drawings. So here you have the assembly icon, and click OK when you are done. And here you started a new interface talking about the assemblies. And as you notice, the interface is quite different a little bit from the part interface. You have the edge component, insert component, and so on. So now let's start to insert our first component. So here you have the browse, then you select your part, then click OK. So as you notice here, you are moving your part everywhere, and click where you want to add your part. So when you are doing this, the part should be stick on the origin. This is what we're going to talk about in the next tutorial, but in this tutorial we're going to have an introduction about the assemblies interface. So as we said, it's quite different from the part, and it has its own menu, the assembly menu with its functions. And here another important thing, you have the mates, where you will be able to create mates between different parts. And if you have a look in here, you will notice the F at the beginning of this part, which indicate that part is fixed. So in the next tutorial we're going to try to insert more parts and see the difference between the fixed and the minus sign, and also we're going to try to figure out the positions where this part is inserted. Also, one thing else I want to mention about, in the mates, they are indicating the type of the mates between the parts, and there are many levels starting with the first or the basic mates, then to the advanced. In this series I'm going to try to cover most of the mates. In the previous tutorial, we inserted this first part to our first assembly. In talking about inserting parts, there are many different ways you can follow to insert your parts. So as we remember, we saw the browse menu where we could browse for our part. But before that, we talked in this tutorial about assemblies, and assemblies parts have a different extension than the parts. So for example, let's have a look. Here we have 3 different parts, and you can see the type of the file is different. For the standard part document, it has the name SolidWorks part, and for the assemblies you have a different types for SolidWorks Assembly documents. So they have different extensions. So this is one point, and then now let's try to delete this assembly. Don't save, and before creating a new assembly, let's just open that part before. So now we have our part is opened here, and when we start to create assembly, you have an options called the make assembly from part. So this is another way to start your assembly. In the previous tutorial, we did that by creating new, then assembly. So there's another way that you can try to make assembly from part. Now let's just try the first method. Click new because I'm going to show something. Simply click OK. So as you remember, we opened that part 2 before starting this assembly. So you will see that part 2 is here in the list of browse. So this way can be time saving if you have your parts already open or you have been working with them, and you will be able to see them here. So you can click here and then you insert your part. Also, we said about something about positioning. Let's go and try to show where this part is inserted. You can go to show origin. So now you will notice that this part origin is inserted far from the assembly origin. So you have 2 different origins. So this is an important issue you have to think about it, because if you will have an assembly, you should know your origin. That might be important for your parts to know their origin. So in the next tutorial, when we start talking about mates, we will try to fix it with the mates method. Also in this tutorial, we're going to try to find another way to try to position that part into that origin. So in this tutorial, we're going to continue to talk about inserting part. Also, you have another way to insert your component. You have insert component, and again the browse menu will be open, and again you will be able to start or add another part. This we're going to talk about in the next tutorial. So here, let's close this menu and close this assembly. Don't save, and we have this part is open. We said there's another way there. You can start your assembly. You can go to file, make assembly from part. So you have the same menu exactly as if you click on new assembly. So you have this part is selected, then you can put it somewhere on that assembly. So let's close that assembly and show you another way for creating another assembly. So let's just minimize this window and let's pick a new assembly. Okay, and see you have 2 window. You can also try to make them tighter horizontally. So you have this part and you have your assembly. So you will be able to. So there's another way to insert your parts just by dragging them directly to the assembly interface. But before doing that, we saw there's an issue that you have to know where you are positioning your part. Let's show the origin here and also show the origin here. So now you are able to see both origins, and then you are able to pick this part and match it with the origin of that. So try to drag it on that origin. And you're done. Click OK. In the next tutorial, when we start talking about mates, this might be quite tricky to place your part on the origin. So when we start talking about mates, we will find a easier way to position your origin. So see you in the next tutorial. In the previous tutorial, we talked about the different ways to insert your components. And we remember from the previous tutorial that we could drag and drop that part into the assembly interface here. And we said we want to position our origins to the place that we want. In this part, in this assembly, this part is inserted. The origin of that part is inserted to be parallel to the middle of that edge. Maybe this is not the way I want. Maybe I want the origin of that part to be somewhere else, to be coincident with the origin. And we found that inserting or dragging and dropping, that might be a little bit tricky to find your exact position. And we remember that from the previous tutorial that we said you can see when you are inserting your first part, you will see the F sign at the beginning that indicate that your part is fixed. So this is the meaning of the F. So that means you will not be able to move it around unless you float that option. So in this tutorial, we're going to start our first mate. We said you have mates here. So the mates, they are the way to create the relation between the parts. So in this tutorial, we still have one part. In the next tutorial, we will start and having more parts and more examples for using assembly mates. So for example, to start your mate, you can click on mate here simply, and then select the type of the mates. So when you are clicking on the mate, you will see the standard mates, the coincidence, so you can understand from that. Simple, the coincident making 2 points or 2 edges coincident, parallel, perpendicular, tangent, and so on. And here you have a distance. You can create a distance and angle. And then you will have the advanced mate. We are also going to talk about them, where you have the symmetry, width, and so on. Then the mechanical mates, also we're going to talk about the mechanical mates, and they are the 3 types of the mates. So let's first start with the coincident mate. We said we want to make this origin coincident to that origin. So here you have this window where you can select the parts or the feature we're going to consider. And let's click on this origin, and on this origin you'll get an error message because, as we remember, this part is fixed and can't be moved. So here is the quick selection where you can click on undo, and let's close the mate menu, and this part, let's make it float. So now your part is ready to move. Let's click on that origin, and when you click on that origin, you will see the mate icon here. So this is a quick selection. Also you can use it from here. So let's click on that, click mate coincident, then click that origin. So let's try to select this origin, this. So that means we have an error because when we inserted that part, let's delete that. Then you'll see here you have the constant is working. So now you moved your part to origin of the assembly. In the previous tutorial, we used the first type of mating, the coincident mate, and we remember that we floated that part. So now you can get back and fix it again after we inserted that mate. So you have your part fixed on that origin of the assembly. So now let's try to find another use for the coincident mate. Let's insert component, browse, and click part 2. So now we have a second part. Let's just add it there. And if you want to insert another part, you can go to the insert and again browse for part 2. But you have another easier way. You can click on control and drag that part. You'll be able to create different parts by using the control. So now let's activate the mates. Let's select that edge and click mate, and then click the fixed part or surface. So you will have the option to make them coincident, so as you see here. And if you want to flip the direction, you can click on that arrow, so you will flip the mate, then click OK. So you notice that we have that surface. The bottom surface is coincident with the bottom surface of that. So let's try use another case. Let's select that edge and then select that edge. You will notice that the mate is still open. Click that edge, so coincident also will be work. When you are done, click OK. So you see that we had different cases. We made the coincident with the point, the surface, and with an edge. So again, to fix. So let's try to make these two blocks on each other. You can again select that surface and that surface, then you have the coincident, then click OK. You will also able to create that with the edges. So now we have two parts are inserted in each other. When you are done, click OK. So if you have a part is not required, or so you can delete it by find it here, then right click, delete, yes. So now we have two parts inserted in each other. If you try to insert another mate, logically it will not be necessary, so you'll get an over-defined message. So that means you don't need that, because now your assembly is fully defined, as you see here. We will continue talking about mating. In the previous tutorial, we created these mates, the coincident mates, to create or to arrange this glass block. So if we want to make a gap between these two blocks, you have many options to do that. For the coincident mate here, if you want to find that mate, you just hover over it to know where is the mate you want. So you have that mate, you will be able to edit feature or to edit that mate, and again you will be able to modify on that mate. And here you have a distance. If you click on that, you're able to modify that mate. We are not able to work with that because we have another coincident mate with the edges which make these parts are sticking together. So let's close that, and let's here make, or to delete that, you have an option to delete, or you have another way to suppress that. So you can click on suppress. You will not be deleting, just to hide that effect. So now you have this coincident, just edit that part and just add a distance. So here you will be able to create a distance that you want. When you are done, click OK. You have another way to do that. You can click on that distance, delete that. Yes, click on that surface, make sure that you are selecting the right surface, mate, and select the parallel mate and this surface. So you will have these two mates will be parallel to each other, and you will be also able to add a distance for that parallel relation. So when you are done, click OK. So here you have your mate is done. In this tutorial, we're going to talk about the next type of mates, the perpendicular mate. Let's delete that last mate. And to avoid any over-defining or problem in creating the new perpendicular mate, let's click on that surface. Let's pick two surfaces. Let's pick this, the bottom surface. So make sure that you are selecting the right surface. So here we have this surface mated with this surface, but we want it to be perpendicular. So here you have that perpendicular relation is done. So when you are done, click OK. To fix it more, you can make this edge coincident with that edge. So you have SolidWorks automatically selected the coincident because it is logically will be working. So when you are done, click OK. So here you have this perpendicular relation is done. So with the distance, you can also add distance. For example, this is perpendicular or this coincident. You can edit it and add some distance to change the place you want. So this is the perpendicular mate or relation. In this tutorial, we're going to talk about the next type of mates, the tangent mate. This is an interesting mate type. So it can make the coincident mate, but in the cases that the coincident can't work, we deleted the previously made mates, the perpendicular. Now we have this part is free to move. We remember that this part has the minus sign, and this is a fixed part. So in this case, we want to make this surface to be tangent with that circular surface here. So the coincident will not work, so you have that option to use the tangent. So let's select that surface, mate, select the tangent. As you can see from the sample, it is a circle with the flat surface. The second, let's select that circular surface. So now you have that surface is tangent to that. You can flip the direction. When you are done, click OK. So here you have that flat surface tangent to this circular surface. So this part now will be moving tangent to that surface. So you're done, click OK. In this tutorial, we're going to talk about the concentric mate, one of the most used mates in assemblies. So for using the concentric mates, we should have some circular surfaces and cylindrical surface to make this mate to work. We have this pen, paper pen, made in the SolidWorks tutorial channel. So we'll use them to create our concentric mate. So if you want to make this product, you can find it in the a tutorial how to make it in the SolidWorks tutorial channel. So let's start a new assembly. Okay, and as we said, because we have the parts is already open, you will see their parts are here, so you didn't need to browse for them. So let's insert this part, insert component, the cap. So in this tutorial will be combination between the concentric mate and also the coincident mate. So let's select this cylinder to make it in the center of that cylinder. So you can click on that surface, mate, and the second surface, you have this surface. Let's select. So now you have the concentric relation is automatically selected because logically it is working here. So when you are done, click OK. So this is one way to use the concentric, but as you notice, this part is not. It is moving but concentrating to that cylinder. So let's just delete that mate and show you another way to create that mate. Also, let's select this time the circular edge, this edge only, and then let's activate the mate and then select that circular. So again, you will be able to select the concentric, then click OK. So you have to choose to select surface, cylindrical surface, circular edge, or both together. So now you have these mates are concentric together, and this part is moving. You can add another relations to fix that part, as we learned in the previous tutorial, the coincident relation. So we select that surface, and the second surface can be the bottom surface here. So we have the coincident mate selected. OK. So now we have our product is ready. So this part is not moving anymore. So in this way, this product is ready. In the previous tutorial, we used the mates to create the assemblies, and we starting every time with selecting the mates type and then create the mate. There is another way to create your mates by the Alt key, or it's called the smart mates. You don't need all the time to start the mate menu and select the type. So let's start make some parts. Let's make a cube very quick. Cube. To use it as an example for our mates. So now we have this cube. Let's make an assembly from, let's save and make an assembly. Let's insert that cube. We have this cube, and we know that by the control key you can make other instances. So now let's show you how to use the smart mate. So we have this fixed cube and we have this moved cube. So select the face, Alt, and drag it to the face where you want to create your mate. So you notice the icon is changed, or the mouse cursor is changed. So now you see the mate icon, which is now ready to select or make a mate. So you selected that face or that face, you'll be able to create that mate automatically. So you have the chance to choose which type here. If you want, just simply make it a constant, and you are able to flip the size if you want. So when you are done, click OK. So let's try to make another mate. We have this face is constant to that. So now let's select that face, click Alt and select that face. So you'll notice that we are able to make a constant relation with that face as well. So now we define two mates very easily and very quickly. So let's select that face, Alt, that face, constant, OK. So this is a quick way if you have big assemblies and you have enough experience with SolidWorks to know how to deal with the smart mates. So let's again select that face, Alt, select that face and make it this time a distance. So you can increase it as you want. So now you have this distance relation. You can delete that distance. And let's try another thing. Select that face, Alt, keep holding Alt, and then select that face. When you are done, release your Alt. Make sure that you made that mate before releasing. So let's make an angle relation. Let's flip the direction and make the angle, for example, 31 or 45. Enter. When you are done, OK. Select that edge, Alt, select the other edge. So constant relation, OK. So this is another way to create your smart mates very quickly. From this tutorial, we're going to start talking about the advanced mates. We have these products made in the SolidWorks tutorials channel, so you can find it there. And in this tutorial, we're going to start working with the width mate. So the width mate is kind of advanced assembly. It is kind of combining the constant and parallel. It brings you the part exactly in the middle between two flat surfaces. So you need 4 flat surfaces. In this case, we have this is first surface, second, and 2 on the other part, this one, this one. So you will guarantee that this part will be exactly in the middle. So to start with the width, we click on mate, and here in advanced mate you find the width mate. So let's activate the width mate, and here you have two fields. You have to fill them, the first two surfaces and then the second two surfaces. So now you have this with assembly is applied. So this part is exactly in the middle between these two surfaces, as you notice here. For example, if we just applied the coincident mate, maybe there will be a gap on the other side, but with the width you will get your part exactly in the middle. So and then we can apply another mate, one standard mate, the concentric, as we know. So now we have this part is simple, but if you notice here, this part is rotating all around, and this is not real. So to deal with this thing, we can talk about that in the next tutorial when we start talking about the angular mates. In this tutorial we're going to talk about the angular mate. We said in the previous tutorial that this part is not rotating like this in the real world, so we will try to apply some angular mate to limit this angle, so we can give a specific angle to rotate. And here also, as you notice, this one also needs some angular mates. So let's start apply the angular mate on the button and the connector here. So we can find two planes that can be parallel to each other and can apply the angular mate. So let's find the first part here. The bottom part is this one, so you can try to find the right plane and then go to the mate, advanced mate. You will find the angular limits here. So we'll try to find the second part, the connector right plane as well, or the plane which is parallel to this, in this case right plane as well. So we have these two planes, and you can imagine these two planes can rotating in a limited angle. So let's make a default angle 30, make here 50 and minus 50. Okay, so let's try now to rotate this part. Now you notice we limited the movement of this part, so it is more realistic right now. Now let's apply it to the connector and the top part with the same idea, to find the planes or rotating planes. So in this case here we have the front plane for the connector, then we have it selected here, and then we go to the third part, find the angular plane. So these two planes have to be limited with an angle, and again activate the angular. We make it default 30. So as you notice, you have to reverse the direction 50 and minus 50. Okay, you are done. Okay, so now you notice that we limited the movement or the angular movement of these parts. It's more realistic and nice to work with. We have this pipe wrench built in the SolidWorks tutorial channel, so if you want to build it, you can find that tutorials there. Let's just show this part, complete part of this pipe wrench, and let's talk a little bit about it. Here you have this nut when you are moving this part, so you have this nut is rotating. Also, if you rotate that nut, you will rotate the up part as well. Thus we applied some limit mates so that stop this part from moving away from this part. So in this tutorial we're going to talk about the screw mate, this part from the advanced assembly. We applied that screw mate on this nut and this part. So let's hide part 2 here. Now we can see clearly, and let's have a look at the screw mate, edit mate. So you can notice we applied into edge, this edge and the face inside, and here you have the rotation direction, and then here we added the pitch revolution, or the when we applied or when we made the helix, we added a pitch of 6 millimeter. So you have to add it here as well. So each revolution, this part will move 6 millimeter up or down. So this is the idea how to use the screw. So on okay, now we are moving this part. You see this nice rotation. And also when we assemble that part, we make some study that this nut will not be interfering with this part as well. So this is the idea about using the screw mate, and you can try to build this part and apply it. This tutorial we're going to talk about the hinge mate, this part, and the mechanical mates. So the hinge mate is kind of combining two mates together in one options, exactly like the width mate, which we talked about it in the previous tutorial. So let's try now apply the hinge mate. You can find it under the mechanical mates, and we have this hinge built in the SolidWorks tutorial channel. If you want to build it, you can find this tutorial there. So let's now choose the hinge. Here we have it, and when you click on the hinge, it will require from you the concentric selections and coincident selection. So it is clear these are the concentric parts, and now the coincident faces will be this part and this part. Now we apply that hinge mate on this. When you are done, click OK. Now you can notice that this part is rotating exactly like a hinge, and it needs one more mates to fix this rotation. We talked about that type of mates in tutorial number 122, the angular mate. So that angular mate will limit the rotation of this part. So you can try with this. You can find the angular mate and the advanced mate, angular mate. We assembled these two gears on this board. This gear is made in the SolidWorks tutorial channel, and we're going to use it to explain the gear made in assembly. So first of all, we firstly applied some basic mates. We have the concentric here, and the coincident with the surface here. Now we already know about this type of mates, but in this tutorial we're going to use the gear mate. We have these two gears. First, let's align them that are not interfering. So, and then we go to the mate, mechanical mates. This first gear selection. Now the gear mate is activated. We select the ratio. We have the diameter. If you select this part and this part, you will get the same ratio because we have two equal gears. Then when you are done, click OK. So you have your gear mate is ready. So when you are rotating, the second gear will rotate with the same speed. But if you change the diameter, you have to explain that in the ratios so that the mate will understand the difference in the speed. If you have the mate, also you have to check the direction of the mate. If this gear is rotating on the right way, but if you have a belt, in that case you need to reverse the direction. So this is the idea about using the gear mates. In the previous tutorial we talked in details how to deal with parts and creating parts and the functions and tools to create the part, and then we move to the assembly to assemble our parts. So now it is the next step after making your part and assemble them to present them in a 2D way. So it's called the drawing process. So when you click on new, you will notice here you have part, assembly, drawing. We have been working in the previous tutorial with the part, then we move to the assembly to assemble these parts. Now the next step, as we said, the drawings. So in this set of tutorials we're going to start talking about drawings, how to present your parts, assemblies or whatever by drawings, and here you can see a brief introduction is a 2D engineering drawing. So in this tutorial we're going to create our first drawing. To create your drawing, go to new, drawing, then click OK. Here when you click on there you have the standard which type of papers or which size you're going to use. So let's choose A3, and if you have a different type you can browse for it, but the standard is the ISO. So I'm going to use this, and here you have some width and height and the sheet format. So when you are satisfied with this format, click OK. So now you have your drawing sheet of paper. As you notice here, we have the model view window because we have our assembly is already open. You can see it here in the browse window. If you don't see your assembly, you can browse for it, and simply you'll notice that you are able to drag and drop your so if you couldn't drag your assembly there, so you have the second method is if you look here to the right, you'll see view palette. So if you open it, and here you can select your assembly, and here you see all your views. So as you know from the engineering book, the drawing is projection presentation for your part. So you have three main views: the front, top and the left. So it's up to you to choose which projection you want. And then let's start with the front view. So you can just drag it and put it in the sheet. So here you have your front view, and when you drag to the right, you will get your right view, and then you will have your top view, and then you will get your isometric view if you move in that direction. So here you have your drawing is done. When you are done, you can click escape. So this is your first drawing sheet. In the next tutorial, I'm going to show a second or a different way to create your drawing. In the previous tutorial, we created this first drawing. So now let's close it and let's show another way to create your drawing. So you have your assembly is open here. You can go to the file, make drawing from assembly. So you can click on that. Here you can select your drawing file, okay, and again you select your ISO sheet you want. So let's click this time A4. Now you have your drawing, and as you remember, we can go to the view layout, model view to browse your model. Also we said you can go to the view palette to drag your projections files directly to your sheet metal, to your sheet of paper. Also there is another way I'm going to show is if we just minimize this window, here we have your assembly. You can simply take it, drag it to this sheet. So we are done, click OK. So you create your sheet here, or you created your projection, front view projection, directly by dragging your part. So when you click on it, you are able to move or change the layout of it. So this is your front view. So if you click on there, you will see projected view. You will be able to extract the projection, and then you have your isometric view. So when you are done, you click OK. And here you have display style. You're already familiar with this. You can use it as that show or this type of showing. When you are done, click OK. If you want to change the display style of your part, for example, click on the part you want, and here you can select the display. For example, if you want to display the hidden line of your part. In the previous tutorial, we showed you how to start creating drawings from an assembly or a part. And now we're going to repeat this process again, and you will have an idea how to create a drawing if you didn't watch the previous tutorial. So go to this icon, make drawing from assembly or part, and select your sheet type, then OK. Here you see, as a first way, you see the projected views. So select front. If you let's get back to fillet, drag it here, automatically it project your views. You're done. Okay. This tutorial we're going to talk about the scale. If you notice here, the scale in this sheet is the 1:5. We'll try to make it a little bit bigger, so we can do that. If you click on that part and then roll down, you will see the scale. So So you can select use custom scale, you can try change it to be 1 2. So now we have this scale is changed, then click OK. But in this method you will notice that here on the sheet down you will see that the scale didn't change on the sheet. So that means just undo, control or bring back the projected view. So now let's change the scale again to be 1 to 5. Use sheet scale. Okay, so this is the sheet scale. So what we can do right now is to find another way to change this scale. On the sheet, right click, you will find properties, and here you can change the scale of the sheet, and also you can change the name of the sheet. So let's try to make 1 to 2. Okay, now you have your sheet. There down you can see the scale is 1 to 2. In the previous tutorial we showed you how to adjust the scale of your drawing, but you notice here that the sheet is smaller to the size of the scale. So we can try now to change the sheet size. You go to properties, right click on the sheet, properties, and here you have standard sheet size. You select the type you want. We already have A4, now we can select A3, little bigger, so click OK. So now we have that bigger sheet, and it's look bigger. Now we can adjust the place of the views, and here we can keep the isometric view. In the previous tutorial we tried to change the sheet size to get a better view, because it was the A4 smaller for our view, but now we got another issue that the isometric view looks bigger or actually has no place to fit. So we can change the scale only for the isometric, not the whole views. You can click on that view here, use custom scale, then select 1 to 5. When you are done, click OK, and you will notice SolidWorks write the scale of that single view on right. So now we have that scale. So now it can be easily fitted, and here we can adjust more the views. So now it looks a little bit better. You're done, click OK. From this tutorial we're going to start talking about dimensions. We created these drawings, as we remember, from the previous tutorials. So now it is time to add the dimensions, because it is important to have the dimensions in any drawing. And as you learn in the engineering book, that the dimensions having some rules that you need to follow, and you can easily know the difference between the type of dimensions and the arrows and so on. So to start working with dimensions, you have smart dimensions icon here. You click on it, you will find two types of dimensions. You have smart dimensioning and the dimension expert. In this tutorial we're going to talk about the dimension expert, and then we're going to use the smart dimensioning, because the dimension experts is kind of faster. So let's click on dimensions and select your view. You will notice you will get an error. So when you are selecting this view, you need to select a vertex or the reference point to your dimensioning. So let's start find any point. Here you will get a message that the dimension expert is used in part level, not on this assembly. So let's go here. I created a single part here, and I'm going to make a drawing from this part. So let's place our parts here. So now we have these parts. So now back to smart dimensioning, dimension expert, and here you know the difference between the baseline and the chain type of dimensioning. That depends on the baseline is clearer, but sometimes it depends on the area and the available places to your dimensions. So here you have the vertex or whole center, and I'm going to select this center or this point. So now we have a reference point for your dimensioning. Now you can simply click on the parts here, and you will get your dimensions automatically done. So that is very fast way to create your dimensions. The previous tutorial we used the dimension expert to create very fast dimensioning to all parts, but the dimension expert, it doesn't work with the assembly level parts. So let's go to smart dimensioning. In this case we're going to use the smart dimensioning. So also we can create our dimensions. Just click where you want to add your dimensions, then you have the chance to move, add your dimension, or simply click on this half circle to position your dimensioning on the right way. As we said, dimensioning has some type of place to be added. For example, this distance should be around 1 centimeter or 8 millimeter. So again, let's start adding more dimensions. Click on that edge. So same idea, we can create our dimensions. So as you notice here, this dimension is higher than that dimension. This is what you learn in the engineering book. So again, we can add or continue adding more dimensions to our assembly. In this tutorial, we're going to talk about another way for creating your dimensions. In the previous tutorial, we used the smart dimensioning tool to create the dimensions in this part. So let's just delete this one, click on that and delete. Activate smart dimensions, and if you go to the view, right click, you will find here more dimensions. You have the horizontal, vertical, and so on. The vertical and horizontal, they can be done almost with the smart dimensioning, and here we're going to use the vertical ordinate. It might be done also. So when you are selecting your first corner here, you have the 0. So this 0 is the starting point for your vertical dimensioning. Then you're going to select these points. Here you created your ordinate vertical dimensioning, so it might look better than the previous used dimensions. So let's select this one also, so we have this dimension is created. So when you are done, click OK. So we can also try doing it with the horizontal level. So we can try do it here. Go to small dimension, I click more dimensions, horizontal ordinates. Let's select the 0 line. So we have our 0. Then can continue selecting these lines and creating dimensions. It's very fast and nice to use. You can adjust the place of in the previous tutorial we created these dimensions, and in this tutorial we're going to show you how to adjust these dimensions. We mean with adjusting is adding more text to it or changing the font and size. First of all, if you want to add something to the existing dimensions, you click on it, and here you'll find this quick menu. Here you can write, for example, if you want to add any marks, for example, external dimensions, and here you can write, for example, millimeter. So when you are done, then it's okay. And you have also a chance to change the font and the size of the dimensions. For example, if you go to the dimensions and here go to the colors, you'll see that box is checked. So uncheck that box and click on font, and here you have the different font types, and here you can choose the size of your font. In this case I'm going to use the points and write 10 and click OK. So we adjusted that font to be more smaller and maybe it has better look. Now we can select more than one by holding the Control key, go to the other font, just click 10, activate the points, 10. Okay, so we have all these dimensions selected with the 10, or maybe you can make it even smaller to 8. So we have these dimensions now shown in this way with smaller font. When you are done, click OK. In this tutorial we're going to talk about another method for saving some times when you are making your dimensions. It's called the model item method. So if you go to the annotations here, and you will see the model items. When you click on it, here you will have your choices. So simply you can choose the entire model. When you are done, just click OK. SolidWorks will create the dimensions, all dimensions for you, all parts, and here you have the chance to modify them if you want to change it further. So here you can modify some items, and here you have all your dimensions created for you. So this is an advantage for creating your dimensions if you don't have a lot of time for making them. Maybe in this model it is quite simple to make the dimensions, but in a case you have a bigger assembly with a lot of dimensions, it comes handy. For example, we already created some dimensions here and used some kind of techniques to create these dimensions and adjusting them, and you can add the rest of the dimensions with the model items method. Here select the entire model and also check the import item into all views, and then SolidWorks will import all the dimensions which we used in SolidWorks to create the parts. So here you have all the dimensions. So if you find it, you can start modifying them. So the advantage with using this method that it give you all the dimensions which will define your drawings, so you will be sure that there is no dimension is missing. Just maybe you need some time to adjust the place of your dimensions. In the previous tutorial, we used the model items to import all the dimensions used to create these models. And as you see, this piston contains a lot of dimensions, and if you want to create them manually, it might take a lot of time and you may miss some dimensions. So we created them with the import items or the imported items model, and we have all the dimensions here, and as you notice, it's fully defined. So this is a very good tool to use, especially with some complicated assemblies like this one. So when you are done with that, you click OK. So now we're going to go to the next step, where we're going to modify the block title. So if you hover over it, you will notice the cursor icon is changed. So that means you are able to work with the block title. So right click and go to edit sheet format. So your sheet will turn into blue. So double click on the title here and then add the name you want. For example, piston drawing. Then you have chance to change size and so on. So here the material, for example, you can edit it and write the steel, for example. And as well you can modify the date and so on. And also you have chance to add some text. For example, you can click on notes and select the area. For example, we have the title, our engine piston view. So you have that text, and then you can continue the same way, adding the rest of the nodes that you want. So when you are done editing your block, you exit your sheet format. In this tutorial, we're going to use the auxiliary view. The auxiliary view is creating views that you are defining the edge you want, not that default isometric or views which are already found in when importing your parts. For example, we want to make a projection view from that edge or from any other edge, but if you, for example, let's now activate the auxiliary, and for example here you can choose the quality you want, select that edge, so you have that auxiliary view from that edge. Also you can do it from that edge as well. So here you have that view according to that edge that you selected. So this is the idea of using the auxiliary views. This tutorial we're going to use another type of views, the crop view. But before you start using the crop view, for example, you created the auxiliary view in the previous tutorial and you have the letter C and D. If you want to change that, you just click here and simply write what you want. For example, side. Then you'll see view side. And here, for example, you can write angle or simply A. Okay. So we have the A view is showing. So now if you think that this view is a little bit bigger than it should be, then we can try to crop it. This is the idea for using the crop view. But first we need an area to be cropped. For example, this view is intersecting with this dimension, so we can try to make it smaller. You can use this rectangle and create center rectangle, or make a so can make that angle, can try to make it smaller to the area you wanted. Then okay, so you have this closed profile, this rectangle, go to view layout, crop view. So now your view is cropped according to the area you selected. So when you are done, rebuild, you have this icon here, rebuild view part, then you have your drawing or cropped view as seen here. In this tutorial we're going to talk about the section view. It is often used in drawing. To create a section view, you have in the view layout menu section view, click on it. So you have now to select just one view. If you saw that message, now select this view, section view. Now you need to draw a line. So you have different type of lines, how to create your lines, either to make it vertical or horizontal, or you choose the points you want. For example, let's try to make it a vertical one. For example, we want to see the section view between this circle and this slot. So now let's add this line. When you are done, click OK. So now you have your section view, so you can add it in the place you want. So now you can, when you are done, okay, so you can define the place here a little bit, and let's move this one as well here. So you have your section view, you have the letter E, and here is the section E. So if you want to modify that, just click on that. You can simply type B, enter. So you have section B. For example, if you want to change the direction to make a cross section from the other side, you just flip the arrow here, just click on there. So you click that section, flip direction, click OK. So when you have that section, you can update your drawing. So now we can try another way to make inclined line. So go to section view. This time let's use the auxiliary view. So now we can create this auxiliary view. Now to select place. Okay, so you have that auxiliary view. So here in the option you have the selection view, or either to have it surface or auto hatched and so on. So this is things you can choose it as you want. So now we have this auxiliary view with the hatching line. So when you're done, click OK. In this tutorial, we're going to talk about the detailed view. Detailed view is like magnification for one part, you choosing it. For example, if you are not seeing clearly. For example, let's try to make a detailed view to this area somewhere here. So to do this, first we go to the sketch, create a circle, and let's make a circle here, so that we would like to see detailed view for this. So now, because we already selected detailed view before, so now we have that detailed view. So now let's do it from before again. Let's click detailed view, select draft, then go to sketch, select circle, and again let's select an area we want to have a detailed view for it. So now you have that detailed view to that section. If you want to change the scale, click on that detailed view, and then go to the scale, make it, for example, 1, 2, or make it, for example, 2 to 1. So when you are done, click OK. So you have that detailed view to this part you selected, and you edited also the scale. You are also able to change the view name as we said before. In this tutorial, we're going to use the next type of views, the broken out section. The broken out section is breaking or making a hole inside your part to see inside of it. So let's start activate the broken out section, or before activating the broken out section, click escape. We just want to change the view of the view style of this. Let's select this one and change the view style to be this material. So now let's activate the broken view. Let's draw a spline where we want to make the view, or to exclude the view. So now we're going to select the part which is going to be excluded. So let's select this part. Okay, now let's make the depth. We want to make the cut until this edge. Click OK. So now we are able to see inside this part after creating this broken view. So now we can see the piston rod inside that part. In this tutorial we're going to talk about the next type of views, the alternate position view. This is kind of nice type of viewing. It shows the movement inside the assembly while it is a 2D drawing. So let's start activating the alternate position view. We created only this view. We already know how to create the views, so we just pick it this front view. So now let's go to alternate position view. We can also work with the previous assembly, just here to be more clear to use it. So now we select this view. Now here you change the name, for example alternate position 1, click OK, so your assembly will be open. So now you're going to move this piston rod to its maximum angle, and when you are done, click OK. So here you're having alternate position view showing the movement of your piston rod. So it is a good view to show the movement inside your drawing. We have this drawing sheet. We have been working with it since we started the tutorial about drawing. So as you see, we have here kind of complicated drawing. So it is how it looks in the real companies and in the real life. So today we're going to use the brick view. So the brick view is useful when you have such long parts and you want to save some space in your sheet. So when you have a long part and nothing happen, and that is like continuous shape, we can break that. So let's select break and select this view. Now we have two tabs to select. You have the vertical or the horizontal, so you can try horizontal one, and here you have the types of the cutting line, zigzag, curve, and so on. And here you have the gap you're going to break, so you can going to keep the gap 10 millimeter, and here you're going to select curve, then here's your first cut, then this is the second cut. So as you see, we cutted the part, and normally person can know that this area that B will be continue, so it is clear. So when you are done, click OK. This is the idea how to use your break view. Now we are in the last stage before finishing our drawing and sending it to printing. So as we see, we add all dimensions and we had a look at the views on different views. If you want to use some special views to make some parts clearer to see or whatever. And also if you go to the annotation, you will have the surface finish, word sample, and so on. They are easy to use. Just select what you want to add and select the surface. For example, this piston, its surface, you can add that sample and add the amount of surface finish or whatever. So these types of sample you already studied in the engineering book, and if you need to add them, so you can just select and add. There is nothing special in this. Just now we're going to show an important step before finishing your drawings. You need to show the names of the parts, the number of the parts in your drawing. So this can be done by the bill of material. You can reach the bill of material and annotation menu, tables. Here you'll see bill of materials. So select the drawing, and so we just do it again. Select a view, then go to tables, bill of materials. So you will get this menu, the bill of material menu. You have the standard one and parts only, top level only, and so on. At this moment I'm going to use top level only, and then you will click OK. So now you will see the bill of materials shown in your drawing. So here you can place it in a good place, so you can see the names of the parts engaged in this drawing. And here, if you click here, you will have the ability to change the number, positioning, and so on. Also change the size of the text. So here you have your bit of material. So also you can show it on the parts level, click OK, but in this case we don't have sub assemblies, so you'll get the same table of material. But now we have an issue that we see our bill of material, but we don't know where are the parts. For example, who are not familiar with pistons will not know where is the piston head, piston pin. So here comes the use of balloons. So you have balloons, you are able to add balloons one by one. So for example, this is number one, this is the piston head. Automatically it is marked. So here you have here number one, and if you select this one, you will get number three, which is piston rod. And here you can see number four, which is the piston rod cap. And then you have here number two, the piston pin. So we can also, if you have a lot of parts and you don't want to do it one by one, you just cancel these balloons, click on that, delete it. You have auto balloons, so SolidWorks going to generate the balloons automatically to your parts. So you select, then go to auto balloons. So now click OK, you will see the balloons here inserted automatically. So here you have number three, but still you are missing number two, then you need to add it by yourself. It's not shown in this part, we're going to have it here. So when you are done, click OK. So now our drawing is almost ready to be printed, because it's include all the dimensions, balloons, parts, bill of materials, the title block, and so on. So I hope this set of tutorial was useful and you are ready to create your own drawings. Hello and welcome to the very first tutorial in level 2 in this course of SolidWorks. The level 1 was the first 145, and this is the first tutorial in level 2, and it is tutorial number 146 in the SolidWorks course. In this series we are going to talk about the sheet metal menu. SolidWorks has special menu designed for the sheet metal products. Sheet metal parts or sheet metal part designs are exactly the products which are produced by the manufacturing processes related to sheet metals. As we know, there are many products around us that are made by sheet metal manufacturing process, like knives, the power supply, computer chassis, and many. For example, let's take this sheet metal part which is made in another channel. This part or this product is made by the sheet metal menu, and in industry it is also made by sheet metals. For example, let's take this base here, and As you notice, it is a piece of metal which is punched to get that shape and then bended. SolidWorks in the sheet metal menu has calculated all the values depending on the metal you are using, which you are able to pick the metal, and that is really a time saving and will increase the productivity. So now let's see how to start the sheet metal menu or how to access the sheet metal commands. This is the assembly mode. Start a new part, and let's see how to access the sheet metal commands. The first method, as we said, go to insert, and then you will see a complete menu for sheet metal's commands. You have base, flange, convert, and so on, which we are going to talk about in this series. The second method is which is easier, is to have the menu here on this bar. Go to this menu here and click on right mouse button and then check the sheet metal menu. Here you have your sheet metal menu, and when you press on it you see the sheet metal commands, the base, flange, convert, hem, and so on. As you notice here, many of the commands are not activated. That is because you need to have a sheet metal, a part of sheet metal, to activate the commands. So let's start making our first sheet metal, and it will be very simple. Go to base, flange. So let's create a base. Click on that and pick your plane. Let's pick the top plane and let's make a center rectangle and give it some dimension. For example, let's add 100 millimeter and 200. Press OK and then exit that sketch, and here you have your sheet or this piece of sheet metal. Here to the left you can pick the thickness of this sheet metal, and then you have the other options which we are going to talk in details in the later tutorials. We talked about the bendings, the type of bendings. You will have many options here, and then you have the auto relief. Let's put a 1 millimeter thickness for this sheet metal, and then here you have your first sheet metal. And before finishing this tutorial, I would like to thank Satish, one of our students, for reminding me to start uploading the level 2 tutorials. So see you in the next tutorials. This is tutorial number 147, and it is the second tutorial in the sheet metal series. In this tutorial we are going to talk about these points. First, we are going to talk about some approaches when starting a sheet metal part drawing or design. There are many approaches depending on the shape of the part you are going to make. And then we're going to talk about the first command in sheet metal, the base flange, and we will see what will be new on the tree, on the SolidWorks tree, when we are starting the sheet metal command in general. And then we are going to talk about the key factor and how it is related to the material properties. As we know, there are different sheets, for example, steel, aluminum, copper, and so on. And then we are going to talk a little bit about flatten. So let's go to this part which we have started. Go to sheet metal, and you see here the base flange, and beside the base flange you will see convert to sheet metal, lofted bend, and then you have the forming tools. As you notice, we have only two commands which are activated, and the rest are deactivated, and they will be activated once we start the sheet metal tree. So now let's talk about the approaches. When you start to draw a sheet metal, there are basically, according to the sheet metal menu, 4 approaches to start or to make a sheet metal product. You have the base flange, which is the mostly used, and it is almost 90% of the sheet metal products are created by the use of base flange. Then we have if you have a little bit more complicated shapes, then you have the lofted bend, or you can create it by other commands like SolidWorks Features, then convert it to the sheet metal. As you see here, convert to sheet metals, or by forming tools, which is kind of die mold. Now let's start using the base flange. At the beginning, to make it easier, you can imagine the base flange exactly the same like the extrude. To the sheet metal, we can press directly on the base flange, then we pick the plane we want to draw on it. I just click X, or we start as we used before, picking the plane that we need, then draw the shape. Let's pick the front plane, start sketch. I'm going to make a simple L shape. Let's give it some dimension. Let's give this 50 and here 25. Go to sheet metal and select the base flange. So as you notice, it just extruded the L shape with thickness. Here you see the base flange menu. I'm going to talk about the very basics for now, we are already familiar with. We're going to talk about the directions, the sheet metal parameters, and for the rest we are going to talk in the next tutorials. We are going to talk a little bit about the bend allowance, K factor. Now let's go back to the extruded sheet metal. Here you can pick the thickness. You have 0.75 millimeter. I can put it 1 millimeter. You can notice that the difference. Let's make it clear. 5 millimeter. You have the thickness of the sheet metal. Then you have the bend radius. You notice here we didn't add any radiuses at the corner, but this is the bending radius. It is logical, when you are bending any sheet you get this radius, and here you can specify this radius if you already know the value. So let's put 2 millimeter for that bending. And then if you go to the very first option, direction, it is very similar to the extrude. You have plane, there you can increase the extrusion or the length of this beam, and then you have direction 2. We are already familiar with that, we talked about that in the extrusion. Also you can extrude on the direction 2. Let's deactivate direction 2 for now. Here you have again the same options similar to what we used in extrusion. I'm going to pick mid plane, then you have your extruded part, mid plane extruded, and here you have under the thickness reverse direction, that where is your metal you need to be placed. If you reverse direction, you will notice the sheet metal is extruded inside. If you reverse direction, it will be outside the shape. And when we are done with this shape, click OK, and then we have our bended sheet metal. We talked about the base flange, a very basic explanation. Then we will have to look at the sheet metal tree. As you notice the difference between extrusion and the sheet metal. Here you have 4 elements instead of 1 element in case of extrusion. You have the cut list, then you have the sheet metal, the base flange, feature, command, and then you have the flatten. So these 4 starting every time you use the sheet metal commands. And here you notice the sheet metal commands are activated. The elements of the sheet metal tree, these 4, the cut list, the flatten, and sheet metal, we are going to talk about them in details in the next tutorials. But right now I'm going to just edit, as we learned before. When you need to edit any feature, go to the base flange and edit feature, and you will notice you have only the basic options are appeared, which we discussed. You have the extrusion distance, which you are able to change, and you have the thickness and millimeters. The reason for that is sheet metal, when you start the sheet metal commands, it assumes the whole part will be the same type of sheet metal, so there is no need to specify all the time the thickness and the bending radius, because it is the same metal or the same sheet metal. For some reason, if you wanted to change the thickness or the bendings radius, you can override the values over here. And again, as we discussed it before, let's just click OK. And to get to the sheet metal properties or the material properties, you have the sheet metal here. If you click on edit, and this part is related to the material properties. We said that we're going to talk about that in the later tutorials. A little bit about the K factor. So as we know, there are different types of materials, different materials for sheets. You have steel, aluminum, copper, and SolidWorks calculated the bending radius when you are bending a piece of metal. For example, when you are bending a sheet of steel, you will not get the same dimensions when you are bending a piece of aluminum, and that is defined by the bend allowance auto reliefs or the gauge table. So K factor, as we said, there are different materials. The harder the materials, the K factor will be bigger. Softer the material, the K factor will be smaller. This is a very basic explanation about the expectation of bending a sheet of metal. So now let's just click OK. And the last thing, we have the flat pattern. We will going to talk about that in detail in separate tutorial. The flat pattern, when you bended this sheet of metal, you can again return it to the original shape by unsuppressing this feature. This feature is suppressed on this flat pattern, and unsuppress, you will get again that piece of metal before bending. If you want to exit from the flat pattern, you go to the exit flat pattern here in the corner. Welcome to tutorial number 148 in this SolidWorks course, and the third tutorial in sheet metal series. In this tutorial, we're going to talk about the next sheet metal feature, edge flange, and we'll talk about the first option, flange parameters, which include edit flange, use default radius. So let's start making a piece of sheet metal. Click new part, And first thing, I'm going to specify a material. This is an optional step, just in case if anyone would be interested. And here I'm going to pick a stainless steel sheet. This is a common sheet of metal. Then go to the sheet metal, base flange, pick the plane. Here I'm going to select center rectangle with some dimensions. Sheet metal, base flange, the thickness. Here I'm going to specify 1 millimeter, and here the K factor will be 0.4, and this is why I picked the stainless steel material. So in this case will be 0.4, and in future tutorials we going to talk in details about the bend allowance. Now click OK, and for the reverse you can notice from the drawing here how that will change. Then click OK. Also, I'm going to pick a stainless steel as appearance, and here is a very simple sheet of steel. So let's see how to use the edge flange. Here you will notice the edge flange option. Click on the edge. Is this feature is to creating a flange on the edge. So pick the edge. Here you will see the flange parameters. Select edge. Go to the sheet and select the edge where you're going to create your flange. You're going to select this edge, and then when you reach the length you need, click OK, or on the right mouse button. It is a very simple edge flange, but we have created this shape in the previous tutorial in one single step. Here we have 2 steps, base flange and then edge flange. I'm going to show you how we create it in one single step. Go to the right plane, sketch, normal to, and make L shape. Adding some dimensions. Let's make this coincident or horizontal, and then sheet metal, base flange, to extrude the L shape 100 mid plane. Click OK. As you notice, the sheet metal parameters is grayed out because we already specified it is a sheet of steel with a K factor 0.4, and we can change it as we said in the previous tutorial. For now, click OK. Here you have the second beam we created in one single step. So let's make another shape where we can notice that the edge flange is a handy tool. Go to the right plane and make a U shape. Give it some dimension.
And now let's extrude it by the base flange. Go to the sheet metal, base flange, and here we have a U-shaped beam. And now let's start to use the edge flange. Select edge flange, and this time we're going to select this edge. Now in this case you have the edge flange. You can make it in a way that you cannot do it by the base flange. So here you can select the edge you need. You can select it from below or the above edge and give you the same result. And this arrow, if you click, will change the direction of this edge flange. The second arrow here is the length of the flange. We are also able to change that length in the next options, but for now I am talking about the first option, the flange parameters. And when you change the length, both of the edge flange changing at the same way. And when you are done, click OK. And here you will notice that we bended both sides of this sheet metal. The next option in the edge flange feature is the edit flange profile. For example, when you selected the edge, it selected the whole edge. But how if you need just, for example, to have half of that? You can do that in the edit flange profile, and you'll notice profile sketch. This sketch, you are able now to change it. If you go to the profile, and here is the sketch, you can change it by dragging it freely, change the length of it, and you can even add dimension to that. You can, for example, add 15 and this side 10. You can also change the shape of that sketch. Let's select a line here, select the midpoint here and the midpoint on the second line, and trim the corner. And you will notice how you change the sketch. And when you are done, you simply click finish. And you notice how is the shape of the flange. Go back to the edge flange, edit feature. When we edited the edge flange, we were able to change this side. Let's try to change, and we are just able to finish or to edit this side. There is a second approach. You can reach to the sketch and you can change it on a different way. If you go to the edge flange, that in case you want to change the second side, you will notice that you have two sketches. That sketch we already edited. As you remember, exit from that sketch. You can select, when you hover over this sketch here, edit, and you will notice it is in this side. We can edit this sketch at the same way, add some dimensions and then click OK. And when you are done from that sketch, exit the sketch, and you will have your edge flange edited the same way. So there is two approaches to edit the sketch of the flange. Now let's see the next option in the edge flange. Again, edit feature. You have the use default radius. As we said before, when you create a sheet metal, SolidWorks assume you are working with the same sheet of metal, in this case stainless steel sheet with a thickness of 1 millimeter, and using the same press, which giving you a bending radius of 1 millimeter. So there is kind of no need to change that. If you change, for example, the press, and then you need and the bendings radius changed, according to that you override the values, and you will notice the change. Welcome to tutorial number 149, the fourth tutorial in the sheet metal series. In this tutorial, we're going to continue talking about the edge flange. The next option, the angle, how to add an angle to your flange. There are two options: selecting the angle directly or choosing a reference face. Start a new part. Here I'm going to select the appearance, steel, and create simple base flange as we learned. Make a U shape, some relation, midpoint equal, and let's add some dimension. Extrude it with the sheet metal base flange 100 mid plane. And there you have the steel sheet metal. And now add an edge flange as we learned in the previous tutorial. Go to edge flange, select the edge, extrude it to approximate height, select the second edge, and it will be automatically the same height. And here next you will see the angle option. So this edge flange right now is 90 degrees angle, and here you can change it according to requirement. So I'm going to add 150, and you will notice the shape. Add 120, then okay. Here you will notice how you bended the edge flange with an angle. It is not the perfect shape right now. We can deal with these edges in the later options, but now we see the angle. Also, you can make the angle into the side. Go to the edge flange, edit feature, and change the angle less than 90 degrees. For example, let's add 75. And as you see here, you bended this edit the edge flange again and add 50 because I want to see the intersection error or warning. Click OK. Here you get a warning that there is intersection between the bendings. This issue we can solve it as we learned in the previous tutorial by editing the sketch. Make the edge a little bit thinner, or in the later options we will see how to deal with this bending. So let's get back and make it 90 degrees. So the next option is selecting a face. Right now we cannot select any face, as you notice. We need to create a separated part. Now I will make a wooden core separated part inside this sheet box so that I can bend the next edge flange on it. Select the plane, in this case the right plane, sketch, and intersect here to make it easier to see. Normal 2. Here I'm going to just make a very simple piece of wood. And add to it some dimension. Equal relation here and midpoint. Make this shorter than the edge flange. Make it 10, so it is logical to bend it, and let's add here 75. Extrude this shape with the extrude boss. Make it mid-plane, and 30 will be enough. And make sure to uncheck the merge result so it is a separated part. Back to original, and let's add some appearance to this core. I'm going to make it from wood. So now we have this sheet box and we have a piece of wood inside, and then I want to bend the second edge. So select again sheet metal, edge flange, select the edge and select this face. You can notice you bended the second edge flange parallel to that face. Also, if you select the second edge, go to edge, select the second edge, and you see the angle is calculated according to that shape. It can be difficult to put it by yourself, and here if you make it perpendicular to the face, you will get it in that shape. You can see this edge flange is perpendicular to this edge. Let's make it a little bit shorter so it will not intersect with the inside, and when you are done, click OK. So this is one way to select a reference face. Let's get back again, edit edge flange and make it parallel. Click OK. And this is another case. In the later tutorial we going to create the same shape where this wooden core is tangent with that edge flange. So we'll have some intersection, and the later options will show how we can fix that. Now we can again think about other cases. Delete the second edge on the face. You can also select that face over here. For example, you make it parallel to that face. You can make it perpendicular. It didn't work, but you can make it parallel that face. But this option is not necessary, because you can make this click OK, because you can make the same by selecting edge flange and make the same. So again, back to that edge flange, select the face over here. Okay. So we see many cases by how you can manage the edge flange angle. Welcome to tutorial number 150 in the SolidWorks course, number 5 in the Sheet Metal series. In this tutorial, we're going to talk about the next option on the edge flange menu, which is the flange length. We are going to talk about the types of how you can make the length, blind, up to vertex, up to edge and merge. Also, we're going to talk about the place of edge length, outer, inner, tangent, blend. In the previous tutorial, we talked about the other option, the first option, flange parameters, angle. We talked about them in details. In this tutorial, we're going again to talk in details about the flange length. I started a new part file, and I will make a box from a piece of stainless steel sheet, as we learned in the previous tutorial, and it will be a repetition to the previous. I will choose the front plane and make the box. Go to the sheet metal. Now I have the initial shape of the box. Going to use the edge flange. Select edge flange, select the edge where you're going to create your edge flange, as we learned, and select the other edge. In the previous tutorial, we were stretching the edges manually by the arrow here. Now you are able to add the exact dimension to your edge. For example, let's add 50. When you are done, click OK for now. As you remember, when we created the initial shape on that sketch, let's show that sketch, you will notice that we added 50 millimeter. And when we created the edge flange, We also we picked the blind length and we added 50 millimeter. But you can notice here that the edges, they are not the same length. That is because of the bendings over here. To get the exact length of your edge, you will choose the next option. Go again to the edge flange, edit feature, go to the next option, up to vertex, and you can zoom in and pick the vertex where you want your edge flange to end. And here you can notice we are able to pick that edge. When you are done, click OK. So you will have the exact length for your edge. If you look down to the box, you will notice this type of cut and bendings. Maybe you need to change the position of bending. That will we talk about in the next tutorial, which will be about the flange position. And here, if you notice on up to vertex, you have the left reverse direction. If you click on that, you will reverse the direction of the flange. I'm just going to give it like before. And now you can move again to blind. You will see the length is 51 millimeter. Now I am going to change it to 10 millimeter and pick the first option, outer virtual sharp, and click OK. Edge flange, and over the edge, you will notice the length is 8.26 millimeter. So it was not 10 millimeter. So the 10 millimeter is the length between, if we measure the length from this face, the bottom face, you will get the Y, which is 10 millimeter. So when you pick the 10 millimeter, it is the distance between the top face and the bottom face. So this is the case of outer virtual sharp. Let's edit again and pick the next option, the inner virtual sharp. Click OK. And again, let's measure you can get the measure tool from evaluate measure. If you pick this face and this face, for the distance of Y, you will get delta Y 10 millimeter. So this is the option of inner virtual sharp. So you are able now to know the difference between these two options. And let's again pick the next option. It will be similar to the first option. It will not be clear for this simple shape. So with these options, you can get your exact length from the first time without guessing. Now I will make another edge flange. Select this edge and select edge. And if you hover and expand this menu, you will not still see the third option. Delete one edge. Delete that edge back. You will see up to edge and merge. So let's select this option and select the reference edge. Go to that edge and you'll notice you're not able to select that edge because this edge is higher than that edge. Click OK for now. For this purpose, I'm going to create another sheet of metal. Pick this face, click Sketch, Normal Tool. Small dimension, make sure to be 1 millimeter under. Then up to surface. Okay. So again, return to the edge flange tool, edit feature, go up to the, or this, move this feature up, edit feature, edit up edge and merge, and select this edge. As you notice, it connected to that surface and merged with it. And when you're done, click OK. So this is a way to use the third option. Welcome to tutorial number 151, number 6 in the sheet metal series. In this tutorial, we're going to continue talking about the edge flange, and it will be the last part about edge flange. We will talk about the edge flange position, and then we will see how to make a miter flange from edge flange, and then flange length and mesh. The first thing I would like to say, until this tutorial, you should be able to create sheet metal boxes similar to this without any problem. In the previous tutorial, we showed you many times how to create the same thing. We have this box created in the previous tutorial. We said about this corner down here that it doesn't look the way I would like to see it. To manage this bending, go again to edge flange 1, edit the feature, and here in this section the flange position. The best way to understand this feature is to have a look at the shape over here. For example, we have here material inside. So in this case, the bending is inside. If you select the second option, material outside, you will notice now it looks better. Just click OK. So a better look depending on the requirements. We go again to edit feature to see the next options. Here you have the bend outside. So you have the whole bending outside, as you can see over here. Go and see the next option. Edge flange, and here you will have bend from virtual sharp, and it will be similar to the first option. In this shape it will not be clear, and also the last will looks like the first option for this simple shape. So now let's pick the first option or the third option. Okay, and here you have the bending outside. So what if you need that bending to be a little bit more? You can create an offset. in this case, go to edit feature, and down here you have an offset, and you can extend that surface more. I can add 3 millimeter. So this option gives you offset of 0, and here you can increase that offset the same way as we learned before. You can up to vertex, up to surface, or offset from surface. We went through these options before. So let's make 3 millimeter. And here you have the reverse direction. You can have the offset inside. You can click OK, and if you change it, you will get the offset outside. So now I'm going to show another thing. Go to the edge flange and select the first option without an offset. Click OK. This is our first shape, and I would like to have that surface here to be parallel with this edge or on the same level. But the cut down here doesn't look that perfect. It is sharp in here, and it might tear while bending. We can fix this issue by adding trim. Edit the feature again, and down here trim side bends. Click OK. Now it looks better and easier to bend without the risk of tearing the sheet. Before talking about the edge flange to miter flange, I would like to talk about the merge and length, which we talked about in the previous tutorial. We created this edge flange by up to edge and merge. This feature will work in case you have the second sheet metal with the same thickness with the first. So it should be the same sheet of metal. If we edit this base flange over here and override the values here and add 2, assume we have a different material, different sheet thickness, click OK, and you will get an error. So you should have the same thickness. We use the default parameter and click OK. And now I will talk about the edge flange to miter flange. Suppress this extended sheet over here, suppress, and we have this basic box. We have an option here called miter flange, but we are still on the edge flange command, and we will see how you can create a miter flange by using the edge flange. Go to the edge flange, select this edge, select this edge. Now when you select third edge, you will notice it converted into a miter flange. Select the fourth edge, and now you have this miter shape, and they are overlapping over each other. This for now, click OK, and you will get a warning that this is intersecting. Close for now, and you will see how to fix this. So for fixing the miter intersection, there should be a gap between these two edges. Go again to the edge flange here, and you can notice that you have a gap So this is the gap distance. You can change it, and you can notice here in the shape. You can make it 2 millimeter or 3 millimeter. I keep it 2 millimeter. Then click OK. And now you will notice the warning is solved. You can also, the same option which we talked about in the previous tutorial, you can add an angle. For example, you can make it 100 over here, and you will have the bending inside. Or you can make it outside bend, adding 80. And the next option as well, you can notice over here the length and the position of the flange. And when you are done, click OK. So now we have this box which we wanted to make, and in order to produce this box, you can go to flatten, as we learned, and suppress this option, and you will see the piece of sheet metal need to be cutted to create that box. And here you can exit the flatten. Welcome to tutorial number 152. This tutorial will be a practical example where we which we learned before together in this example. We will review the base flange and the edge flange. We will bend this sheet steel perfectly on this wooden core. Start a new part, file, and then start a sketch on the front plane. Let's start making the wooden cube. Select center point rectangle, give it some dimension. Extrude it to 50 millimeter. And then extrude the surface, the top surface, another 50 millimeter. Select, start sketch, convert entity, extrude 50 with an angle of 30 degrees. Click OK. Let's add some fillet. Select one edge and then select the whole edges over here with a radius of 1 millimeter. Okay. So this is the wooden core. I'll just change the appearance. Now let's make a base flange on the bottom of this block. Click sketch, normal to center rectangle, Make sure to pick the inside edge. Make it for construction. Okay, make another one. Vertically inside edge for construction. Add equal relation to the edges and assign some dimension. Give this one 20, and then you will have the construction fully defined. Pick line and select the corners. Of these rectangles. This is the shape of the base sheet or base flange. Go to the sheet metal, base flange, and you'll have the sheet. Make the thickness to be 1 millimeter, reverse direction, and without checking the merge result, because this will be a sheet. The K factor will be 0.4. And now let's see how to make edge flange that are perfectly bended on this wooden core. Go to the edge flange, select the edge, this edge, select second side, third side, and fourth side. Now let's go have a closer look at the edge. Now you will see the bended steel is overlapping over the core. This overlap in case there you are bending this sheet of steel without any help or without anything, but we're going to override this value because we have this wooden core as a helping core for bending the bend radius to 1 millimeter. And you see you have the bend radius is on the wooden core. And you can check as well on the other side. You will notice all this side are perfectly matching. So now how to extend this edge to this edge over here. As we learn, go to the flange length and select up to vertex and select this point. You will notice that the edge flange is perfectly matching that edge. When you are done, click OK. And one thing before closing, you might have this selected and this is overlapping. You can pick the bend outside, click OK. Go to edge flange, select the edge, then you will have an option for the edge flange angle. Select face, go to the face and select the face, and then to make the exact length, go to the bend up to vertex and select this point. Let's check that bending is correct. So you will notice here the bending is from. So you go again here to the flange position, select bend outside, and you will see again that the bending is not perfectly matching the edge. You can override the bend radius to be 1 millimeter, and you'll have the bend is matching the edge. When you are done, you can select the rest of the edges. When you are done, click OK. You might get this not correctly showing. You can just edit the feature and check that it's up to vertex and go again, and it will be corrected. And now time for the last bending, and this one will be easier. Go to the edge flange, select the edge, extruded or push flange length, make it 10 millimeter, and check it is correctly bended. If not, you adjust the angle over here. Select face and select this face, and for the radius override 1 millimeter. When you are done, select the rest of the edges. Okay. So now we have this piece of sheet metal perfectly bended on that wooden core. And these are two separated bodies. You can notice them over here, over the cut list. So now let's try to flatten that. And here you have, go to the first extrude, show, and you will see the wooden core inside. And unflatten or bend it again. And one last thing I would like to show. Let's edit the last bended edge over here with the edge flange. Edit flange length to 20 millimeter. You will notice the edges got trimmed automatically, and we can edit the gap as we learn. We can make 2 millimeter or 0. I will keep it 1 millimeter. Okay. Welcome to tutorial number 153. In this tutorial, we will talk about the next command, the miter flange. We will talk about the basics of using the miter flange, and we will make a simple example and show you how to make a miter flange, and then we will make another example to compare it with the edge flange and see the differences. In the previous tutorial, we talked about the edge flange and the base flange. When we start using the miter flange and the next commands, you will see many options are similar, so you should be familiar with them. Here I start a new part file. So let's start to make a very basic base of steel. Select top plan, base flange, and center rectangle with some dimension. Sheet metal base flange, give it 1 millimeter thickness, 0.4 K factor, click OK. Now I will make a basic edge flange, but by using the miter flange. Go to the miter flange, and once you pick the miter flange, you will see the message here. And you will notice there are two options to start miter flange. Simply, I can say you can just pick the edge where you want to create your miter flange. So let's pick this edge, and once you pick that edge, SolidWorks automatically opens to you a sketch. It's sketch 6, and also inserting a plane. So this sketch, you are going to draw your edge or miter flange. So click normal tool, select the line, and we said we want to make it edge flange. So it will be, in this case, just a line. So give it a dimension 50. Click OK. Plane or the sketch is perpendicular to the edge you selected. So now when we exit, you will notice you got that edge flange. And here you will see similar options and start, and which we will talk later about the start and end offset. For now, click OK. So as we said, once you create a miter flange, it will create a plane for you and a sketch. For now, there are nothing special. We already learned how to create a similar shape by the edge flange. So let's see what we can do more with the edge or the miter flange. Go to the miter flange, edit feature, and on the miter parameters, select the rest of the edges. And as you notice, you are simply creating many edge flanges by selecting the edges in series. And when you are done, click OK. Hide this plane. So now you got this box. So now let's continue about the next options. Go again to the miter flange, edit. The radius is already selected, and let's see the other options. We already talked about the flange position. Let's make it outside, and the gap distance, it is the gap between the edges or the flanges. You can make it 0.25 or 0.5. I will wait 0.1, so you know it means this gap. So now to the next option, start and end offset. You remember the base sketch which started the miters. It is sketch 6, and you will notice it is in the corner over here. So the start and end gap, you will notice it means the start gap of the sketch. Let's see the start 0 and the end 5 millimeter. You will notice the gap with the starting sketch, and you can make the start also 5. You will get the start and end gap. I make it 2 millimeter and 2 millimeter. And when you are done, click OK. So at this point we worked with the miter flange and we saw the options. But for now there is nothing special. We already could make this shape with the edge flange. The only difference right now is the end and the start. So now I will make another example that will show you the difference between the edge flange and the miter flange. As you remember, we made this box in previous tutorial. We made it base flange, edge flange, and another edge flange. 3 steps. So the first is flange, a U shape, as you notice here, and then we made the edge flanges over here and here, and then we made the miter flanges over here by the edge flange. And as you remember, with the third flange we have an angle of 80 degrees. So let's see how to create a similar box but with the miter flange. Start a new part. Start by making a base plate on the top plane by the base flange. Select a center rectangle, make the 2 edges equal, dimension 100 millimeter, base flange 0.41. OK. Select a miter flange and select the edge where you want to create. So we open it, sketch, normal 2, and now let's make a sketch. And this time we will have a second line. So this is the first difference. You have to actually make 2 edges at once. So let's give it some dimension, and the angle we said 80 from outside, so it is 100, and give this edge 20. And when you are done, exit the sketch and select the rest of the edges. And when you are done, click OK. And as you know, we talked about the option over here. Just click OK, and you will notice that we created the same box in just 2 steps. So you will see that this tool is a time saving, and also you are able to create several edges at once. There are cases where the miter flange might not work. For example, if you would like to pick a miter flange in series, the edges should be on one singular part. I mean, when we created this miter flange, we make it in one single plate so we could select the edges on series. And also, the starting sketch should be on a perpendicular plane on the selected edge. For example, let's start to make a miter flange on this edge. Click miter flange, select that edge, and we started a sketch. When you go normal to, you will see the plane is not perpendicular on the edge on that surface over here. So this might create a problem and the miter flange won't work. So let's make a line, select this plane, and make a line, exit. You will see view when you click OK. There is an error that it couldn't work. Exit that sketch, and you can make it with an edge flange, but we will see how to make it again with the miter flange. And delete this plane. So go again to the same miter flange. There is no need to create an edge flange. We will save the steps, go to the miter flange and edit sketch normal to, and add another two edges. Give it equal relation and dimension 10 millimeter and exit. You will notice the shape is updated. So we created this box with only two steps with the help of miter flange. So you will see how time saving is this tool. And imagine if you would like to create this shape with only the edge flange, you need 1, 2, 3, 4 steps. And also it allows you to create detailed sketches that cannot be created by the edge flange. For example, let's go back to the starting sketch, sketch 6, edit, sketch, normal to, and let's add a bended edge or a hem, pick arc, and define it some relation, dimension, for example this bended edge. Exit from the sketch and you will see that you created that hem. You can flatten, see how it looks. Welcome to SolidWorks tutorial number 154. In this tutorial we're going to talk about the next feature in the sheet metal after the miter flange hem. We will talk about how to use the hem feature, the reasons I started a new part. So let's first make a very basic plate to explain the hem feature. So this is a basic plate, this dimension, click OK. So we have a plate here. Here we have our basic plate. Go to the hem feature over here, and here you will see the options. You have edges, and where's start bending, either inside or outside, adding material to the base, and you have the types and size. I'm going to select first the closed one, and you can notice the shape of the hem. So you're going to pick this edge, and here you see this bending, and you can give it a length, for example 20 or 5 mil. And this is a bending outside. You will see the bended sheet is added, and if you pick inside, bend will be included in the base plate. And then you can select the next one, the open. Here is not shown because the value here might be small. We'll change it to 10, and you will see the type of this pen. So this type of pen mostly can be decorational or doing some function. Here you can change the length, and the inside or the gap distance. You can make it 10 and make it outside, and you will get this shape. So let's move to the next type. Go to the hem and select the tier top. This one will always touch the base, and here you can change the degrees and the inside radius. I can make it 1 millimeter. The types of hem explain the reason why you are using them. The hem are used mostly for safety reason because the sheet edges are sharp, and it can also for doing some function. For example, you can pass some wires inside or for decorational reason. And the last type over here, rolled, where you will get the same type, but you will have a chance to make a gap. If you this one, you will always touch the base sheet, and here you will get with a gap. For example, you can make radius 2 and the control the angle. Click OK. Also with the hem feature, you are able to pick many edges at the same time. Go again and edit the edge, and select the rest of the edges. So you can notice over here. So you can imagine this kind of, and you are able to reverse the direction of the hem. If you look to the left, you can pick the edge and reverse the direction. For example, 1 by 1, or you can reverse them all. And one thing before closing this example, if you go to the hem and pick it the first type closed, you will notice the length of 10 here. You will notice SolidWorks will trim the corner. This is kind of small steel door. Welcome to tutorial number 155. In this tutorial, we will continue talking about the hem and see how to edit and compare it with the miter flange and see the differences. At the end, we will make an example using the hem. We made this box in one of the previous tutorials and we created that hem here, as you see, manually with the miter flange. As you remember, if you go to the starting sketch, sketch 6, edit sketch, normal 2, and you will see here we created that hem. But we also could do it by the hem feature. But the difference here that you are able to create a custom shape hems that are not available in the hem options. For example, we can add an extra extend here. And then make this distance 2.2. Exit, and you will notice we created a custom shape hem. You can click OK. So this shape is not available with the hem feature. So this is one thing. Also, if you notice here, you could create that hem without any intersection here in between. So let's try with hem. So just one thing in the sketch here, we made this distance 2.2 so that the sheets will not intersect. Otherwise, you will get an error. Here, suppress or make this to construction for now. And exit. Now we don't have any hem over here, so let's try to use the hem feature. Go to the sheet metal, hem, and on the edge select that edge. So you can edit the values. You can select this type for now. You can reverse the edge, select second edge, click OK. So here you got an building error because of the intersection. Let's try to make it bend outside, and also let's make this type. But you still have the intersection over here. Click OK. So you get an intersection here that we could avoid by using the miter flange as we see before. So let's again edit the hem. You can try also the values over here. Also, you have another thing to do if you would like to fix this thing. You go here to the edit hem width. So you can drag this edge and the other edge, and then click finish. So this is one way to edit the hem, and also you can try to edit that edge as we learned. You can go to the hem. You have this sketch over here if you would like to edit the second hem. So you can edit it manually. You can add dimension. We didn't select all the edges because I wanted to show you that we also can mirror the feature. If we select the right plane and then go to the feature, mirror, and select the hem, pick geometry, OK. The second edge, you can do the same, mirror, and select the front plane, and select that edge, click OK, geometry, So I made the hem on the opposite side, so it will be easier to see the edges and how to deal with this. So one way to deal with this intersection to increase the gap over here, but sometimes the gap should not be increased. But let's just see how to do it. Go to the miter flange and edit feature, and here the gap distance, we can make it 1 millimeter. In this case, we can use the manual hem. So let's suppress this hem and again return normal to is it. And let's again edit the gap of 0.01. Click OK. We have a hem that is not intersecting. So these are some of the differences between using both. So hem, it can be faster in simple shapes, and the manual hem integrated with the miter sketch can be easier in more detailed shapes. So now I'm going to start a new example, start a new part, so we can see how to use the hem with two different functions. I go to the top plane and create sketch. So if you try to create a press flange with this sketch, you will get an error because of intersection. So go to the sketch and trim the edges over here. This flange, click OK. With the thickness of 1 millimeter, click OK. So let's go to the hem. First of all, we need to add a safety bending for the sharp edges. Go to the hem and select the edges. We will pick this type, give it a distance of 10 millimeter, and select the rest of the edges. As you notice, we are able to hem this shape as well. Click OK. So this bending is to avoid the sharp edges as many of the sheet plates. Now let's make another hem to do a function to hold the door. Go to the hem, and this time I will pick the teardrop and select this edge, make it 2.5, and the angle, you can edit the angle according to requirement. And you can also bend it inside. Select the other, then click OK. and we have this door over here. So we use the hem for two reasons. First, to avoid the sharp edges in the first hem, and for making a function to hold it with a hinge. You can edit the edge, the sketch, if to make it, if required, make it a bit shorter. Click OK. When you are done, click OK. Welcome to tutorial number 156. In this tutorial, we're going to talk about the next feature after the hem, the jog. And if you hover over the feature, you will see a brief definition of this feature. And there is a sketched line. For that reason, I thought to start talking about the bending lines and the boundary box lines before starting the feature. And then use the jog in two cases, closing and offsetting. So first, what are the bending lines? We have this box which we made in one of the previous tutorials, and if you flatten that box, you will have the sheet, the original sheet metal. And if you notice over there, you will see dashed lines, vertical dashed lines and horizontal dashed line, and those are representing the bending lines. So they are showing at this edge or at this side you are going to bend. These bending lines are important because without them you don't know where to bend exactly. So you can imagine this is the 2D drawing, and let's hide the sketches. And if you send this piece for manufacturing, they can cut it by the method they are using, either milling, punching, water jet, or whatever. But after that, for example, you don't exactly know where are the bends. So let's again show the bending lines. And here you can know exactly that there's a bending over here and then here and so on. Also, you can access the bending lines. If you go to the flatten, also you can see them all in one sketch in the bend line sketch over here. And the one after that is the boundary box lines. So they are representing the outside boundary of this shape. So you can imagine if you would like to cut this piece of sheet metal, that you need to send it is representing this boundary over here, which we can see it by the boundary box. So let's unflat this box and start a new part to use the jog feature. I will make a box. I will go to the top plane and select the corner rectangle and make a rectangle and give it some dimension. And this rectangle, if I would like to extrude it with the base flange, let's try to extrude it with the base flange. You will get only the plate, but this is not the thing I want. Close it and make an opening in this sketch. And take corner rectangle and make it or construction, and then trim the entities. You can give again some dimension over here. And trim the unnecessary edges. And again go to sheet metal, base flange, extruded to 100 millimeter. Click OK. So now we have sheet metal box with an opening over there, and you will see how to close this with the jog feature. So to close this, logically you need to bend this side over there and extend that edge under it. So let's see how to do it in the jog feature. So we learned that there's bending lines. So the jog will ask you about a plane where you create a sketch or to have a sketch. So let's first try the first method by creating a sketch. So select this plane. SolidWorks will open to you directly a sketch. So go to normal 2 and then create a bending line. Here you are going to create your bending and give it a dimension of 10 millimeter. Then exit, and here the jog options. The fixed face, it is clear to be this face, and here you will see that you are offsetting the edge. And if you make it normal 2, you will see the edge will remain the same but with an offset. And the next command, jog offset, can be blind. There you can add distance or up to vertex, up to surface, which we mentioned before. And then you have the dimension position. So we pick it 10 millimeter. So the 10 millimeter will be from the down edge to the upper edge, or from the inside edges over here and there, or from the inside edge over here to the outside edge over here. So in this case, we know that the thickness is 1 millimeter, so I will make it 1.1 and give it some tolerance. Here to the left, you can reverse the direction. We said that the edges are matching, but here you can the bend included in the length. Check that. And the choke position, you can decide where to make this bend, after the line, or in the center of the line, or on the edge of that line. And here is the angle if you would like to add an angle to the bend. I can make it 80 degrees, 70, or 50, so it will be matching the edge, and give it some tolerance. And then when you are done, click OK. So let's make the recommended minimum 1.28. Click OK. So now we bended this edge, so let's extend the other edge to close the box. So after creating this jog, so let's extend the other side to close this box. We will do that by the base flange. If you notice here over the command base flange / tab. So let's see how to extend that edge or make that tab. Click on that face, sketch, normal to, and draw a rectangle. So you can see the edges where to start this rectangle. From this side, before the bending, and ended on the down corner. And the rectangle is fully defined. Go to the sheet metal, base flange, and here merge results. Click OK. So now it will be one single sheet. And if you notice over there in the tree, SolidWorks recognize it as a tab, and it has its own sketch. Welcome to tutorial number 157. In the previous tutorial, we made this box and we made that jog close the box. So in this tutorial, we will see the second method of creating a jog by an existing sketch. We will make a hanging tab on this box. So let's start a sketch on that face. Normal to, and I will draw a slot and define it with dimensions. And add relation. So here we have this slot, and I will make it for construction because I need the down part. Put the line and quickly make this seam slot. So if you go to the extrude to make the cut, you'll notice that the thin feature is not working. So let's create the sketch manually. Go to the sketch, offset, and offset for 1.5 millimeter. Click OK. And close the gaps. Go to the Extruded cut, and here up to next. So now let's start a sketch for the bending line. Click on the same face, sketch, normal to, and now I will place the bending line over here and see if it will be accepted. Go to the exit the sketch or go to the jog, you'll see that the jog is activated over here. And the fixed face, select this face, but you'll notice that the jog feature didn't work and you didn't get the right view. So close this, and again let's edit this line. So again, let's talk about the bending lines. The bending lines should be in the center of the bending radius. For example, exit that sketch and go to sheet metal and flatten. And here you will notice the bending line. And let's again bend it again, just to make it clear here. Here you have the bending line, and flatten. Let's hover over the bending lines here, over here, and you will notice the bending line is in the center of the bendings. So let's again edit the sketch, normal to, and let's add a distance. So delete this line and make a new line. So you see we made a distance from the line and the bending. So let's make it 1 millimeter, and it should be not less than bending radius, which is 0.7 something. So now let's go to the jog, select the fixed face, and now here you have the jog is working. So this is one issue we could solve, and here you will see the option that we talked about before. I would like to make it 5 millimeter from this face to inside face of the tab. The bending is inside. If we can also make it outside, or so make it inside, and the angle I will make it 40 degree. And then click OK. Here we created this tab, but there will be an issue with this tab. So let's flatten this tab. So you flatten the tab, and if you have a look over there, you'll see that the tab is intersecting with the plate. And we can solve this either to make the cut bigger, or as we learned before, or to make the bending radius of the jog included in the total length, which is more logical. So edit this feature and go to fix projected length. So, and this is the realistic, or mostly how it looks. And click OK. Flatten, and you'll see the cut will be similar to the sketch we made to create this tab. And flatten. Now let's close this box. Select edge flange, select this and up to vertex, and select this point, and also select the opposite edge. Then click OK. And here is the box initially closed. And if you would like to improve it further, you can try to reverse the direction of this closing jog and add more edge flanges on this side, similar to this. So I can close this one. Welcome to tutorial number 158. In this tutorial, we will talk about the next command in Sheet Metal, Sketch Bin. And we will go straight to apply this feature with an example. And then we'll see some cases how to deal with the Sketch Bin. And then talk about the advantages of Sketch Bin and compare it with the base flange. Start a new part OK, and we will draw a shelf hanger. I will start from the front plane and draw a triangle, and let's give it some dimension. $200 and add relations. Fillet the down corner. And make place for holes, so it'll be easier to save some time. We can make the holes already here. So this is the basic sketch of the hanger, and we will mirror this sketch. Make this for construction and mirror Click on this to uncheck it and the mirror about this side. Go to the sheet metal base flange and make it a thickness of 1 millimeter. Click OK. So now we have this flange, and now we'll see how to bend it with the sketched bend. So sketched bend is a feature to bend some sheets. Fillet these edges, feature fillet 10. Okay. So now we can bend this hanger with the sketched bend feature over here. So to use the sketched bend, click on it and you will again get two options as we talked about in the previous tutorial, similar to the jog. So you should be familiar with this. So directly I'm going to pick the face, and here SolidWorks will start a sketch to draw a bending line. Click normal to, and the line you will make it in the center of this flange. And when you are done, exit, and SolidWorks will ask you about the bend parameters. This is the fixed face, similar to the jog, and now you'll see you are able to bend it. And here are the options which we already talked about, inside, outside, and I will just keep it in the center of the bending line, and here you can make it with an angle. So I'll make it 89. And for the hangers, you notice that the radius is a bit bigger, so you can override the value to type 10. Okay, we can click OK. And the hole, we can make them a little bit down. So let's make this sketched bend. Sometimes when you can get complicated faces or boxes and you need to bend some edges, and it can be difficult to make it with the edge flange. So this feature is flexible, that you just can draw a line and bend wherever you want. And also one advantage with using this sketched bend, that you will get a smooth edge over there. If we flatten, because we already draw that sketch and we see it is smooth, and when you exit you will notice the edges as well are smooth. And let's compare it with the base flange. So if you would like to make the same shape with the base flange, it can be done, because this shape is kind of simple, but in some detailed sketches or in some detailed places where you need some bends, you cannot made by base flange. But let's try to start a sketch for the base flange in the right plane and draw a 90-degree. The sheet metal base flange mid plane, and we set the The radius is 10 millimeter. Okay, and here is the first step. And then to create this triangle, you need to cut over here, and then again another step over there. And another thing, the cut here is on an angle, so if you would like to cut this side and then this side, you will not get a smooth edge as in the case of the sketch sheet pen, because the original shape of the sketch is made and then bended. And now let's see another case where the base flange cannot make it. So we will make a partial sketch shape bend. Go to the original sketch, edit, we will create a tab to support this hanger. So I will draw corner rectangle, and define it some dimensions. And create a tab cut. Make this construction offset entities 1 millimeter, offset reverse. Okay, and close the cut. And now exit. You'll notice that this tab is already bended with the sketch, but I wanted to keep this straight. So let's see how to do this. We can edit this feature again, go to normal tool, or we can start again to show you how it can be done. Suppress this feature. To give it a chance to be bended, we can extend that cut. Make a similar. And define it. Make this construction. So we extended the cut. And now let's try to keep this straight and see and start the sketch sheet bend. And line from this side to this side. Exit the fixed face is this. You can select one of these options. When you are done, click OK. So here you can see that we could partially bend this hanger, and this cannot be done with this flange. Welcome to tutorial number 159. In this tutorial, we will talk about the next sheet metal command, the cross break. In this tutorial, we will see what is the cross break and why, and have a look at some real examples, and then see how to apply the cross break on a single face and see the options of a cross break. And then we will have another example to show you how to apply the cross break on multiple faces. Then we will have a look how to know the direction of cross break. The cross break, from its name, it is a break with the shape of cross on a sheet metal face, or in other words, cross bend. Here I have a real picture for a real example. Here we have a sheet of metal where the cross break is applied on that face. So why they are using the cross break? When the sheet metal face become long, they become weaker. So the cross break is to add some support to the sheet metal and increase stiffness and rigidity of the face when it become longer. Or in simple words, to make the sheet metal stronger. Here we see this on a single face, and here I have another picture for a duct where you can see clearly how the cross break looks like. So this is somehow a long sheet metal, and this cross break will support and decrease the vibration. And let's get back to the first image. If you have a look, you will see that the cross bend has a radius and has a depth, and as well it has an angle. So when we come to the command in SolidWorks, so it will be clear what it means with the angle and the radius. Go back to SolidWorks and start a new part, and let's try to make a similar thing. Sketch on the top plane. I will pick a corner rectangle and make a rectangle and give it some dimensions. So I will make it 2 meters. So it is 2000 millimeter, and the length, make it 1000. Create a plate with a thickness 1.5. Click OK. So here is the base steel plate, and let's add some edges. So select the edge, give it dimension of length of 30 millimeter, and then select the rest of the edges. When you are done, click OK. And here on the bend radius, I'll make it 5 millimeter. Now we have a single face plate, so let's add a cross break to this face. Go to the cross break command, and here the cross break options will open over there, and here you're going to select the first where you're going to apply the cross break. So as you remember in the picture over here, so we will make something similar, and I pick this face, and if you look the arrow over there, that is the direction of the cross break. So it is upward, and if you would like to reverse it, you make it downward, but it is upward. And here we said the bending has a radius, so let's make it 5 millimeter, and the angle almost 100. So you can guess the angle over there. It is quite deep cross break, so we can guess the angle to be kind of 135. And when you are done, click OK. SolidWorks will not show you a 3D view of the cross break, but this line, they will indicate there are cross break over there as well. On the feature tree, you can see the cross break. So let's again talk about the cross break options. Go to the cross break, edit feature, and you have here edit cross profile. To have a successful cross break, the cross break lines be coincident with the edges. So go to edit the cross break profile, and now you are able to see the lines and modify them. So for example, if delete this coincident relation and make the line shorter, here you will notice the finish is not activated, so it will not actually work. If you go back and then click OK, you will get error. So edit the line again, and let's this time add it on this edge. So now it is coincident with this edge, but it is not on the corner. So you can add some dimension there, 20, and then finish. So you will notice that the cross break is working. You can do the same on the other edges as well. Finish the sketch. So you will have the cross break applied as you see. So now let's try to make on a cross break on a multiple faces as you see here. Start a new part. Go to the top plane and create the base of that box. I'll select the corner rectangle and give it some dimensions. Equal, and over here I will make an opening So again, select corner rectangle and add some dimensions to it from this edge to this line 5 millimeter, and from this edge to 5 millimeter, and trim unnecessary part. So you can fully define. The dimensions are already assigned, so you can just simply fully define the sketch. Okay. Extrude this sheet metal or this sheet metal box. The bend radius 5 millimeter, the sheet thickness millimeter. Click OK. So here is the initial duct, and now let's apply the cross break on the faces. Select cross break here 5 millimeter, and if you notice in the picture, the duct here is not as deep as in the previous one. So in this case, the angle can be around 165. So 170 is like the most of the cross breaks around. So we can make it around that value 165. So pick here in the face, select the faces, and you notice that you are able to apply the cross break only one time, and SolidWorks not allow you to select multiple faces. So when you are done, click OK. And over here we can, before applying the cross break at the rest of the faces, we try to close this gap. We can do it by adding an edge flange over there, give it a distance 30 millimeter, select offset 2 millimeter, and click OK. So it is clear that this face or this edge over there will be spot welded with that. So now let's apply the cross break on the rest of the faces. Cross break, select this face, OK. Cross break in this face, as we saw in the picture, is upward. Click OK. And the last one, it will be a little bit special because of the adhering edge. So let's see, apply cross break, and then this edge or this distance over there, it should be welded with to the edge over there. So we need to edit the place of the cross breaks lines and make this point and this point vertical, and this point with this edge make it coincident. So now it's fully defined. and as well in the same here. Delete the previous operation and this point to this point, make it coincident, and it will be directly defined. Click OK. So we can apply the same gap on the other two edges to give it some symmetry, and to do that you can measure the distance over there, and it is 23.5. Let's try to, and you can keep them, or you can keep them as they are. When you are done, click Finish. In reality, as we saw, it looks something like this. And one last thing I want to say, how to know the direction of the cross break. As we said, there is no 3D view for the cross break. There are two ways. First way, if you go to the cross break, edit, and you will see the arrow over there. And there is also the method that they look at it in industry is on the drawing, because there are some values can be shown. And this is we will talk about when we came to the drawing with the sheet metal. Welcome to tutorial number 160. This tutorial will be a theoretical tutorial, but it will be important tutorial to understand the logics behind the sheet metal bendings in order to get an accurate sheet metal's dimensions. In this tutorial, we will talk about the sheet metal trees and where to locate the bend allowance menu, and then talk about different materials, calculating the K factor, and see general K factor values. And then at the end of this tutorial, we will see some programs that calculate the K factor. So here we have a new part file. Start with the top plane and draw a V shape. I'll define it here and give it some dimension. And here give it a symmetry relation. And now make sheet metal beam from this V shape by the base flange, and here give it a length of 150. As you remember, we talked in the early tutorials that we will talk later about the bend allowance over here. So we will discuss this menu now. So if you open the bend allowance, you will find many methods to calculate the bend allowance. You have the bend table, which will be the topic of the next lecture, and the K factor, and then the bend allowance, which is a longer equation that includes the K factor. We will look at the formula of bend allowance, and then the bend deduction and bend calculation. The last two, they are mostly based on experience, and so we will discuss more the first three options, and then in the tutorial after the next one we will talk about the gauge table, where you can combine the bend table and K factor, a saving time method. So now, for now, pick a K factor, and as you remember in the previous tutorial we said this will be a stainless steel sheet, and we assign 0.4 K factor, and we will see how we came to this value. And then when you are done, click OK. We said in the tree you will get the cut list and the sheet metal and the base flange, and if you want to get back to the theoretical values, you should edit the sheet metal over here, and here you can find or adjust the bend allowance, but you cannot find it in the base flange. The reason for that, we said it considered the whole work on the same type of sheet metal or one single sheet metal part. And let's say just specify a material to make it clear that we are dealing with stainless steel sheet. Why there is a bend allowance? The reason for that, there are different materials, and as we said, when you bend a sheet of aluminum, it will not give you the same dimension as bending a sheet of steel, and so on with the copper. Also, the type of press you are using. If you have a press with a bigger bending radius, also that will affect, for example, the K factor. The K factor is the ratio between the neutral line and the thickness of the sheet metal. As we can see here we have the neutral line, and here we have the thickness is T over there. The place of the neutral line can be changed depending on the bend radius and the bend angle. Now again, go to the sheet metal, and let's talk about the bend allowance. The bend allowance is kind of more accurate way because it used the complete formula, which we can see it over here. The bend allowance is by multiply with the radius, the bend radius plus KT over 180. So this is the formula of the bend allowance. In one of the next tutorial, we will talk about the gauge tables, a popular method in the industries which combine both methods. Here I return to the K factor, click OK. Now you may think it is a complicated process, but it is not, because the values are already calculated for the most used sheets. There are bending tables we will talk about in the next tutorial, and also there are even a faster way called gauge tables, will be also the topic of the tutorial after the next. And here, if you go to the Wikipedia, you can read more to understand this topic, and you will notice it is. So I recommend you to read this article about bending. It will give you a wider understanding about the sheet metal bendings. And here you will see the types. Also, you have the punch, and at the end you'll see more detail about calculating the K factor and bend allowance, as we said. And then you have a general table that you may use for the most standard sheet metals of aluminiums and steel, and here the value of the K factor, which you can pick according to the radius, bend radius. For example, we have in our example, this back to the values over there, we have the bend radius 0.7 and thickness is 1 millimeter. Material is steel. You can find the value will be 0.4. And also, as you notice here, when the bend radius is increasing compared to the thickness, the value of K factor is increasing as well, and the hardness of the material will also affect the K factor. As we know, the steel is harder than aluminium. Here is an example for a sheet metal industry, example for a bending press, and they have also their for calculating the bend and K factors. And you can start it here, and if you go to the bend deduction, you can see very easily the values over there and calculate the K factor. As you remember, we used stainless steel in our example, and we made the thickness 1 millimeter and the A side and the angle 75, the A side 126 and 126. Then calculate, and here you will see the value of K factor. It is close 0.4. If you remember, we said if you increase the bending radius, that will increase the K factor. Here you have the bending radius. Let's make it 2 millimeter, and you will notice the K factor became 0.5 and so on. If you make it 0.4 or more, it will be 0.6. Now return to our sheet metal beam and go to the sheet metal to modify the values. Here you can change it according to the website, or you can keep it 0.4. I'll make it 38, and you know from where I bring the 0.38. Click OK. Welcome to tutorial number 161. In this tutorial, we will talk about the next method in bend allowance, the bend tables. The bend tables include the values, and according to the material and thickness, they can calculate the bendings. So in this tutorial, we will see how to create new bend tables and locate the already existed SolidWorks tables, and if needed to modify, and how to apply it on sheet metal parts. So to insert sheet metal bend table, so you go to insert sheet metal, and down there, and there you will find bend table. And there are two ways, either to use an existing file, which we will see, or create a new table. A better way is to create a new table based on the saved tables inside SolidWorks directory. So to find the sheet metal bend tables in SolidWorks, go to the program files, the SolidWorks directory, SolidWorks Core, SolidWorks, and language English, and sheet metal bend tables. And here you will see samples. Here is a PTL file or a text file that is a sample, can be edited. So you can create a copy from that and edit it. And also there are some samples that are ready to be filled. So it's recommended before filling this, making a copy, for example. Here you have a copy, and then fill the values if you have them, so you can fill the table over there. And in SolidWorks also there are some bend tables which are ready filled, but they are not a lot. That's why we will just show you the bend tables, and in the next tutorial we will show you how to use the gauge tables. So through this course we will be using those two methods, the key factor or the gauge tables. And here you have table 1, it is in inches, and also there is the metric bend allowance. And if you see over there, it is for the 90 degrees bends. We will go back to the file and try to see how to implement the bend table. So let's just edit the sketch over there and make it 90 degrees. Okay, rebuild, and then go to the sheet metal features, and we saw in the previous tutorial that we calculated how we calculated the key factor, and now let's see the other method, bend table. So once you pick the bend table, it will ask you to browse the place for your bend table, which we already saw before. So you can again go to the same folder, bend table, and if you click OK, you remember in that folder there were just empty tables, that they are here, sample, and here is the copy which we made. If you click OK, you will get warning because it is an empty table, so it couldn't calculate anything. So let's again go to that table, override bend table, and browse the fillet metric table, bend allowance, and here is the table which we already saw. Click in there, click OK. And now you calculated the bend by the bend table. Welcome to tutorial number 162. In this tutorial, we will talk about a popular method for determining the sheet metal properties, and we will see what is gauge table and why and where to locate them, use them, and then show you some examples, and also show you how you can make your own gauge table depending on your requirements. First, start a new part, and I will make a simple sheet metal beam on front plane, and give it some dimensions. Go to the sheet metal, this flange, and the length, make it 200. Click OK. I will assume this is steel beam and the thickness was 1 millimeter, as you see. Now go to the sheet metal properties, edit feature, and as you remember, here are the values which we showed you how to calculate, and here is the K factor. But you may ask yourself that if you are working with few types of sheet metals and you are already know the bending radius and the thickness and the K factor and already calculated the K factor, and ask yourself that these values should have been saved somewhere and used directly without the use to re-enter them. So this is the work of the gauge table. If you look over there, you will notice there is use of gauge table. So this is the method. For example, you can edit your own gauge table and add these values in there, and every time you start a sheet metal part, you just load the gauge table, and automatically is a time-saving method, and it is very popular at industries. Before checking the use of gauge table, I would like to locate them on your computer. So they are found on the SolidWorks folder. So if you go to computer, program files, SolidWorks code, and then SolidWorks language and English, here you will find the gauge tables already over the bend tables which we talked about in the previous tutorial. And if you open the gauge table folder, you will see many examples. So each gauge table, depending on the method you are following, so there are gauge tables based on the bend allowance, which we showed you the formula. You have the bend deduction and then the K factor, and there are some sample tables. And we said that we concentrating on the K factors method. So here you have the K factor in inches. If you open that, and you will see there are two thicknesses, but these are inches, and here you see in millimeters. And here you can see the gauge table, and it looks, and this is how the gauge table looks like. It is a bit different than the bending table, and here is the for which material. It is steel, but it is clear it is not the stainless steel because of the value of the K factor. And the process is the air bending. K factor is on the K factor units, and then the material is steel. Table is divided by gauges. Gauge number 5 is for thickness 1, and the bend angles as we notice over there. And for the angle 75, the K factor is 0.6 for this type of steel. And for thickness 2, you have the bend radius over there already, and you have the bend angle. So this is what makes the gauge table popular, because here it will pick automatically depending on your bending radius and thickness and the type of material you are using. It will directly calculate the K factor for you. So let's go back to SolidWorks, to the part which we made, and now let's check use gauge table. Select based on the K factor, and then here is the steel air bending. We saw it on the table, and even you will see that the thickness is 1, then it should be the gauge number 5. So here is gauge number 5 is picked, and if you pick gauge number 4, you will see the thickness is 2 millimeter, but in our case it is 1 millimeter, and the bend radius it calculated to be 1 millimeter. We can change it or override the radius, for example, but I will keep it for 1 millimeter. For the gauge table here, the bend allowance is gauge table, and when you are done, click OK. So here is browsing our table, and you get, and if you edit the sheet metal feature, you will see all the values over there. So let's make another example. Start a new part. Okay, pick front plane, a sheet metal LB, and we already know that we are working with steel, and the thickness should be 2 millimeter, and the bend radius 2 millimeter. So you just go directly to the base flange, extrude to 100, and use gauge table. Select the type of gauge table. We said that the gauge 4 contain the thickness of 2 millimeter, and the bend allowance I let it to the gauge table to calculate it, and the bend radius here you just can make it 2, and you don't need to think about anything else because the table will do the work for you. We saw this is a small gauge table, and there is an example I want to show you. So this is an example for a gauge table for the CAD industry, and here is the reference link, and here you can see it's the units in inches, and it is for steel and aluminum. And here you can see the gauge number and the thickness and so on. Modify it to millimeter, and I'll show you how. Change it over there, click enter, and here for the thickness, to change it, you just simply type equal the value that you. So this is the original value. You just click equal and change this to millimeter, multiply by 25.4, and you'll get the thickness in millimeter. As well, the angle, the radius, you can change it in the same way, and so on with the rest of the values. Here, see the so let's see the nearest gauge to our previous example, this one here, with a thickness of 2 millimeter, and here is the thickness and the bending radius is almost 2 millimeter. So it is gauge 14. So let's save this and apply it to example. So edit the sheet metal feature. Here, browse for the key factor and select the table, which is click OK, and here is the copy of CAD's table. Click yes, and it will upload the values of your material. And as you remember, we said the nearest gauge is gauge 14. Find it over there. 14 gauge steel, and the values already uploaded. As you remember, we have only one bending radius, and click OK. And here the values are calculated. You can also make your own bend tables. We can go back to the SolidWorks samples, pick one, make a copy, and let's say that is stained steel, and the values we showed you that how you can calculate it in tutorial 160 is 0.38. Let's assume it is the same for the rest of the bending angles. You can fill your gauges by yourself. So for now, I'm just deleting these, and also these values, and the rest you can continue. So you can look at which material you are using and which are the angles you are using and the bending radiuses, and fill according to your requirements. the table. Make a new part here, the following dimensions: sheet metal 100, use gauge table, and this time browse for the new sample that we made. Select the gauge factor as a copy of our table that we edited, and there is gauge 5 and available thickness is only 1 millimeter because we deleted the rest over there. The bending radius is 1 millimeter, and we already calculated the K factor of this. Air gauge table or K factor, click OK. Welcome to tutorial number 163. This tutorial will be a simple short tutorial, but it will be important to continue the sheet metal feature menu and important for the next tutorial. If you remember, if you go to the sheet metal feature, edit feature, here at the end you will see the auto relief section. We already talked about the gauge table in the previous tutorial and the bend parameters and bend allowance. Now let's talk about the last section, auto relief. We will talk about the types of auto relief: rectangular, tear, up round, and understand the auto relief ratio down there. So start a new part and let's make a very simple box. Okay, go to the front plane and make a U shape. Okay, let's assume this is a steel sheet and go to the sheet metal and give it a length, base flange, give it a length 100. And for the bending method, I will use the gauge table, the topic of the previous tutorial. Also pick the same table shown in the previous tutorial charts, and the sheet metal parameters, I will pick the gauge number 20. So here we have gauge number 20, and the thickness, the bend radius, all, and the bend allowance are calculated according to the table. And here you will see auto relief. Just click OK for now, because auto relief in this case will not be shown because there is no tight corners or any need for them. For example, let's go to the sheet metal and expand the auto relief. You will see the three types we said: rectangular, tear, up round. If you pick tear, click OK. you'll not notice anything. So you will see what is the use and purpose for auto relief. So in order to show the auto relief, I will make an edge flange for this box and make it up to vertex. Up to vertex, and here is vertex. So now if you scroll down over there, you will see that the bending over there might looks not that perfect, and it can be even harder for the machining, and there is a risk for tearing, and it can be managed by the auto relief. So the auto relief is from its name to give a relief to the sheet metal while bending and processing. For example, let's decrease the offset of this edge flange, edit feature, and here make it with an offset. Make it offset of 3 mm and reverse it and click OK. So in case of steel, this type of bending might be difficult for such material. So the auto relief purpose is to relieve the corner. So let's now go to the, so to make it clear, I will edit the edge flange, edit feature and edit flange sketch, and make it a bit shorter over there, and on the other side give it some dimension, 5 and 5 here, click finish, and if you notice over there you will see this little cut near the bending. So this is the auto relief. So in this case it will be easier for bending. So the type chosen over there, go to the edit feature, and it is a round. So it is from its name, it will have a round edge over there. Make it normal too, and here you see the round. If you pick the other type, the rectangular, click OK, and here you will see the rectangular type on both edges. And the last one there, it is kind of tearing directly through the sheet. So I go back and pick the up round. And down there you will see 0.5. This is the ratio of the auto relief related to the thickness of the sheet metal. So 0.5 we will get exactly, if you remember the thickness is almost 1, is 0.91, so the distance over there will be almost half the thickness. If you measure, if you go to the measure tool, select this face and this face, you will see the normal distance is 0.49. That will be the same distance if you make it rectangular and pick that edge, and you will get the length 0.46. And for the tear, it is a tear and it will not have any gap. So I'll pick the up round, click OK, And let's try to make different shape. Let's make the offset. Click OK. You will see there is no any auto relief because there is already a gap over there, and it is easy process for bending. And let's now return it back to change the offset direction. Click OK. Now let's try to make a full edge flange. Pick that edge and click make an offset. Click OK. You'll notice that there is no any auto relief because the bending is directly near the edge. You can check over there that there is already the overrun is already checked. So in this case, there is another way to deal with the corners, which will be the topic of the next tutorial when we talk about the corners over there. For now, let's again repeat the process of the auto relief ratio. This time, let's make it. You notice the maximum is 1.9. Let's for now make it 1. Click OK. Here you will get the same. The gap will have the same distance as the thickness of this sheet. If you select the radius, and the radius is 0.49, that means the distance or diameter is equal to the thickness. Let's again change it to the maximum, 0.15. You'll see it will be almost the gap distance is almost twice the thickness of the material. Welcome to tutorial number 164. In this tutorial, we will talk about the next section over the corners and how we can deal with the sheet metal corners and add a corner relief, break corner and close the corners, and at the end we will see how we can weld the closing. Now I will make a very simple sheet metal box to show you briefly what is the corners. Start from the front plane and make a U shape and define it with dimensions. We will make a box similar to what we did in the previous tutorial. Sheet metal, base flange 100, and I will add another edge flange in the corner on the edge over here. Up to vertex. Okay, this is the edge flange, so we can treat this corner over there. Let's just check the what we choose here. We have material outside and 90 degrees, and the bending radius 0.9, and the thickness is, so let's make the thickness 1 millimeter, and the following option. So go to the corner and we will pick the corner relief over there. Click on the corner relief, collect the corners, and you will see how to, you'll notice that SolidWorks selected 2 corners on this edge and in that edge. We remember in the previous tutorial that we couldn't add a relief. For that we needed to edit the sketch, but with the corner relief we can add a relief in this way. Here you can see the 2 corners, selected corners, and you need to set a type of the relief. Here you have a rectangular, circular, and tear, up round, and constant width. So let's pick the up round and select the second one. It will be over there, and as well select up round, and you will notice over there is no error, and here is the slot length and slot width. So let's make it 0.25, and this one make it 2, and let's notice over there, or you can change the shape. For example, if we select it there, it will be just a small tear over there, and if you pick a circular, you will see a circle shape in there. And here are the circle widths or slot width. You can make it 2 millimeter, and you will see the shape over there. And even you can make it wish to the thickness, which we talked about previous tutorial, or tangent to there. Click OK, and here you'll notice that we could treated this corner, which we couldn't do it with the auto relief. So this is a corner, you can use the corner relief instead. So this is the corner relief is tear. Let's flatten and see. The differences. This is the tear type, and this is the circular, so it is up on the requirements, and which is easier to bend. You can pick the type. And we will talk about the next type of corners with this example box which we made in one of the previous tutorial. So let's try to finish this box with the corner tools. So we would like to close the gaps over there. So this is, let's say, a liquid container, and we would like to close the gaps over there and try to add a corner relief to make it a bit easier for bending, and see how we can weld the corner. So first of all, let's try to change the corner relief over there go to corner relief, and collect all corners. So, and we will see if SolidWorks could select them, and you will see he collected 4 corners over there. And I would like to change this type of to be there. And now you can see all the corners type are there. You can also select a corner individually. For example, corner 3. If you click on corner 3 and make it circular, so you will get a circular relief, as you notice over there. But let's make them all there, and you'll notice it is a bit easier for bending. Just I click X over there because I would like to show another way. For example, if you couldn't apply the corner relief for some reason, a complicated corner, for example, you can do it on the flatten mode. If you flatten this box, make it normal too, and then if you expand the corners menu over there, you will see corner trim. This is the only option can work on the trim. And then just make sure that you are not selecting any face, because it will break all the corners of the products. Just clear or delete this face and select that edge, and you will notice it is a fillet, but we would like, or you can make it a chamfer, but we would like to make it a circular relief. And here is the edge, and if you notice, you get circular cut. Make it 2 millimeter. You can pick the other edge, click OK, and here you make a manual corner trim. And if you exit, you will not see that trim because it will be just shown when on the flatten. So I'm going to delete this corner which we make and apply the corner relief. Collect all the corners and I will pick the tier for all of them. Here you notice, and as well over there, click OK. As you notice, we made kind of a small gap, and this will make it easier for bending and minimize the risk of tearing the sheet. And then we can deal with it at the end by welding this corner. So now the next step, we would like to close the edges over there. We can do that on the closed corner. And here are the faces to extend and faces to match. For example, let's extend this face, and you will see it select all the faces. Make sure that we can uncheck, delete the unnecessary faces. And faces to match, it automatically knows it is the face over there. And you can change the type of closing. In this case, it's not shown. We may minimize, decrease the, or reverse the bendings. So as you notice now, we closed that edge. So as you notice now, we have a better shape for this box, and we can repeat the same process on the next corners. And here for the closed corner, if you edit, you can control the gap between the edges. For example, the gap is 0.09. If we try to make it 0.01, it is a bit wider, and if you make it 0.01, and it is almost closed. So this is how it looks like when we change the gap distance. It closed more, and the first case it was like this. There is a small gap, so it depends how you would want it. So I will make the rest of the edges similar to this one, almost closed. And now let's see how to use the next type of corners, the welded corner. As we said, this box will be box for liquid. This edge is not convenience for a liquid box. And we used to close this edge partially, but is not closed completely because it is, in case of sheet metal, it is bended edges. Is the job of the next type of corner, welded corner. So now you can weld that edge, and then you will close the edge corner here completely, so it will be valid for liquid. So to weld that edge, first select the edge where you want to weld it, and you will notice very easily you created a weld over there from the bottom corner to the upper edge. And here you can, if you check this, you can add a fillet to make it looks a bit better. So you can add a fillet, and we can make it, for example, 1 millimeter. It didn't work, so you can make it. So here you will see this welded material over there. Start from here the whole way to the edge. Close this here, and here you can see the welding material, and this edge corner over there is completely closed, and it is valid for adding this side. You can see this is the welded material. You can try to make a cross section and see it from inside. So you can see there is no gap, and compared to the other side over there, you will see there is an opening. There is a gap, a small gap over there. So we can repeat the same process to the rest of the corners. And if you notice over there and expand, you will see only the welded corner option. And if you suppress the welded corner, then you will see that the rest of options are working. So the welded corner is one of the last steps in finishing your products beside the trimmed corners. So let's unsuppress this one and continue to weld the rest of the edges. So the remaining option now is the brick corner. So let's see how to use it. We flatten the sheet metal, which is going to go to industry. We can modify it further and try to modify these sharp edges. Go to the corner, you will see corner trim, and it will automatically trim or fillet the corners. So we can make it, you can select one by one. Because we selected the face, you will see that all the corner fillet, but you can delete and just select the edges where you want to add a trim or a fillet. So this is make it 2 millimeter. Even you have another way to do it with the brick corner option. Click the brick corner and select this edge. You'll notice that you broke that corner. You can make it fillet or a break is fillet. You can make it a break of 5. Here is the box which we started in this course, and we wanted to be for holding liquids. Is almost complete, welded from all edges and closed, and it can hold the liquid without any problem. And at the end of this tutorial, I would show you another example about using the corners. Here we have this product made in another channel, and if you remember this blade made with sheet metal, this is a sheet metal part and made simply by a base flange. And here, if we hide this, you will see this sheet metal part has a broken corners over there to make it easier to slide over the plastic barriers over there. So we can open this part, and here is the broken corner. Edit one edge, and we can even change it to fillet 1 milli. So it depends which one you need and which one can be easier. Welcome to tutorial number 165. In this tutorial, we will talk about the next section or the next approach in forming the sheet metals, the forming tool. As we remember, we have the first approach for making sheet metals, the direct, which create simple sheets, and then it might be not enough to create more complicated shapes. So there is the forming tool next. So it takes the benefits of other features for the sheet metal. So you can use, for example, the extrude, revolve, and to make usual shapes and then make them to sheet metal. In this tutorial, we will talk about some ready forming tools in SolidWorks, how to locate and use them, and then we'll show you how to make your custom forming tool and make an example, ventilation fan vent, and then we will look quickly to another real example where the forming tools were used. So first, let's start a new part on the top plane. Let's make a very simple plane. Go to define it with dimensions. Go to sheet metal, and we have the values over there. Click OK. So here is a very simple plane, and to find the forming tools, they are in the design library. If you go to the design library and expand it, notice there forming tools. So these are forming tools which are ready to be used. You can click on them and find the types over there. You have louvers, lenses, flange, and so on. For example, we can take the circular rib, and here you can just directly place it on that plate, and you will form your plate according to that forming tool. Or you can flip the tool, and here the configuration, we don't have any other choice than default. We will see how to make another configurations in the example next, and in the link you can link into the form tool and we will see how to use them. Then you are done, click OK. So here is the shape of that forming tool. So this shape is not easy to be done by the basic sheet metal commands over there. Try another case. Click on that face, make a sketch, normal to just make some random points. Let's make one point here, and so on. Exit. Go to again to the forming tool, and let's pick round flange in this case. Let's place it here. So the face is already picked directly, and you can place it where you want. But to be sure about the place you want to put it, you can add dimension, you can open the next menu, make it normal to smart dimensions, and you can easily add some dimensions to the place of that round. Okay, and you can make a dimension over there. Let's make this 70. Also, you can place directly on the point which we made. Click OK. Now let's see how to use the sketch which we made here with points to help positioning the forming tools. Go to the design library, run flange, pick and place it over there, position, and you can simply pick the point as you notice and place it directly, and here we can add relation to that point. So we have the round flange on the places where we want. Also, you can use the linear and circular pattern to pattern the forming tool. For example, for the feature 2, as you notice, you could also you can linear pattern direction, and for the feature, let's pick this single one, and you can change the number for 320. Okay. So now let's start making our example, the ventilation grill, and use some forming tools. Start a new part. Go to the top plane and make simple plane. Make the edges equal and the dimension 150. Go to the base flange with a thickness of 1 millimeter, 0.38 K factor. Click OK. Let's make the edges with the miter flange. Go to miter flange. As we learned how to use it, pick that edge normal to and draw edge 15, 10. Exit the sketch and select the rest of the edges. When you are done, click OK. So now let's see what we can find in the forming tool library to create the vents. Go to the forming tools and let's find louvers. Let's pick this type and flip the direction, and you can change the angle to 90 degrees. And click OK, and then we can linear pattern this louver. go to linear pattern, direction 1, features, reverse, this is the initial shape of the fan vent, but actually this is not how I would like to see it. This is just a quick example how to use the louvers. So this is a popular type of grills, and in the description below I have a link for animation to show you how this louver is made. This is first, and second, and I would like to change the style of this grill by using the forming tools. I would like to have the louvers longer and create just one press die to create the whole louvers at once. So make it longer. That will increase the passing air volume, and making all in one press will also save production time. So delete the louvers and let's see how to create a custom forming tool. Start a new part. Go to the top plane and make the press die. Give it a dimension. You can make it 150 or a bit smaller, so it is matching our grill. Extrude it. Okay. And let's make the louver manually. Click on this. Go to the right plane, normal 2, and draw a quarter of a circle. Give it radius of 10. Make this, and here make it horizontal, and dimension from here to here 20. Close. And extrude it mid-plane. One 100. Click OK, and here you will make a circular revolve. Sketch, convert entity, and feature revolve. And make it 90 degree. Mirror this, right plane, okay. Add a fillet of 2.5 millimeter to the edge over there. And now linear pattern this louver, direction is over there, reverse number is 7. Feature the fillet and revolve, and this one. Click OK. Can make it 19 instead. So this is the shape of the die, which is going to press the plate, the sheet plate, and produce all these at once. After making the die, you need to convert it into a forming tool. Go to the sheet metal, forming tool, and the stopping face. It is clear it will be this face, and faces to remove, we want these ventilations, vents. When you are done, click OK. So you'll notice the colors has changed. You need to save it in the forming tool folder. Pick a form tool and find a place to, you have forming tool, louvers, and you can call it custom louver. Save, and let's go back to the grill, the main grill, and press it all at once. Go to the forming tool, you will find the custom louver where we save. So it will be the face of pressing will be this face. Pick it and drop it on that face. Normal to adjust position the like this and this line coincident or midpoint, and here you have the louver center. When you are done, click OK, and here you have the grill ready, all done in just one press. So now let's talk about other options in the forming tool. If you edit the forming tool over there, you will see we said about the configuration. We don't have any configurations. Also, the link over there is not checked. So now let's see first how the link can be. So let's undo this process. Click delete. Show the main sketch. Click this face. Go to the forming tool and drop it over there. Normal to, and pick the good position. Normal to this point, this point, this point, this point. Make it coincident. OK, and on the type over there, click on link to form tool. Click OK. So that means these louvers are linked to the main die. So any change you make here, it will be changed as well on the grill. So let's edit the length of this grill, make it 75. Click OK. And here you don't see any changes. To see the changes, go to edit feature and return back. You will see the sketch is updated. So let's add a configuration. Go to configuration, add configuration, and call it second, for example, and return to the model, edit sketch, and here we can make it, for example, 75. Return to the part, edit feature. You will notice that you have second and first. So you can make many configurations depending on the size of the plate and simply change the length by configuration. And one last thing I would like to show you about using the forming tools, this kitchen sink example. It is a real example in industry. So this is how the kitchen sink is made, by pressing a piece of sheet metal with a die press. Here, for example, we have made 4 dies to create all these bendings. The first form to create the first bending over there in this face, and the second one to create another. So if we hover over, so this is a raw sheet of metal, then the first die is pressing to create this, and the second press will create this shape. The third form will make this shape, and the last one to make this louver, so it was applied on this face. Welcome to a new tutorial in the series of teaching SolidWorks from the beginning. This is tutorial number 166, and we will continue talking about the sheet metal tools. In this tutorial, we will talk about the gusset, the next option after the forming tools, and we will talk about the gusset options, how to use it, position it, and look at the shape, profile, dimensions, and at the end we will look at some examples. So start a new part over there, and let's make a simple L beam by sheet metal. Let's give it some dimensions. And go to sheet metal, this flange, extruded to 30. Let's make it a little bit wider, 50 millimeter. So on the bend radius 1 millimeter, the thickness 1 millimeter, and K factor 0.38. So these are the values we are using almost in all our tutorials. So now let's have a look at the gusset tool. If you look over there, you will see the gusset icon, and also you will notice that it is a part in the forming tool section. So actually the gusset is a forming tool, but it has the gusset shape. So because it is a standard, shape, and it used to make the sheet metal stronger and increase the stiffness of the sheet metals. And you can, for example, when you use it, you'll notice it is a forming tool which you can make by yourself. So start the gusset, click on it, and here you will see the options. You'll have the position and offset and profile. So let's talk about the position. From the icon over there, you need to select two faces. So let's select this face and this face. You will see the gusset. Just in 2 clicks, you get your gusset made. And if you notice over there, they are the reference edge point. And we will make another case where we can make our edge and point. But if you click on the edge, you will see the reference edge is over there and the point is on the other side with pink color. And the next option is the offset. If you look over there, you have distance of 20 millimeter. This is the distance from this point to the gusset. And if you uncheck the offset, you will have no offset and the distance over there, the offset distance grayed out. So here you have the gusset without any offset. If you click OK, so you see an error because the edges, they are not complete. So let's click on offset, and if you remember, the width of this is 50, so you can make it 25. You will get the gusset exactly in the middle. So click OK. Or before clicking OK, there's the profile. You can decide the shape of this gusset from the profile over there. Let's check the first option, the depth. So if you look on the picture over there, you will notice where is D, which is here. So it is the thickness is written. Let's make it 30. Click OK. As you notice, there is a draft. Let's make it without any draft because I used it before and without any option over there. So this is the shape of the gusset, which you will see without adding any fillet or any draft. So if you click on the gusset feature over there, you will notice the dimensions, which we added 25. It is from this edge to the middle of that gusset. The 30 is the depth, and 0.5 is the thickness, and we'll show you later. We'll talk about it as well later. You can make it smaller and can make it click OK, and if you change, so that is the thickness over there. So let's continue talking about the next options. The profile dimensions, you have D1, D2. You can imagine it like a chamfer. For example, you can decide by the length of edges over there, one here and one there, because you see D1 and D2 can be this 20 and the second 40, or make this one 30 and this one 10. And also you can control with the angle over there. You can make it 45 and the length 30, or you can make it 30, so you understand the logic, the meanings of this. And if you click over there, flat gusset, you will have just without any fillet. If you click OK, you will get this gusset. So let's back again and click in the filleted gusset. And now here are the other options. If you would like to make it wider, for example, you can make it 10, and the indent thickness should be less than the ended width. For example, we have 10, so here it should be 4, less than the half. Click OK, and the ended and the gusset work it. Let's edit again. If you make it 5, it will fail, so we make it 4.9, and you will get a very thick gusset. So let's make it again 1 millimeter, similar to the thickness, to the sheet metal thickness. So here you can add fillet from inside and outside. So if you make 1 millimeter, let's make it 2 millimeter. Click OK. You will get this inner fillet, and we can also add a fillet on the outside. Let's add a fillet here for 2 or 3 millimeter, and click OK, and you will get the fillet over there, inside and outside. So this is one case of using the gusset. So now this L-beam gets supported by this gusset. So let's suppress this gusset and show you how to use the line. Make a line on that edge. So if you would like to have a gusset with an angle, let's make a line, for example, and give it some dimension, 135, and make it for construction. At this point, can make it coincident. So we have a line over there, and let's make also a point somewhere over here. Let's make it an exit. So go to the gusset, select this face and this face. The edge, we will like to pick this line. You will notice the gusset is perpendicular to that line. You can edit the values. You can make it 45, and here you can make it 40. Now done, click OK, and you will get the fillet inside and outside from the previous gusset. So now let's again edit and pick the point. If we pick this point, it will be as well a reference to that point. So the distance will be 25 from this point to the middle of that. And when you are done, click OK. So this is another case for using the gusset. So now let's start using the gusset in our previous example, which we did in tutorial number 158. As you remember, we made this shelf holder and we added this tab to fix it on the wall. But you can notice as well that is not enough. Go to the main sketch, edit, normal to, select all these and delete. Rebuild and unsuppress the bending. So now let's add a gusset instead of that tab. Click on gusset, pick this face and this face, and let's now add a draft. And the thickness will be 1 millimeter, and we make it a bit. And here we can add a draft. And the depth of, make it 50. We can increase the thickness a little bit. So, and here for the distance, we know the distance is 38.38 divided by 2. So this will be the middle of this holder. And we have a fillet 2 millimeter and 2 millimeter over there, and click OK. You will get that gusset on this bending. And the shelf holder is stronger and can hold heavier loads. In the end of this tutorial, I would like to say, if you want to make you a custom gusset, for example, like this shelf holder gusset with a special shape, and it is, as we said in the beginning, the gusset is a forming tool, so you can form it. So here we have an example for that custom gusset, and it will be an example in another channel. And the link will be below. Welcome to tutorial number 167. In this tutorial, we are going to continue talking about the sheet metal features. And now we will talk about the next section after the gusset, the cuts section, which include extruded cut, simple hole, and vent. And we'll see the differences in the extruded cut for the sheet metal and the simple hole. And then we'll have a look at some design library vents, kind of ready cuts, and then the most important part in this tutorial, the vent options. We will have a look at the vent feature options, which include the geometry, properties, flow area, reps, spars, fill in boundary, and we will cover these options in one example. So start a new part and make a custom beam. Pick the front plane line, and we will make this shape. Let's define it with some dimensions. And here we will have an angle 120. Near midpoint. So we have this side perpendicular to the base edge, and here we have an angle extruded with a sheet metal base. Make a thickness of 1 milli. The bend radius key factor 0.38. Click OK. Let's make it a little bit wider. So now let's try to make a cut in that edge. So select this face, start a sketch, normal to, and let's make a rectangle over here. And define it. So we have a rectangle, and we are going to make an extrude cut through this sheet metal. Go to sheet metal, extrude cut, and for now nothing is new. We already know about the extrude cut, and you have the arrow over here, and you have a second direction, and so on. Click OK. Return back to the cut extrude, edit feature, and now we would like to see the difference between the normal extrude cut and see what is additional when we are cutting through a sheet metal. Here, if you notice, you will have length to thickness. So if you click on that, the cut will be only through that. So if we just uncheck direction 2, the depth of the cut will be the same as the thickness of the sheet metal. So this is one thing. And another option, let's now click through all and cut through the second side, and click through all, and normal cut is unchecked. Click OK. You will notice that the cut over here is not perpendicular to the surface over here, and it is not as the most of the cut, because if you flatten the part, you will see the cut here with an angle, and in reality mostly the punch gives you straight cut similar to the cut in the first edge. So we can fix this. If you edit here and check normal cut, so it will give you a straight cut through the edge or perpendicular to the sheet. If you flatten and look again, so this cut here is more logical. Unflatten, so we saw the two differences in the extrude cut. So now let's move to the next is simple hole. So simple hole, because as we know in the sheet metal you'll have only a hole, there will be no special holes for screws or so on. So you can create the simple hole directly on the sheet metal, and here you can make the diameter, change the diameter and the depth of the cut. And here you can check the face if you would like to have it perpendicular to that face. So just clear that selection, and you have the draft option as well. Now I will talk about the design library vents or cuts. So to locate them, go to the design library, features, and here you will see sheet metal. And over there you will see many cut shapes. For example, we can pick this one and drag it, drop it directly on the surface. And once you drop that on surface, you will get the cut directly. And to the left here, you have the ability to edit sketch. If you go to the sketch over there, let's make it normal too. So smart dimension, we can add dimension over there. We can make it 10, and from this side, 10. And also you can change on the dimensions of this shape. We can make it 1.5, and this will make it 4. When you are done, click finish, and you will get this shape. Again, let's pick another sheet metal feature. This time we can try this shape and place it over there. And if you want to change the size, override the main dimensions, make it normal too. And this one we can make it 2, and this one we can make it 1, and B can make it 10. So you have the chance to override the dimension values. And you can edit the sketch as well, add dimensions. Make it 40. When you are done, click finish. Now I will talk about the next feature and the most important feature in this tutorial, the vent feature over there. And it is an interesting feature, very nice to use and time saving. And I will show you how to use it with an example. We will make a ventilation grill. Start a new part. This time we will make a circular ventilation grill. Go to the top plane, draw a circle, and give it a dimension of 150 millimeter. Sheet metal. We have the values from the previous part. Click OK, and here you have this sheet metal disc. So we will draw a sketch. If you pick the vent feature, you read a message over there that you need a 2D sketch. So let's make 2D sketch. Select that face, start a sketch, normal 2. We will make the boundary circle of that grill, and let's give it 125, and we will make lines, the lines of the grills or the ribs. And this line you can linear pattern, select pattern it on direction. Here we have 6 pattern. Click OK, and repeat the same process on the other side. Click OK. And to support the ribs, we can make one rib in the center, or it's called spar. Let's make a line here and another line for testing over here. And we can add extra support the ribs in the center over there. We can make another inside circle and make a third. Sketch trim. Okay. And now go to sheet metal, vent, and you will see the vent will already select your sketch. So the boundary, as we said, the outside boundary of the grill is the circle, and the feature will directly create this hole. And the face is the tool face over there, and we will look later on the fillet and the draft. The area is cut at 100%, so the flow is 100%. Now we can decrease that when we are making, when we will make the ribs. The ribs, you can make them directly by selecting the line. So you'll notice how easy to work with the vent feature. And here you have only one option is activated, is the width of the rib. The reason on the sheet metal, because it is a plate of sheet metal and you don't have a solid feature. We will see later in another example how to use the rest of the option. But for now you have 5 millimeter, and you can change it to 3. And you'll notice now we have 71% floor area. And if you think the ribs need some support, you can add sparse the line in the middle. And as well we can increase the width 5 millimeter, 50 or 5, so I make it 10, and then we can the fill-in boundary, adding some extra support. Now this is select as far, delete and fill-in boundary be this circle. And for the spars, we added this line as it is. If you want to add more support to the ribs, you can select this line, but for now I will remove it. So here you have the basic shape of the grill, and now to make it looks better, we can add fillets to the edges. Go to the fillet and you can add 2mm fillet, and you notice the fillet is applied to the grill. Now it looks okay. When you are done, click OK. 2 more holes to fix this grill. Here is another grill made by the vent feature. So this is a plastic grill, and I will go over the steps how I made this. Since it is a plastic grill, it is outside the scope of this series, but if you would like to see how it's made in details, I will put the link in the description below. If you go again to the vent feature, here the vent can be used for sheet metal and for plastic ventilation units. So this one is made by plastic. We'll show you how it's made. First, we extruded this plastic plate, and here is the main sketch, and then we use the ventilation feature to make the grill. And here I wanted to show you what we said before. When we are working with plastic parts, the rest of the options will be activated. So we have the depth here is activated, and it was not the same in the sheet metal. We saw that the depth is grayed out. And here is the plastic part. We added as well a draft, so it would be easier for injection molding. We applied the draft with 1 degree angle and a fillet 0.5 millimeter. The advantage of this plastic that we have a high open area, because we made the ribs stronger by increasing the depth of the rib, and which we can see over there. We have 20, and if you click 10, you can notice. You can change the way you would like, and let's make it back again 20. And instead of making the rib wider and decrease the flow area, we can increase the depth, and that will increase the strength the grill. So we have almost 77% open area. And the same thing with sparse. You have the depth value is activated, which you can increase it or decrease it. So this is the main point of this grill, and then we made a cut to remove the extra materials. So here is the grill. It looks nice, and all is done in just few steps with the vent feature. Welcome to tutorial number 108. In this tutorial, we will talk about the next section in the sheet metal commands, the unfold, fold, flatten commands. We will see how to use the unfold commands and compare them with the flatten, and how to link these two options with the flatten. Also, we'll see differences between the unfold and flatten commands. I have this box from one of the previous tutorials. It already has all the bins. Let's see how to first use the unfold command. Click on unfold. Here you will get a fixed face and bins to unfolds. Let's first select the base face, and then here you have collect all bins. Let's click on that. It will collect all the bins. If you hover over each one, you'll see which bin is selected, and here is selected all the bins. And when you are done, click OK. Then you will get all the bins flatten or unfold. Now it looks like similar to flatten, and if you just make it normal too, you'll see the unfold mode. Let's undo this and click flatten instead. Click on flatten, make it normal too. On the flatten mode, you will get the bendings line, which are not shown in the unfold mode. This is one difference. Let's unflatten this. And now let's unfold by selecting the bins. Click unfold. Let's select this face. So let's see that we don't want to unfold all the box. We just need to check one edge. So I selected this fixed face, and the bins to unfold, I will select this bin. Click OK. Now you will get that bin unfold. So you can check if you have any cuts or any things, then you can check it by the unfold. Let's undo this. And see how to use the fold command. Let's first unfold the whole box. Unfold, let's select this fixed face and select all the bins and click OK.
So you'll get the box flattened. So we can try now to unfold edges. So click fold. For example, we can select this face, and for the bend we can select this bend. So and check if it will work. Click OK. Now you got this side fold. Also you have the option, let's undo this. Also you have the option to select all the bends. So let's select this face and select all the bends. Click OK. And you will fold all the bends. So now you may ask yourself that you can use the flatten instead of unfold. So let's now talk about the main advantage of the unfold, because if we work on the flatten mode and make cuts, it will not appear when we unflatten the box. For example, let's make a cut over there, select a slot and let's define it. Okay, now when we unflatten, you will not see the cut we made, and you will see that the cut is after the flatten mode. So let's instead try to do it with the unfold. Select this fixed face and let's just bend this side. Click OK. Now let's make a cut over there. Make a sketch, normal tool, select a slot and let's make it beside. And when you are done, you can fold the box. Click OK. As you notice, the cut appeared on the box. Also, you can try to treat the corners as well. Also, we can use the unfold command for unfolding other shapes, not only boxes. Let's start a new part and we will make a pipe. Pick the top plane, make a circle. So let's define it 100 millimeter and let's make a welding gap. Pick center line,
make this construction. Go to sheet metal and extrude the pipe, let's say 300. The sheet metal thickness is 0.15. Click OK. So now we have this pipe, and let's see how we can unfold this pipe. Go to unfold, fixed face. If you try to select this face, it will not allow you, but if you pick that edge, you are able to pick that edge. The bends to unfold, so the whole pipe is a bend. Just click on it and click OK. You will get the pipe flattened. And you can undo, or you can make modification to that pipe and then fold it again. But let's try to fold it on the other side. Go to fold, select this edge listed, and bends to fold the pipe. Click OK, and you'll notice that we fold it on the opposite side. Also, there are other ways to fold, unfold. We will talk about them in the next tutorials when we talk about the insert bends. Welcome to tutorial number 169. In this tutorial, we will talk about another approach in creating sheet metal parts. At this moment, we are familiar with most of the sheet metal commands, and now we will talk about the convert to sheet metal. That will make it clear which way will be, for example, easier. For example, if we would like to make such shape, so we can do it with the base flange approach and the rest of the commands, or there is another way, shorter way, convert to sheet metal. So one of the advantages of the convert to sheet metal that you can implement the solid features for creating sheet metal parts. So we will make this shape and see how we will do it, and then have a look at the convert to sheet metal options, fixed face, bend and rib edges, and we will see another example how to use the rib sketches. Also, one another advantage of using the convert to sheet metal feature that you can convert more complicated shapes to sheet metal, which can be easier to be done by the solid feature. So let's start a new part and pick top plane, select hexagonal and define it. .65 and extrude it to 50 with 25 draft angle. click OK. Now mirror this part, mirror, select this face, bodies, click OK. So we made this shape in 2 steps, and let's see how to convert it into a sheet metal part. So go to the convert to sheet metal, and here you will get the convert to sheet metal option. Use gauge table, we already talked about it. We'll keep it to the default, and let's assume that we will have a base flange. We will pick the base face over there. The thickness of the sheet metal, we will keep it 0.5 millimeter, and reverse the thickness. We will see now when we will start selecting the bent edges. So let's assume that is the base flange over there, and the edges around are the bent edges. So you can select the bent edges directly over there, and you will notice the color is the pink color, and the purple color represent the rib edges. There are other options. Let's just click OK for now. Because we selected only these edges, SolidWorks converted only the down part into a sheet metal part, and you can flatten this part. So if you would like to do the same process in direct approach, the base flange, you will need to create hexa diagonal, and then you will make an edge flange, then edit the sketch, and it will be like more steps to do this. And if you would like to make the whole body, it will take longer time. So let's go back to convert to sheet metal option, and here we have the rib sketches. We will talk about it in the second example, and here are the corner defaults. If you can look over there, so depending on the requirements, you can decide. I will keep it open, and the gap, you can make it 1 millimeter, and also the overlapping gap, and auto relief, we can make it rectangular. We talked about it before. And here, if you click reverse thickness, you will get the thickness inside. So I will check the reverse thickness, and if you look over there, you have the default bend radius 1 millimeter. You can override the value. For example, you can make it 3, 5. So I will keep it 0.5. So we talked about the bending radius before. So when you are done, or before that, you are able also to change the radius directly on the shape. If you notice over there, you have the radius. For example, we can make this radius to be 3 millimeter, or 0.5 millimeter, and the gap as well. You can change it, change the type of the gap, and the gap width. You can make it 2 millimeter. I will keep it to the default. Now let's continue selecting the rest of the bendings. If you go to the bend edges and select the bend over there and this edge. And let's close upper edge. So now when you are done, click OK. So you notice that SolidWorks converted this shape directly into a sheet metal in few clicks. Now let's see how to use the rib sketches. For that, we'll make first a simple part. Start a new part and pick the plane. We'll make a simple cube. And extrude it 100 millimeter. This time I will add a shell. This add shell of 1 millimeter. Okay. Go to sheet metal. And let's first make a sketch for the rib. Select this face and make a center line over there. So this sketch will be used for the rib. Now go to sheet metal, convert to sheet metal, and as you notice we don't have the base. Select, let's select this face and the thickness 0.5 and the radius, bend radius is 0.5, and let's pick the bend edges. You can see in the preview the shape of the sheet metal part. Select this edge and also select this edge. So you'll see that we have the opening, the rib edges over there, but we would like to modify it to have the rib in the middle. So go to rib sketches and pick this sketch. You will notice that we got the rib on that side. So let's also add another bend edge over there. So we'll have the whole face closed. And when you are done, click OK. So you'll notice that we got the rib in the middle of that face. So you can flatten and have a look at the part. So let's back to the main example and try to make a rib over there. So let's roll back and start a sketch over here. Normal, and make a line in the center. Exit and do forward and edit the convert. Sheet metal here, the rib sketches, add this sketch. you see the opening drip there. This is just your selection, and to make it easier, let's uncheck this part. So we have now the top face is open. Select drip sketch, and now in the bending edges, select this bend and this bend edge. So this is how I would like to see this box. So when you are done, click OK. So, and here you have the ribbed sketch to make the opening in the middle of the top face. Let's flatten. And here is the flattened part. And if you would like to make this sheet metal part with the base flange and basic commands, you can imagine how longer time it will take. Welcome to tutorial number 170. In this tutorial, we will talk about the next sheet metal feature, rib. You can find the rib here before the last feature, insert bends. So in this tutorial, we will see how to use the rib feature and have a look at the rib parameters and see how the rib works and the cases you need to have in order for the rib to work. And then we'll have a look at the rib options, rib directions, gap distance, and then we'll see how to make a sketched rib. So first, let's start making a new part, almost similar to the one we made in the previous tutorial, and see how we can rib the edges by the rib feature instead of converting to sheet metal. So let's define it and give it a distance 65. Extruded 50 with 25 outward draft angle. Click OK. So now let's try to rib the edges in order to produce a similar shape by sheet metals. So let's go to sheet metal, rib, and here it will ask you to select the edges. Simply you can pick the edges and you will see the arrows in two directions. Now we selected the edges to be ripped, but in this case it will not work because you need to have a clear shape. You should imagine the solid feature as a box or a sheet metal part before ripping it. So let's now click OK. You'll see the rib error. So close this and let's shell the shape. Go to feature, go to shell, and let's say that you want to make this shape by sheet metal plates of thickness 1 millimeter. So let's make it 1 millimeter shell. Click OK, and this is the initial shape of the solid feature. Now let's go to sheet metal rib. There will be also another case that it may not work to select all the edges at once, so you need to select one by one. Let's just first try to select all the edges. Click OK. You will get again a geometry error. So clear section. And now let's just apply to only two edges to see the shape of the rib. Now we will get two errors, so the rib will be equal in both sides. And the gap distance 0.1. Click OK, and here you get the rib over there. So this solid feature, how it would looks like if you would like to produce it by a sheet metal part. So let's compare it with the previous tutorial shape. Here is the sheet metal part from the previous tutorial, and it's made by the convert to sheet metal feature. And here we have ribs, as you notice on that side, and in this case, or by the rib method, you have the ribs in that shape. Let's continue adding more ribs. Let's this time add to this edge, and let's make it just in one direction. Click on the arrow, or you can change the direction here. So you will have a rib in that direction and in that direction. Click OK. So you'll notice how the rib looks like. So you can now continue the rest of the edges, or let's suppress these two edges and add the rib to the edges. And the gap distance, let's make it 0.1. Click OK. So this is the solid part. If we would like to make it by sheet metal plates, let's now try to make a similar ribs to this one. Here you have ribs on all the edges, and you have one rib over there. So let's try to make it. Go to rib and select this edge. Click OK. Now it looks almost similar to the ribs made by the to convert to sheet metal. So let's go back to the previous example. If you go down there, you have sketch rib over there. So let's see how we can do it by the rib feature. Go to the part, start a sketch over there. Let's roll back, make a sketch over there, and let's draw a line over there. Exit the sketch, roll forward. You can edit the sketch over there to add another edge, this one. Click OK. You will also get that rib over there. So let's edit and delete that edge, make it in a new rib. Select that line and make the gap 0.25. Click OK. So this is also one way to manipulate with solid parts in order to get to exact shape. As you know, there can be a lot of shapes, tricky shapes, and for now we saw many approaches how to work with them. We, from the beginning of this course, we had a look at the base flange feature, and then we looked at the forming tools. Then we looked at the convert to sheet metal. Now we see the wrap. And in the next tutorials, we will see also another approaches, how to sweep sheet metal part. Also, there is another way to make more complicated shapes with sheet metals by lofted bends. So at the end of this course, you will have an idea about these options. You will be able to decide which approach is easier and better to reach to the requirements. And also, this course will be a good reference to repeat it again and again to have a look to the features. Welcome to tutorial number 171. In this tutorial, we will talk about the next command in the sheet metal menu, insert bends, and opposite to this command, the no bends, and see how to use them. Also, we will compare it to the rep in the previous example. Then we'll go and have a look at the insert bends parameters, use the no bends after that, and see one of the advantages of using insert bends by making an example and unfolding it and compare it to the unfold command. First, let's talk about the example from the previous tutorial 170, where we used the rep command. So as you notice, we made the reps over there. Maybe that is not the most perfect shape, then that will be the work of the next command, insert bends, because the insert bends will take the reps one step forward. So let's start a new part and make a similar example so it will be easier to compare. Pick top plane, select hexagonal and give it a dimension. Extruded 50 with 25 draft outward angle. Click OK. And chill it with a thickness of 1 millimeter. Click OK. So now we have a similar shape. Go to sheet metal, insert bends, and here we will ask you about a base face. So you can imagine this is a base flange or base face. Select it and you will get similar options to the base flange options. You will get a bend parameter. Let's make it 2 millimeter. And here you have a thickness. We already made a thickness. And bend allowance, we already talked about them. Auto relief we can make it rectangular. We also talked about it. And here is the rib parameters. So here you will make again ribs similar to what we did in the previous tutorial, and we will see the difference between the rib and insert bends. Select the edges. Here you can change the direction, make it 2 directions instead of 1. Here we selected the edges to be ribbed, and the gap distance, let's make it this time 0.5. Click OK. Click OK again, and here you will notice you made a modified rib than in the previous tutorial. So we get the auto relief, we have the bend radius, also we have the gap. So actually the insert bends in the beginning is a rib feature. If you look at the tree over there, we have a rib, and there are 2 more steps after the rib: flatten bends and process bends. So these processes made it the part to be a sheet metal part. Here you can also change the relief type. You can find it in the sheet metal properties. You can change it to a round, or we can make it tear. So it depends on which type you need. And if you notice on the sheet metal menu, you have the no bend commands is activated, and the insert bends is not activated for now because we already have bends. So before using the no bends, I would like to talk more about the 2 options over there on the insert bends tree. First we have the rib. If you edit the rib, we already talked about this feature in the previous tutorial. It is already included in the insert bends. You have the edges, and you have the gap distance and the directions, and also you can add a sketch, more sketch to that. And now let's roll forward to the next option. This option will flatten the part, then process bend, it will bend it again. So as you saw that we have the flatten and bend again on the tree, but you can do the same process by clicking on no bends. If you click on no bends, it will show you the part without any bends or any bend allowance. It will be just similar to the rib, the previous rib. And if you uncheck the no bends, you have the bends again over there. And when you check the no bends, you will see the insert bends is activated again. It will allow you to insert more bends if needed. And also you can use the flatten option for that part, and you will get the part flattened as you see. So this part maybe is not that complicated geometry, but the rib and insert bends can come handy for more complicated shapes, which can be difficult to be done by the base flange and tab. We will make an example to see how we can use the insert bends and see one advantage of using the insert bends. Start a new part and let's make a pipe. Pick the front plane, draw a center line and draw another line over there. Let's define it 250. Go to feature, revolve, click yes. Okay, so use the thin feature, make a thickness of 1 and revolve it 1 degree less to make a welding gap. Click OK. So we have this simple pipe. Now we can flatten this pipe with the insert bend. Go to sheet metal, insert bend, just select that edge, click OK, flatten. You'll see you are now flatten this pipe. So the point here, the part which we made is made by a solid feature by the revolve boss, and we could use this solid feature to convert it into a sheet metal with the insert bend. If we roll over there, you will see the unfold command is not activated. We used the unfold feature in one of the previous tutorial. You can go back to that tutorial and try to compare it to the insert bend. So you will notice here that the unfold is not activated. Start a new part on the top plane. Normal tool. Let's make another pipe. Quickly, we have a circle with an opening. Exit. Go to sheet metal. And here you have the base flange and the sheet metal is not activated. Roll forward the cursor, pick the base flange and select that edge. Click OK. So here we have a pipe made by the base flange, sheet metal. If you go to the unfold and pick that edge and select the body, OK. Now you have the pipe flattened. To unflatten or to fold the pipe, you can suppress the fold or the unfold command, or you can add another fold to it. Let's just unsuppress, add a fold. The edge is selected already over there, and bends to fold, select this part, click OK. So this is the fold unfold method, and the first pipe is made by the insert bends. If you would like to flatten the first pipe, you can, as we said there, you can, as we said, suppress over there, and you will get the first pipe flattened. Click unsuppress. So there are two approaches, but we said the insert bend took the advantage of using solid feature. So, for example, the first type can be a more complicated shape that is not easy to make it by a base flange command, and then you can add the insert bend to it and bend it. Welcome to tutorial number 172. In this tutorial we will talk about another command for creating sheet metal parts. In this tutorial we will talk about the lofted bend command, which we see over there. We will have a look at the cases where the lofted bend can work and when it can't work, and then we'll have a look at the main two types of the lofted bend: bent lofted bend and formed lofted bend, and see the types under the bent lofted bend, which are chord, tolerance, number of bends, segment length, segment angle, and see the difference between them and see which type will fit your requirement. The sheet metal lofted bend is almost similar to the solid features lofted, boss, and lofted cut, with some major differences. And if you hover over the lofted bend, you will see that the lofted bend in sheet metal works between only two sketches. So let's start making two sketches. Let's make on the top plane a circle and give it a dimension of 100, and make another sketch on another plane. Let's make a plane parallel to top plane with a distance of 200. Click OK and draw a center rectangle. Give it dimension of 175. Make this tangent to the circle. So here we have two profiles or two sketches. Let's hide this plane. So in the original lofted bend or lofted boss, these two profiles will work. Also in the surfaces loft as well, the loft between two sketches will work. But in the sheet metal, as we knew before, that we should have a gap, mostly for bending gap or welding gap. So let's first try to see. We have click on the lofted bend, you have bent and formed. But first let's try to select this sketch. You will notice that you are not able to select any of these sketches. So exit from the lofted bend and let's make opening gaps in both sketches. Edit that sketch, normal to, and let's make center line and opening gap. Make this rectangle for construction and give it 2.5 and then trim the circle over there. fix the point over there. Now it's fully defined, exit, and the same thing on the second sketch. You can convert entity or again create a similar rectangle and trim the entity. Click OK. So now the sheet metal lofted bin is supposed to work, but you will notice later that it will not work, probably for one reason. We will talk about it. Select lofted bin. Now select that sketch. You notice that you are able to select that sketch and select the second sketch. You see it worked, but if you hover or zoom in, you'll see there's a gap over there and the bin is not fully covering that gap. If you click OK to see it clearly, you'll see there's a gap over there. So the reason for that you need to have bending radius instead of a sharp angle, 90-degree angle. So delete that lofted bin. Go to Sketch 2, Edit, Normal 2, and add bending radius in the form of fillets. So let's make it 10 millimeter. Click OK and exit from the sketch. And let's try now to use the lofted bin. Select first sketch and the second sketch, and you notice there that you got the lofted bin fully working. Here in the first options you have bin and form. Let's first click on the form. You will get just a very simple loft without any chord lines or angles, and we will have another example about it later in this tutorial. And let's discuss the first option, bend. And if you roll down the profiles which we already selected, sketch 1 and sketch 2, and here are the facing options. So depending on the manufacturing method which is going to be used to produce this cone or duct, here are the options, or depending on the shape wanted. So the easiest way to know the difference between these four types is at looking at the figure of it over there. So the chord tolerance is the distance between the max distance between the linear segment and the arc. To show this segment and the arc, let's exit from this command and flatten. And if you notice over there, there is straight lines or segments instead of arcs. It is clear over there, and let's unflatten and go back to lofted bin, edit, go to the chord tolerance, and we can decrease or increase the value to 5, so it will be clear to see the segment and the chord arc over there. So the maximum distance, it is 5 millimeter between the arc over there and the segment. And the second one is according to the number of bends. So it is almost clear. So depending on the number of bends, you have here 4 corners, and you can decide the number of bends in each corner. For example, now we have 2 bends, which represent this one over there and one over there. If you increase, you can notice that increase. Also, you can change the type of bends in each corner by selecting the dot over there. So if you click on the dot and let's select number of bends and let's type 8, you will see that the number of bends are 8 over there, and it's applied on that corner. And let's go to the next corner and try to apply a different type. And this time let's select the segment length, which we showed you before. Click on segment length, and it is here 5 millimeter. Let's click OK, and the segment, you can see it if we flatten the part. Let's click OK and flatten. And here you'll notice the maximum distance is 5, and here it's shown 4.7, and adding the bendings radiuses, so it will be almost 5. So the 5 representing the maximum value. Exit, and let's go to the angle between the bending lines. Edit the lofted bend again and move to the next corner, and let's this time select the segment angle. So this is the angle between the segments. Here it is 30, then let's make it 40, and you see the angle is 40, and let's make it less 10, and this is clear the angle between the bending lines increasing and decreasing by changing the angle value. So now this is brief look at the types, and with practice it will be easy to differentiate between them. And the rest of the options, we already talked about the thickness of the sheet metal and the bend radius. When you are done, click OK. Now we will have another example where we can use the lofted bend with the form type. We have the famous example by Alex, and it is found on the internet, and here he has the instructions how to form this part. And as you notice on the second part, use the lofted bend. And if you notice this shape, there is no angle or bending segments, so the type used to create this shape is deformed lofted bend. And also it will be a repetition for the unfold, the cut, unfold back. Here the dimensions are in inches, So we will assume that they are in millimeters multiplying by 10. So 4 inches over there, we will assume it 40 millimeter, and 0.1 inch, we'll assume it to be 1 millimeter, and so on for the rest of the dimensions. Here the circle is 20 millimeter, let's say, and 30 by 15 ellipse. So start a new part and make a second reference plane 40 millimeter far from the front plane, as you see over there. So features, reference plane, and reverse offset and make it 40 millimeter. Click OK. On the front plane, we'll have a circle with a gap Let's make a center line to make it easier to deal with it. So let's check the dimension of first sketch. You will have 20 millimeter diameter and the gap is 1 millimeter. So the radius should be 10 millimeter and the overall diameter is 20 millimeter, and the gap over there 1 millimeter, and let's make them symmetric about the center line. So here we have the first sketch is fully defined. Exit and go to the second plane and insert sketch normal 2, and here we will need an ellipse 30 millimeter by 15 millimeter. Here you can see partial ellipse with the gap. So the distance from this point to this point is 30, and from this point to this point is 15. Let's make this horizontal and the gap one millimeter, and let's make them symmetric around center line. Convert entity and for construction symmetry. So now we have the ellipse fully defined. And the second option or instruction is to use the lofted bend. Go to lofted bend, sheet metal, lofted bend, and this time we will pick the format type. This sketch and this sketch, and the thickness, let's make it 125. And as you notice, it is similar to the shape we saw. If you convert it into pen, for this shape, you'll see it didn't work. So let's make it form and the number of bent line. So we keep it to the minimum 1. So make it smooth and click Okay. So here we have the initial shape of the exercise inside that plane, as we can see it here in the picture. So here we have a similar shape. So, and it said that use the unfold. So as we learned before, so you said unfold. Let's go to the unfold, pick that edge, and the bodies or bent to unfold is that body. Click OK. So now here is the unfold shape of that part. So now let's create the holes. We have almost 3 mm hole, 80 holes. So pick that face, start a sketch, normal to, and let's draw a circle. .12. Let's make a dimension of 2.5, or better make it 5, and 5 over there, and go to feature, extrude cut, click OK. So now we have the hole. You can make the holes all at once, but I would like to make the holes tangent to the curve. Go to feature, curve driven, and select the curve and features is this hole, and we need 10 holes, and let's make the distance 7.5, and that will be okay. Click OK, and now we need and as you notice from the shape, we need 8 on the other side. Now we will make a line, a direction line for the second pattern. So we have the face with an angle. We can make a center line between this angle. Make a sketch on that face, normal to, select center line, and make it an angle of 7 degrees. Exit from the sketch, linear pattern, the direction. We'll pick this 7.5, 8 pattern, the features, let's make the distance, make it 4, 5, click OK, and now let's unfold or fold back the part. Go to Sheet Metal, fold, select the edge is selected, the body, and here we have the required shape. And let's hide that sketch. So if you compare it with the part over there, you'll notice that we got a similar shape. Welcome to tutorial number 173. In this tutorial, we will talk about the last command in the sheet metal menu, sweep flange. And we will see how to locate the sweep flange command and show it in the menu. And we'll have a look at some cases where the sweep flange will work compared to the previous types of sweep in the solid feature and surfaces. Also, we will have a look at the type of path and profile to use to create the swept flange, and then we will have two examples using swept flange and then compare it with the miter flange. So first of all, if you go to the sheet metal menu, you will not see the swept flange. To locate the swept flange command, go to Customize, right click on the menu, Customize, and then go to Commands, Sheet Metal, and here you will see the sweep flange command. So you can drag it and put it on the menu. So we have the last command over there. If you hover over the swept flange, you will see the profiles or the path. They can be closed path or an open path, and we will make an example for each case. But the main difference with the sheet metal swept flange that it requires some certain type of path and profiles in order for the swept flange to work. To make it clear, let's start to make the first swept flange. Let's make a path, go to the top plane, and let's make just a very simple path, straight line, exit, and go to the front plane to create a profile. If you go to, let's make an ellipse, partial ellipse, and let's make this point coincident, and go to sheet metal swept flange. You see the profile is selected, the partial ellipse and the path, let's say this line. Click OK. You'll notice an error that only arcs and lines are allowed to create sheet metal swept flange. Exit the command, and if you go, for example, to the swept surface, the profile and the path, you'll notice it will work in the surfaces. So it is a special case in the sheet metal swept flange. You need to follow some certain type of profiles. So let's edit the profile, the ellipse, and delete that ellipse, and make instead just one line. Exit, go to sheet metal swept flange. The profile is this line, and the path is this sketch. And here you'll notice you'll get a similar options which we talked about before, and then click OK. This is a very simple, nothing special in this example. So let's start a new part and make a base flange. Select top plane, center point rectangle, sheet metal, base flange, and the thickness, let's make it 1 millimeter. Click OK. Now let's pick the right plane, make a sketch for the profile. In this case, we will show you that second case when the sweep flange won't work. So let's just make a simple profile on the right plane, and let's define it with a dimension of 135, and here 15, and here 35, and exit, or we can directly go to the sweep flange. The profile is selected, and here we can select the edges. As you notice, we can select the edges, but this case will not work because the sketch or the profile should be perpendicular to the beginning of the path. So let's click OK, and you will get another error that the plane should be normal to the edge. So let's exit that sketch and instead make the sketch in that plane. Click Sketch, Normal to, and select this line, and convert entities. Now go to the sheet metal, sweep flange, select this edge, that edge, and you will notice that you are able to sweep around that edge. And you may ask yourself that it might be similar to the mitre flange. It is not. There are some differences, so that depends on which type of shape you need. And here the bending radius is 2 millimeter. You can change it, for example, to 5. It will change over there in the angles. And as well, you can select the type, the flange parameters, inside or outside, and so on. Let's make it outside and click OK. So here notice you made the sweep flange around that plate, and you create a continuous box, and this also able to be flattened, as you notice over there. And here you see the bending lines around. Let's exit. Now we will start another part to create a sweep flange where the mitre flange is not able to make it. So start a new part, click OK, and select the top plane and select line. Let's make a path. For example, let's make a fridge base. Let's make this horizontal and define it with some dimensions. Let's make this 500 and this 350. This is the path which we need, except select the front plane. If you make a sketch on the right plane, it might not work because the plane is not perpendicular to the edge. So select the front plane, normal to, and let's make this shape or this profile, and let's define it 50, and let's add some relation. These are already perpendicular, and here as well make this equal and those lines equal as well and make 25. So we made this special profile without adding any radiuses. It will be automatically added when we use the swept flange. So now the profile is ready. Go to Sheet Metal, Swept Flange. As you notice, only the Swept Flange command is available for this profile and the base flange. If you click on the base flange, you will create only a straight profile. Let's just click on Swept Flange. The profile is selected and select the path. And let's make the bending radius 5 and click OK. So we have this, the fridge base, for example, and it is able to be flattened, as you notice over there. And here are the bending lines. Now let's see the difference between the swept flange and the miter flange. We made this part in one of the previous tutorials, the tutorial about the miter flange, and later on we welded the edges. So we could do also the same type of box if it is possible to be manufactured by a swept flange and make it suitable for holding liquids instead of making it by miter flange and then welded. So that depends actually in the type of material and manufacturing process. So if it is not possible to be made by swept flange, then it can be done by the miter flange. Let's have a look at the cross section of this profile. So we have a profile looks like this. So let's start a new part and make a similar profile. Select the top plane and make a base plate, make it equal and define it dimension of 150 and go to base flange and have it with 1 millimeter thickness. Click OK. Now go to that face over there, start a sketch normal 2 and let's make our profile. Can be something like this. Let's define it. 45, 125, 15, 'Let's make this tangent with this and Let's make this 15. So here we have the profile fully defined. Go to sweep flange and select the edges. And let's make the bending radius to be 1 millimeter, and the flange position outside. Click OK. So we have now a continuous edges without any gaps, as seen in the miter flange case over there. So we have a continuous wall, and it is suitable for holding liquids. This kind of profile may be a little bit detailed and can be difficult to be flattened. As you notice over there, we can go and edit the sketch. We can move this part, exit, and let's try to flatten. And here you get your metal tank. Exit, and we can try add a hem manually instead. Welcome to tutorial number 174. This tutorial will be a real example for using the sheet metal commands, the commands which we learned in the previous tutorial in this series. We will make this real power supply which can be ready for manufacturing. And also this tutorial will be a good review for the previous commands. We'll make this power supply which consists of two parts, top part and the bottom part, and both of them can be flattened. Start a new part for the first chassis. Go to the front plane and let's make the base for the bottom part. Make midpoint and dimensions 80 9.25. This side is equal to this side. Now go to sheet metal, paste flange and Extruded for 150 and thickness 0.75, bending radius 0.25, K factor 0.38, and the relief rectangle. So these are the basic information and it will be used automatically for the next features. When we are done, click OK. So this is a steel, and here in the appearance we can make it brushed steel. On the base flange, let's just make sure that the base flange is outside, as you see over there. Now we need an edge flange on this side. Go to edge flange, select this edge and make it a length 38.75 and make sure the flange position is inside, as you see over there. And here the relief is rectangular. And here over there, edit the flange profile and give it a distance in this line to this line, 0.8. The same over here. And this side is 38.8. And before finishing the sketch, we can do one more thing. Instead of making it in a separated command, we would like make a cut over there for another edge flange. So click on that line, make it for construction, and this line make it for construction, normal to, and draw these two lines and give it a dimension of 11.75 and here 0.8 and connect the rest of the lines. So you notice there the sketch is valid. Click finish. So now we have the edge flange with a relief over there and the cut here. And here we would like to make another edge flange. Pick edge flange and select this edge. Edit flange profile, normal to. Here the dimension is 8 millimeter. And here make a gap of 2 millimeter and we would like make a cut over there. .75, and this distance is 9, and trim the rest. And when you are done, click finish. Just make sure that the edge is material outside. Click OK. And here we need another edge flange. Select edge flange, select this edge, and edit flange sketch normal to. The place of this line is correct, and let's make this for construction, and draw another rectangle over there. Make a gap of 0.8, and this line 1.25, and this distance 15.5, and this make 10, and when you're done, click finish and make the sure the edge is material outside. Click OK. Need a miter flange on this side. Click sketch normal to, pick a line, and draw this shape and give it a dimension of 45, 4, and here 10. Go to sheet metal, miter flange, and you will notice it is extruded automatically to the edge. Click OK. And here on the main edge flange we need more cuts. We can make them on the face, or we can edit the main sketch over there. So depending which one is easier, you can choose. I can again pick the main edge flange, edit normal to, add some cuts, and here construction, and add another cut over there. Now the sketch is valid. Here make 1 millimeter, here 3. This one make it 2.5 and this 3.5. Distance from here, this one 35, and from this distance to here 4, and here 4 as well, and then you can add relation to define the sketch. So now the sketch is fully defined and we have the cuts. Click finish. You could also do the same by adding simple hole, but it might be easier to make it on the same sketch. And here add another edge flange. Edit the sketch normal 2, and then make a gap, define it with 2 millimeter and the length 30 millimeter. Click finish. Let's make sure that is outside. Again, edit and make it material outside. And here we'll add a fillet for this sharp edge. Go to fillet and make 2 millimeter fillet over there. And now we will make some holes for fixing the second chassis, the top chassis. Click on this plane, sketch normal 2, and draw a circle over here. 2.5. This point, let's select midpoint, or it is already selected. Select this edge, select midpoint, select this, make them vertical. Go to Sheet Metal, Extrude Cut through all. click OK. And here we can add one more hole by drawing a circle or simply linear pattern. This hole direction is this edge over there, and quantities to feature this hole and make it 20 millimeter over there. Click OK. And now we need a similar edge flange on the other sides. So first, let's make sure that the first edge flange is mid-plane extruded, edit feature, and here make it mid-plane. So this process will save us from creating a new plane. Go to front plane, mirror, and let's pick the edges that we want. First, we need this edge and this edge, and that's it. Click OK. So the edge flanges are able to be mirrored. Unlike others featured in sheet metal, they cannot be mirrored and should be created individually. We discussed this in the previous tutorials in this course. And on the top there, we will add a 3.5 millimeter edge flange. Go to edge flange, select this edge. And make sure the material outside. The length is 3.5. Click OK. And add a fillet of 1 millimeter around the sharp edges. Feature, fillet 1 millimeter. Okay. And here we would like to make a cables hole. So let's draw a slot, center point slot, and make it to be in the center of, and here make a dimension of 10 millimeter and 10 millimeter over there, and here make it 16 millimeter, and one more cut to add. Select center rectangle and make a rectangle over there, tangent with this edge or collinear, and this one is 27.5. So extrude cut, sheet metal extrude cut, select this. Area and this area and this area, extrude cut 10 millimeter, And here we can make the distance from the center of the slot and the edge 27.5, so that we have chance to make another cuts over there to fix the second chassis or the top chassis. And here we would like to make some ventilation slots. Click on vent, click on that face, make a sketch normal to, select center slot and draw slot and define it with some dimensions, radius 1.25 and this is 6.5, and from this edge to this edge 7.5, and from this point to this edge also 7.5. Go to the, and here go to linear sketch pattern, and we need to fill that surface with slots. So let's make the 7.5 the distance between, and let's make it 10 instance or entities to pattern this slot. So we can, and here the distance we can make it 7, and in direction 2 we can make 3 lines of pattern, and the distance we make it 12, and we can skip the unwanted pattern, this one, and this one. Here we can try to make it 7.1. That looks better. So we can skip more instances over there. Can skip this slot and this slot, and make distances 7.5, and we can skip this one over there. When you are satisfied with the shape, click OK. Now add a little dimension over there, and over there. That would define the pattern. Click OK. Now the pattern is fully defined. Go to Sheet Metal, Extrude Cut, Length to Thickness. Click OK. On the other side, we will make the ventilation hole. Click on that face, start a sketch normal to, and draw 3 circles. First, make a distance from the center of the circle to the edge 20 millimeter. Select midpoint, and the center, make them horizontal. Here the outside diameter should be 35, and this distance between the center to the edge is 20. So we need to fix the place of the hole over there. go to normal 2, and here make it 35 instead. So let's check. So now it is correct. So again, edit the ventilation sketch, normal 2, and here should be 25, and the last circle 15. Now let's make lines for the spars. Select line, select center point to the outside circle, and circular pattern the lines. So the direction or the center of circular pattern is the point over there, and entities to pattern this line and make them eight. Click OK. Now go to sheet metal vent. As we learned how to use it, the boundary is the outside circle. As you notice now, it is already got a cut, and the ribs, let's make that and the ribs, let's select the lines, and for the spars we can select this circle and this circle, and we have 2 mm spars and 2 mm ribs, and define a fillet of 1 mm, 1.5, and click OK. And hide the sketch. So this is the ventilation. Now we will make some mounting holes on this chassis to mount the second chassis. So go to this surface, start a sketch, normal 2, and draw 3 center point rectangles in the middle of each edge, and a third one over here. So make the edges of rectangles equal, and give it a dimension of 5 mm. And the second side of the rectangle is tangent or collinear with the edge of the chassis, as well in the rest of rectangles. So now they are fully defined. So extrude them, go to sheet metal, extrude cut to this surface, extrude to surface, and select that surface, or better, this surface over there. click OK. So now we have the mounting holes over there. And here we may need some fillet for the sharp edge here. Go to fillet 1 millimeter. Click here and on this side. Also you can add fillets over here. Click OK. So now we'll see the final touches. Now we need more edges. Here we need another edge flange. Go to Sheet Metal, Edge Flange, and select this side. And it is already material outside. Edit, make it normal too. Now we can mirror the holes as well. Select front plane, feature, mirror. Click OK. And one last thing, we need a socket hole over there. Normal to center point rectangle. Give it a dimension of 27 by 19 and a fillet of 3.5. Okay, and dimensioning, make it 17.5, and this point to this edge as well 17.5. Click OK, go to Sheet Metal, Extrude Cut, Length, Thickness, OK. So now we have the power supply is almost ready. We can also add an impulse to the bottom. Go to Forming Tool, Countersect, Impulse 2, and position. Make sure it is in the select midpoint, and this point, make them horizontal, and as well over here. Select midpoint, and this point, make them vertical. Okay, For the top chassis, start a new part, click, go to the front plane, start a sketch, and draw this shape. Make this point with the line midpoint, give it a dimension of 80 millimeter, and here 30, the angle 115, in this gap 0.75, and this edge 5.4. We can mirror the same lines on the other side. Go to mirror and select these three lines, mirror about the center line here. Click OK. So here we have the base of the top chassis. Go to Sheet Metal, this flange, and extrude it to 150 on the other side, and here you will have the same sheet metal configurations from the previous part, 0.75, and the rest of the values. Click OK. And for the appearance, we can add brushed steel, and also we can add a material over there, stainless steel sheet, apply, close. So here is the base shape, and let's just make sure that the side of sheet metal is outside the sketch, as we notice over there. Click OK. We can make one thing to make it easier to follow, or that top chassis is matching the bottom chassis. We can start an assembly and work in the assembly mode. Click OK, and here show the center point, and drag part 1 in the center. So now we have the chassis is centered. Hide again the center point. Let's mount the top part. Select top part, and here we can make this side coincident to this side, or we can make this line coincident to that face. Click OK. Now let's make this one coincident. Click OK. So now we have the basic shape is matching the top chassis, and here we can make some modification. We can change this, the color of to make it easier to see. So here in the assembly mode, it can be easier to check for matchings. So we can go now, try close the gap. If we go here normal 2, you'll see there is a little gap over there. We can measure it and close it, and measure the gap between this face and this face. You'll see the normal distance is 1.26. So go to the
edit part, and edit sketch. And here we can make it 30 minus 1.26. Rebuild. Now it is matching, and here we need to make the material inside. Edit part. Click OK. So now we have the two sides perfectly matching with the top chassis. And normal to, and another dimension. Click OK. And exit the sketch. Now we don't have any warning, then let's continue modifying the top chassis. Here we need if we change the transparency, here we can notice that we need some cuts. So let's try to create that cut. Select that or edit part. Normal to start a sketch on that face. Normal to and draw a cutting rectangle. The same on that side. The two sketches are fully defined. Now go to Feature, Extrude Cut through all. So it will cut only on the top part. And here we need an extra cut for that edge. Start a sketch, normal to, and select again a rectangle from this point to this point, and this line with this line. Collinear, Feature, Extrude Cut, up to next. And here on the top, we need more cuts for inserting a mounting teeth. So go to the top plane, start a sketch, normal to, and here we can show the rectangles that we need. Select center point or select a rectangle and draw a rectangle for that cut, and one over there, and a third one in the bottom
go to Feature, Extrude Cut, up to Next. Click OK and change the style of the material. Now we can see that we created a cut for the mounting teeth. Now we need to insert an edge flange over there. Go to Sheet Metal, Edge Flange, and select this. And we can make it the distance 3 or 2 millimeter. And the material we can make it bend outside and select the rest of the edges. So that is the mounting teeth to mount the top chassis. Click OK. And now more things to add. We need holes to fix on the edges. Start a sketch in there, normal to change the style of the material, and draw circles matching the and we can fully define them. They are already matching the holes on the bottom chassis. Go to Feature, Extrude Cut, through all, click OK. Change the style of the material and you'll notice that we made perfect holes that they are matching the base chassis. So now the top chassis is almost fixed. On the top, on the bottom chassis, we have the screws over there and we have the mounting teeth or tabs over there. And one last thing to add is ventilation holes on the top, similar to the one on the side over there. Click on the top plane, normal to, and draw a center line. And draw cutting slots. Then, and from here to here, 5, and the radius over there is 2.5 by 2, so it is 1.25, and the distance from here to this size is 21.5. So now we need 3 lines of these slots and 7 pattern to the left. Go to linear sketch pattern. On the x-axis, make it 7, and on y-axis 3. The distance should be 5 on the x-axis and 16 on the y-axis. Entities to pattern is this slot. So here we can change the directions. Click OK. And here we can try to fully define, calculate. So remove the relation, so it will be a bit easier. Click OK. Now mirror the slots in that center line. Click OK. Now go to Sheet Metal, Extrude Cut, link to thickness. Click OK. So now we have the ventilation slots are ready and the shape of the power supply looks better. Now exit that part. So change the transparency and again return back to the main color of this. So here we have the final look of the power supply. Save all, and now we can go to this part, open part 2, and try to flatten the part to see. Now we have the part which we need to cut to create that power supply. In the next tutorial, we will see how to create a drawing to send that part for manufacturing and what is required in sending sheet metal drawings in order to understand the bending process and where to bend. So the next tutorial will be the last tutorial in this series, and it is about how to create drawing for manufacturing the parts. So we'll make this example in order to show you how to manufacture or produce it by sheet metal processes. Welcome to tutorial number 175, the last tutorial in this series, Sheet Metal in SolidWorks, is about making the drawing for your sheet metal products to be sent for manufacturing. So before starting with this tutorial, I assume that you already attended the SolidWorks drawing section. If not, I will put the link for that series in the description below. In this tutorial, we will make drawings for our previous product. We made it in the previous tutorial. We made this fully manufactured power supply, and we will make drawing for it to send it for manufacturing. So we will see the difference between the standard drawing which we saw before and the sheet metal drawings. We will make as well the standard drawings, then make the flattened drawing, and we'll talk about the bin table and punch table. So here we have our power supply from the previous tutorial, which contain of two parts. So first, let's make the drawing for the top part, and for this part we'll make it from the part mode, open part, and for the next drawing we will make it from the assembly mode. So we have our top part over here, and as we learned before, to make a drawing, go there, make drawing from part or assembly. And here we will choose A3, the most popular one, click OK, and here we get the sheet paper, and if you notice to the right you will have a flattened pattern. So this is new for a sheet metal. We didn't see that in the solid products. So let's first make the standard views, find the front plane, and make the right plane and the top plane, and then the isometric. Click OK. We are already familiar with these views. We can make some arrangement to make a place for the flattened view. So now we have the basic drawings over there, and they are half the size of the original size, because as you see there, half 1 to 2. Now let's go again to the drawings and pick the flattened pattern. So this is the most important view of the sheet metal drawings. You can also make from it a front and top view, but in this case it is not necessary, because all we see is a flat sheet of metal. So now here, if you zoom in to the flattened pattern, you will see the direction of bending. Here are the bending lines, which are very important, and here we have as well the other bending lines and the information on them. So it may a little bit confusing and not clear to see. We can manage it, for example, changing the size, limit to double the size or the actual size, and it is actually depends on which is better to be sent. For example, there is a way to send all the views, the standard views and the flattened views. For example, the reference will be the flattened view, and to make it easier, also sending the standard views. But it might be small and difficult to see. We can try to change the size to 1 by 1, but as well in this case it will be, the sheet of paper will be small to handle the views. So one way to solve it, for example, we can delete the flatten view and make it in a spreadsheet, and here we can have only the standard view, the front, the right and the isometric, and we can define them by adding dimensions. We can add dimension automatically if you go to annotation, model item, and select the view, and here pick the first one and second one. You can add more and click OK, Yes, and here you will get the dimensions which we made. Here you have all the dimensions. It is an easy way to add dimensions. And again, we can add it for the next view. Click OK, and here we have the required dimension for the right view and the last view. Click OK. So to deal more about drawings and so on, as I said, you can attend the drawing section again. We already discussed it about the basic drawings. So here is the first standard drawing, which can be additionally attached to the flattened pattern and sent to manufacturing. So start a new drawing. OK, and pick A3, and for the part we will need the part 2 and check the A flatten, and here you get the part over there. So as we said before, we have the bending lines in there and the information required in order to manufacture this part. Also, you can make it bigger, for example, because we have enough space. We can make it 2, or we can make it 1. So now it is easier to see and more. So you can save this drawing and attach the second one with it, which we made in the beginning. So this is one way. You have the flattened pattern and you have the standard drawings, so it can be helpful in that case. For the next part, we can see another way. We can make only the flattened view and attach instead the punch and bend tables. So that might be more accurate and easier to see. And let's go back, and here I have the standard views. So now let's go back to the assembly, and we will make a drawing from the assembly mode. First, go to new, make drawing from part assembly, select A3, OK, and here you'll see that we have only the assembly, but we are interested to make drawings for the base chassis. To locate it, go to View Layout, Model View, double click on Part 1, and here you will see what you can attach to that drawing. We need the flat pattern, of course, beside the standard views. And here you can change the view that you want. So click over there. Here we can add top view and here a side view in order to make it easier that there is a forming tool in the middle, and here we can see the shape of it. And as we said, we have only the flattened pattern, so we can increase the size to be 1 by 1. If it didn't change, go to Sheet Metal Scale and select 1. click OK. So there is the bending lines are shown over there. If you click on the bending line, you get the information, and you can also add more information. You see the direction of bending, the angle of bending, and the bending radius. You can add also more information to this bending line. If you click on the view, go to the left, here you will see the parameters you may need. So for example, the bend direction is already selected, supplementary angle, and the bend radius. Here you can add bend order. You see the bend, this is the first bend, the second bend, and so on. That can be handy. Click OK. And if for some reason it is not clear to see from the paper, so it can be easier to make it in separated table. If you click on the right mouse, there in the bottom you will see tables, or you can access that, or in annotation tab, tables, and we are interested in the bin table, and here are the format you can choose from. Click OK, and here you will see the information on a table, which might be easier to see. And here you have the tag, direction, angle, and the inside radius. For example, A, you'll see the annotation is over here. So you can, let's select all the annotations and make an arrow. Click OK. And here you can see where is A and B and C and so on. So this way may be easier. So it depends in which way you can see it better. So here we have G and E and so on. And here is the fixed face, which is the base plate. And one more thing, in this flattened drawing, we have a forming tool, which used in the middle. We use an emboss to create the punch in the middle of that sheet. So we can show the information related to this forming tool by showing the punch table. Go again to table, select punch table, and here you will specify the X and Y axis to locate the place of the forming tool. So for the X axis, I will select the bottom edge, and Y axis, I will select the first edge over here. So we have the origin point should be over there, and the face will be this face. So this is the easiest way, and click OK, and here you get the punch table related to that forming tool. So the tag is A1. SolidWorks automatically recognized that punch or forming tool, and the location related to the origin point which we made, 0 and 0 over there. Y location, angle, and quantity 1. So you can add dimension for that. Go to Smart Dimension and to make it easier to know, and you can add dimension for the rest of the parameters. We can go to model item, select first two options, click OK, click yes, and here you will see all the dimensions shown in the drawing. Or you can add them in a separated sheet with the standard views. So there are many options in order to reach to the final manufacturing shape. So for now I will go to annotation and hide the dimensions for now, and we can add them or show them when we need. Hello and welcome to the very first tutorial in a new series in SolidWorks Mold Tools. This is tutorial number 176 in general, and we will talk about the mold tools, where to locate the commands, and which manufacturing processing are using the mold tools. And then we will have a quick review for the surfacing section in the mold tools and how they are related to the mold tools. And then at the end, we will have a look at some important definitions in molding, draft, parting line, and shrinkage. So go to SolidWorks and start a new part. Okay, so to find the mold tools commands, go to Insert, and here you will see molds, or an easier way here in the tabs, right click and check mold tools, and here you will get the mold tools sections or the mold tool commands. So if you have a look at the mold tool commands, you will see there are 4 sections. The first section is related to surfacing. Most of these commands we talked about in the surfacing section, and here are the analysis section. The third section is drafting and parting line and scaling, and the last section. This is also an advantage of the SolidWorks software. It has mold tools commands, so it makes working with molds easier. As we know, making molds is a complicated process, and the molds are used mostly in injection molding processing, manufacturing process, mostly for plastic, and also in casting. Also, there are some molds or dies for forgings. So before going to some molding terms definitions, we will have a quick review for the surfacing sections. And I will put a link below for the surfacing tutorials which we talked about before. So let's go to the top plane and we will make a very simple block. So let's make it of a cube and here make a dimension of 200 and extrude it in two directions. Go to Features, Extrude, Mid-Plane, and extrude it 200 steel. So let's add a steel. Also, there are some molds made of aluminium. So we have a very basic block without any separation or any parts. Go to the mold tools and we will see how to use the planar surface. Go to the sketch one, show, select planar and select the sketch. Click OK. So you just created a separating surface. Hide that. You will see there is a surface. So this is one way to use planar surface. And also if you would like to, let's show again the block, and if you would like to have the planar surface not in the middle, like shifted 1 centimeter or few millimeters above the center, you can go to the offset, select the planar surface and make it 20, for example. Click OK. Hide the block again. You will find a second surface which is offset. Show the block again. Rolled surface. For example, if you don't need all the time to hide the block and need to show the surface, let's hide that sketch because there are two surfaces but they are not shown. You can go to rolled surface and here are the options. For example, you can select the edge of that surface and the rest of the surfaces, the rest of the edges. So here you have a 10 millimeter. You can increase it. You can make it normal to the surface or tap it to vertex or sweep. So we stick on the first option. We can make it just straight. And when we are done, click OK. So now you have the surface is clear and it is clear there is a surface separating the block. And fillet surface, for example, if you would like to have a different shape than the cubic shape or the square shape, you can make a custom surface. You can just, for example, create that surface on the top of that shape and draw a circle, give it a dimension of 350, go to surface, go to the mold tools, exit from filled surface, select, so you fillet that surface which is a circular surface. So I'm going to suppress that circular surface. So it needs surface. For example, we have created that separating surface, but when we generated that with the rolled surface, we made one for the rolled and a second for the main. And here is the offset which we can suppress to make it clear. So that offset, and here we have only two surfaces, which can be better if we made them in one single surface. You go to neat surface, you can select the rolled and the planar surface. Click OK. You will notice that now we have only one single square surface. So this is a quick review for the surfacing commands in the mold tools, and later on we will see how we can divide the block and make it two parts and adding parting line. So now let's talk about some molding terms. So the first term we will talk about is the draft and why we need a draft. So the draft definition, according to the Wikipedia website, is the amount of taper for molded or cast part perpendicular to the parting line, and it is measured by degrees. And we will show this what is exactly mean with draft. And you may already know what is the draft because there is many commands in SolidWorks. We use in the solid features, we have the draft. So there we are creating an angle. And why we need the draft? It makes it easier to extract the parts, the injected part or casted part from the mold, and that will also increase the mold life. As you know, the molds are quite expensive. And the next term is the parting line. So this is the parting line where the draft is calculated. So we made the part, as you remember in the beginning here. So the parting line should be this line over here, which is separating the mold. Also, draw the parting line here, so we can draw that separating line between the two sides of the mold, and here we can draw so here I made a very simple shape. If you see the line, the straight line over there, that can be the parting line, and the top side over here is the upper side of the mold, and here is the lower part of the mold, and here is the casted or the injected product. Let's say it is a cup over there. So the draft is, if you see the angle, also the draft can be positive and negative. Here, for example, this side, and we said this line is the parting line, and here can be a positive draft, and this side is a negative side. So if you imagine the product over there with a draft, it will be easier to be extracted from the mold. So this is a positive draft, and here this side is a negative draft. So here again we can see this is the parting line, and here is, if we make a straight line, and here is the draft angle. So one last term is shrinkage. Once we extracted this cup from the mold, so this is the actual size of the mold, but after cooling it will get smaller. For example, it is a plastic or a metallic, so that is a very basic. So as we know, the material are shrink when it gets colder. If the plastic which is used will be shrinking with 40%, so the mold should be designed 4% larger than the actual product. Welcome to tutorial number 177, the second tutorial in SolidWorks Mold tools. In this tutorial, we will talk about the first command in the analysis section of Mold tools, draft analysis. For that reason, we will make this plastic mobile cover. So we will apply the draft analysis on that plastic part. And we will show you how we made this in this tutorial. And also during the design process, we will have some faces with a draft and other faces without a draft, or we can notice that in the draft analysis process. And then when we are done with the part, we will apply some draft analysis to that part and see if it requires some drafts or not. And that is the first step for preparing the plastic part for injection molding and creating a mold. And we will see the colors and explain them and read the draft from the part and see if there is a need to add any draft to the part. Now we will start making a front cover of a simple mobile phone. Start a new part. Go to the top plane, start a sketch and pick a center point rectangle and give it dimension of 43.5 and second side 118.5. Add a fillet of 18.5 to the upper corners and 12.5 to the lower corners. Now we'll make another sketch or another profile for the top. Select 3-point arc and here and give it a dimension of 50 radius and the point from here to here 26. Make this point and this point horizontal. So now we will extrude the first profile. Go to Feature, Extrude, and select the outside profile. Extrude it to 5 millimeter and add a draft of 5 degrees. So that is an important. Click OK, and now show the sketch. So select the sketch, go to Extrude, selected contour, select that contour, and it have to be 5 plus 3.5 and the draft as well 5 degrees merge results. Hide the sketch. And now select the right plane, start a sketch to make a cut on the upper side. Select 3-point arc and make an arc from the first edge to the second edge with a radius of 25 and the distance between this point and the upper face 5 millimeter and make the distance between this point to the corner 15 millimeter. Go to Extrude Cut. You see the arrow of the cut is upward. Make it through all both. Click OK. We will add some fillets. Go to fillet, first fillet is over there and make it 20. Click OK and make another fillet with radius of 7.5 and select this edge. OK, and the last fillet for the upper face is 3.5. Select that edge, click OK, click OK. Now let's shell the cover with a thickness of 1 millimeter. Click OK. And now we'll make a cut for the screen, the mic, the speaker, and the buttons. Go to this face, start a sketch, normal 2, and here make an offset of 1 millimeter. Reverse, click OK. So this is the first cut for the screen, and here we will make a cut for the speaker. Let's make a reference circle over there for construction and give it a dimension of 7.5 and dimension from this point to the upper edge also 7.5, 9 millimeter, and the center of the circle to this point vertical. So this is the reference circle for the speaker holder, and now we'll make another circle for construction for the cuts. Make it a dimension of 7.5 divided by 2, and let's make the cut circle 1 millimeter. This circle is equal to this circular pattern. Direction is this point. Click OK. Here we can make the hole a bit tighter. We can make 3.25 and make a relation over there and add a dimension to fully define the circles. And here in the bottom we will make a slot for the mic. Draw a slot with the dimension of 3.5, the radius of 0.5, and the distance between this point and the down edge 9 millimeter. Give a relation from this point and the origin of vertical. Here we can make it a little bit smaller, 5 millimeter. So now we can make a cut and make the buttons in another cut. Now we will make holes for the buttons. Start a sketch on this face, normal to, and draw an ellipse. Give it a dimension of 7 mm, for the vertical distance 5.25, and the horizontal distance 7.25, and make a distance from this point and the origin to be 11 mm. Now let's add some relation to fully define the sketch. Select these 3 points, make horizontal, and this point vertical, and add 2 more dimension from this point to this point, the lowest edge of 18.25 mm. Here we'll draw a center line for reference reasons. And now make a linear pattern with that ellipse. Entities to pattern this ellipse on the x-axis, make it 11, and 3 reverse the directions. So you have the second ellipse is central in the middle, and we need 4 on the y-axis. And make a distance of 8 or 9 millimeters. Click OK. And here we'll draw the main buttons. And here make this line, this point coincident, and give a dimension of 10.5 to this, and here give it 5.5. Let's fix this ellipse, and here the distance 5.5, and this line 8.25, and add a fillet for the corner of 2.5. Go to mirror, select these entities, this line, click OK. You can add a fixed relation for each ellipse or fully define sketch, and make a cut through all. Click OK. Now we will make housing for the mic and speaker holes. So if you show the sketch of the speaker holes, and here for the, and let's add another circle for the mic, edit sketch, normal to, and let's make the distance a little bit bigger, 7.5, and add circle, make this circle with this line tangent, and make that circle for construction. Sketch on that face, normal to, select this line, convert entities, as well select that line, convert entities. Go to features, extrude, select here thin feature of a thickness 0.75 inside the circle. And extrude it up to body, select that body, and here make an offset of 2.5 in the other direction. Click OK. Start a sketch on that face, normal to, and draw a circle over there, the dimension of 3.75, and distance between this point and the origin 11 millimeter, and the vertical distance 50 millimeter. Make a center line to mirror this circle on the other side. Select mirror, select this circle, mirror about center line. As well, we can mirror them on the left side. Make again another center line, mirror, select both circles, mirror about this center line. Click OK. Now extrude out the body. And we will add to these screw cylinders extra fits so it fits better on the second side. This process could be saved if we make the circles in the previous process when creating the screw cylinders. Select this face, click offset 0.3 reverse direction, make it inside, click OK. And for the rest as well. Go to feature, extrude 1 millimeter. Click OK. Now we will make the holes for the screws. Go to hole wizard, select hole, and the diameter is 2 millimeter, and the distance here make it 5.25. Position, select each cylinder of them. Let's check the hole. They are not. Okay, here we need to decrease the hole, make it 4. So that looks okay. Then click OK. And here we have the holes. And one final touch to add a fillet for the edges. Make a fillet 0.25. Select this face. This face. This face. Here is our mobile cover ready. First thing I would like to mention is the top plane. If we notice over there, the top plane is our reference in creating this part. So I will show that plane. And now go to Mold Tools, select Draft Analysis. So the first option over there is the analysis parameters, which means that we need the reference for this injected molded part, which represent the direction of pulling and injecting. For example, in this case, we can consider the top plane is the reference because the pulling will be upward. So we select the top plane, and here the angle represent the draft angle. So this angle is probably high. For this I will make it 1, but for now, if you notice the part, we have green on the top side, as we discussed it in the previous tutorial, that represent positive draft, and the yellow faces, these are parts require drafts, and the negative, so far it is in the bottom side, that represent a negative draft. It is okay so far, it is in the bottom side because this side will be dragged outside. So as you remember, in the design process we added a draft for that face in the upper side, and we didn't apply any draft when we created the screw cylinders. So that you can see that in the draft analysis process. So the draft analysis purpose is to check for draft and which part you draft. So that is the reason we didn't add a draft, to show you that it can be shown over there. So, and if you hover over the face, you will see the drag or the draft angle is 0 degrees, and if you hover over this, the draft angle 5 degrees. As you remember, when we started to make this part, we extruded with a draft of 5 degrees. So close this for now and go to the part, and here we added a draft of 5 degrees. So let's just remove the draft, click OK, and check the draft analysis, check the top plane, and here the side, outside side without any draft, you will notice it is in a yellow part. So this is one thing to think about, is while designing a plastic part, to add a draft during the process, that may save some time. So exit the draft analysis and fix the part again at the draft of 5 degrees. Now go back to draft analysis, select the analysis parameter, we set the top plane, and here is the draft angle. This draft angle is for comparing reason. For example, we wish to have 5 degree draft angle, for example, for the outside side, and if you click OK, that will show you everything is in green, and click again. Let's say that we needed 10 degree for our product, so select the parameter, and here you will see that this side will require a draft, but for our case we already applied the draft for the outside face, and we don't need to compare it, and just need to compare the draft of the inside cylinders, and we wish to have between 0.5 to 1 degree draft angle. So let's make it 1 degree. So you'll see that the top face is okay, and we need only to fix the outside face of these cylinders. And if you go to adjust triad, if this is if you would like to change the angle of the reference plane. For example, we said the plane representing the direction of pull. So if we adjust, and let's say that part will be injected in with an angle, and you will notice there are some troubles with some faces, but that case is not logical, and just exit, return to normal, and or Ctrl Z and start again. And here we set 1 degree, and let's say for the direction of pull we take it the right plane. You will see there is something wrong and everything needs to be changed, and it is clear that the direction is wrong. Otherwise, that is the correct direction of pull, and then this part will require a lot of work. For example, you need draft in each of these faces. So return to top plane, 1 degree, and face classification. So the positive draft, we have 32. The faces required draft in yellow, 59, and the negative are 49. The negative ones, they are okay. So far they are in the bottom side. Straddle face, this face is kind of in between in some meeting points, and here the positive steep over there. So these faces are in green. It is somehow okay. They are laying in between the positive draft and the required draft face. So the area in between, it can be a steep face, and for the bottom steep it will be in dark blue. And let's say that we need to apply a draft angle for these outside cylinders, and then start the draft analysis once again. So for this, for example, the bottom holes, we can apply a draft, but it is a thin layer. It might not be that big problem for injection molding, but the cylinders over there we need to try to fix or add some draft. And inside cylinder, since it is designed for a screw, logically it doesn't need any draft. So exit and see how we can apply a draft for these faces. So you have one choice is to go to draft over there in another way by going to the solid feature over there, and when we extruded this part, you could add an angle of 0.5 and make it outward. Now go to draft analysis again, and the reference plane is this plane, and here we set 0.5, so we get the red over there. So as we said, the red in the bottom side is okay, and we can add one more draft for that face. Select add draft 0.5, click OK, and check the draft analysis once again, and here we get a red color. So we need only two faces over there, this face and this face. Click OK, select this edit feature and add draft of 0.5. So we got a green, that means in the bottom side, that means this is a wrong direction of pull. So edit again, make it outward, click OK. So now we have the bottom side is ready, and we have the pulls. We have the draft applied for the required faces, and on the top side. And if you wish to add a draft as well for that part, so that can be done during the cut by adding a draft and running the draft analysis once again. So one last conclusion, this tutorial, that the draft analysis is a very good way to check for the draft. If someone needs to add a draft, also it is a good practice to add a draft during the design process. That would save some time. Hello and welcome to this tutorial number 178. In this tutorial we will talk about the next command in the Mold tools, undercut analysis. In the previous tutorial we talked about the draft analysis, and we see how to apply the draft and read the colors and solve any draft issue in order to make the injection molding process easier without any failure. In this tutorial, we will talk about another issue, the undercut analysis, and understand the meaning of the undercut and applying and solving the issue. So now here we have this mobile cover from the previous tutorial, and as you remember, we applied the draft analysis, and here we selected the direction of pull, which is the top plane, and the minimum draft analysis we wanted was 0.5, and here you have all the part as we need. But there are also other issues we have to look forward. For example, the undercut surfaces. So let's go to the undercut analysis and discuss more about it. Here we will also pick the direction of pull, again the top plane, and here we see the undercut faces. The first two cuts, direction 1, direction 2, they are the faces which you can see from direction 1. If we look on that arrow which represents direction 1, and here we see the light blue faces, and direction 2 are the faces which we can see from the top side. So basically these are faces, no worry about them, because they are just representing the faces which we can see from top and bottom of this cover. The two faces we need to think more about, the cleared undercut and threaded undercut. These threaded undercut are something in between, might not be that big problem, but the uploaded undercut, we need to try to think how to fix them. And they are shown in red. For example, we cannot see them clearly. They are mostly because of the plate over there. So the undercut, the occluded undercut, actually the faces can be difficult for the to be injected or to be seen by the mold. And to make it clear, we can try to make another example. So the occluded undercut in this case are because of the fillet over there, and there might not be that big issue. It can be easily extracted from the mold. So as we said, the undercut faces are so tiny and they are not that. By imagining the injection direction, it will not represent any issue. So we'll have to do another case where the undercut might represent a problem while extracting the cover from the mold. So here, start a sketch, normal 2, and let's make full sample a cut for the charger or the speaker. Point 5 and 8 millimeter, and from this point, point 5, and select this point horizontal with this point and make a cut of point 5. So for example, we have this extruded cut in this cover, and go again to Mold Tools, Undercut Analysis, and the direction of pull is the top plane. And as you notice over there, we have a large surface with unseen undercut face. So this face might represent a problem. It is unlike other tiny fish over there. So there are two ways to fix this cut, either by removing it or making a path for the surface. So let's make exit from the undercut analysis, select this face, start a sketch, convert entities, and make a cut through all. Click OK. So now we made a path for that surface, and let's again go to Mold Tools, Undercut Analysis, and select the top plane, and here we have only one face after we solved the inside face, and we can try to fix this issue again by adding another draft. As you notice, we solved the face over there, and we have one remaining undercut face need to be solved. We can easily fix it by make the cut through both directions. So as you notice right now, we managed to fix that cut over there, and here can be a snap fit, or so this area can be a place for a snap fit, or also you can add another hole over there for the charger.
Welcome to SolidWorks tutorial number 179. In this tutorial we will continue talking the next analysis tool in the Mold Tools section. So the next analysis tool is the parting line analysis. So after performing the previous analysis, draft analysis and undercut analysis, now it's time to prepare for creating the mold. So for creating a mold, we need a parting line. So the parting line analysis aims to help in placing the parting line of the mold. So let's think about this part, and we need a mold for that. And here is simple view of a mold of two parts. And let's imagine that the inside cavity is for the mobile cover. We closing the mold. There should be a parting line. So let's close this mold and change it to and change the transparency. So you can imagine the inside product is the mobile cover, and here is the parting line in the middle. So the parting line analysis feature helps to place the parting line for creating the mold. Now let's go back to our mobile cover and let's see where we can place our parting line. In this case, for this upper half, normally it should be inside the top of the mold. So let's click on the parting line analysis, and the direction of the pole is the top plane, and you will notice the parting line will be on the edge over there. So it is logically, as we said, that would be the upper side of the mold. So in this case, the parting line will be on the edge, or in other words, this part will be inside the mold, and the top face of this part will be the top face of the mold. If we go back to the mold over there and hide this part, so this is the upper face of the bottom mold, and here is the edge, which can be the parting line for our mobile cover. So to make it clear, we will make another product. So let's see another example. Start a new part and pick the top plane, and we can draw a simple cone. Click OK, and let's say we would like to create a parting line for this part. Go to the mold tools, click on the parting line and the direction of pull, depending on how you would like to pull it. Let's say we would like to have a mold that will with a direction of pull on the right plane, and you will see there is the parting line in order to inject each half of this cone. And if you would like to make the direction of pull the top plane, so you will notice that the whole cone will be injected in the first half of the mold, and there is no parting or preview for a parting line. So depending on the size and the mold, you can pick as a helping tool for placing or where to place the parting line. And we are done, click OK. So you'll notice this is the recommended parting line for your mold. And here we can notice, if you imagine this product, so this is the first half of the cone, and the second side will be the other side of the cone. Welcome to tutorial number 180. In this tutorial we will talk about the feature section, as we see in the picture below here, or the section comes straight after the analysis section. As you might notice, this feature can be found in other sections, but there is a reason why they are in this mold tools sections, because they have some specific importance. We will talk about the split line feature and then talk about the draft, move face, and then the scale, and see how they are related to the mold tools section. In the previous tutorial we performed a parting line analysis for this cup, and we took the right plane as the direction of pull, and we got the parting line shown as we see. Maybe in this case for this cup, maybe the best pull direction is the top plane, and that's why we will try to make another example to run the parting line and then talk about the split line. Also, we performed the split line or parting line analysis on the mobile cover, and if we took the direction of pull to be the right plane, as you notice, click OK, you didn't get any line, so that is clear that is not the right direction of pull. Or you cannot, for example, mold this part in two separated, each half in one separated part of the mold. So that's why again we run the parting line analysis and pick the top plane. And once you have the parting line analysis on, you'll notice there is no any appearance or colors on the part. So let's start making a new part. This time we'll make a simple vase and try to make parting line, and then how to use a split line as a helping tool. Here I will insert 4 planes parallel to the top plane, and in each plane I will draw a circle 30, and on the second plane another circle, make it 40, and on plane number 3 another circle, and give it a dimension of 100, here again another circle, give it dimension of 60, and then the last circle give it dimension of 75, and go to feature, boundary boss, and select So this is a simple vase, plastic vase, and for this kind of part, because it is curved, it might not be possible to make the direction of pull to be on the top plane. Let's just hide the planes. It will be difficult to extract this from one side. So let's go to mold tools, parting line, and if we pick the top plane, this shows that this part with this complexity can be molded on 3 parts, because this side to the left, if you separate it, and that side by itself can be easy to be injected and extracted, and the second side, and so on. But this might be not logical, and let's try now to find a better solution. Go to parting line and this time select the right plane, and here we got a more logical solution with one parting line, and we said that parting line represents the line between the sides of the mold. Here we can add appearance to this. So again, go to the parting line and select the right plane, and here we got the parting line. But you might need to not to work on the parting line mode, so you can deactivate it, and instead, as we know that there is the parting line is over there, we can make a sketch on the front plane and draw a line matching the parting line and exit, and then we can go to split line and select the face, which will be this face, and select projection, click OK. So here you can deactivate the parting line and you get the appearance again, and by split line as a helping tool. So here the split line, you will get a preview for. So by performing the parting line analysis, we knew that the line over there in the middle representing the parting line, and we made a sketch that is matching that parting line, and to keep it as a reference while working, or to see it without the need of activating all the time the parting line analysis mode, we created a split line. And now let's talk about the next feature. It is also an important feature in injection molding tools. Every part, as we said, to make it easier to extract, should have a draft. Perform a draft analysis for this phase and we'll see what will happen. For example, we'll need a 3-degree draft angle, and here is the side of the ball, and you will notice that we have kind of not logical combination. Here you have the positive draft and then get the negative draft, and again you'll get a positive draft. This side might be very difficult, as we said, to be injected with a direction of ball is the top plane, and we said that we made the parting line on the right plane. Let's go back to one of our part, or the mobile cover. As you remember, we added a draft when we performed a draft analysis, and we added a draft and fixed all the faces over there. So it is important to get a draft to make the part easier to extract. For example, we can run draft analysis. Let's make a part, a new part. Here, let's extract a cylinder and perform a draft analysis. Here you'll notice that there are a side that need a draft in order to be easier to be extracted. So here are required draft. That's why the draft feature is important in injection molding tools. So we can make a draft, pick draft, and here the neutral plane would like to be this plane, and face to draft this face, click OK, and now let's perform the draft analysis and pick this face and the reference 0.5. Click OK. Now here our part is green. So in order to make it a bigger draft angle, for example 3 degrees, we can edit the draft to make it 3-degree draft angle. Click OK, and the draft you can make it inside or outside. And let's run the draft analysis. Pick this face and here a reference to be 2 degrees, and we have our cup is green. And now let's talk about the next feature, the move face. We said when we are performing the parting line analysis, we get the parting line. For example, in this case is the edge, and if we would like to expand this to make the parting line shown or to make an offset for that face, we can use the move face feature. But in this case, because this simple cylinder or simple cup, the parting line will not be shown, but we can try to use the move face. If we have the direction of pull is the top plane, and we would like that 10 millimeter on the other side to be molded in the other side of the mold. For example, in the case of our vase. So let's first use the parting line or the move face on the simple part. If we select the move face, the option which will be used is the offset, but the used in our mold tool case is the offset. Select this offset and we said 10 millimeter, and here we move that face. For example, for some reason that we would like the parting line to be on the top plane, and the part over the top plane will be injected on the other side of the mold. This is only an example. For example, if we run the parting line analysis and we pick the top plane, here we will not see any parting line because it will take the edge, but with the help of split line we can draw a sketch normal to and make a 10 millimeter which is on the origin, split line and select the face, and here have our split line. And as we said, this is only an example. We can try to use it also on the face. Go to move face, select, and we said let's make it 30 millimeter. Try to use it on the mobile. For example, we would like to extend the edge of this face. Over here to be matching the screw cylinders. We can pick move face and make it 1 millimeter. Click OK, but I will delete this feature for now, and we can solve it by adding another edge or a snap fit edge. So now let's move to the next feature, which is also a very important feature, scale. As we know that materials are expanding with heat and shrink when they become colder, and also it is the case with plastic injected molded plastic or uninjected molded parts. When they are hot, they are bigger in volume, and when they are getting colder, they shrink. That's why, for example, this mobile, if we would like to inject this mobile with the size shown in here, we should add in consideration that this plastic part will shrink, for example 5%. For that reason, to solve this, you need to add a scale. You have many options, but the most used is the centroid. It will scale, and here you pick uniform scaling, and we will make it 5% bigger. It means 1.05. So this is the part which you need to design a mold for it.
This is tutorial number 181. In this tutorial, we will start talking about the last section in the Mold Tools menu, which it is the actual tools for creating the mold. In the previous tutorial, we had a look at the Surface Features section, and then the Analysis section and the Solid Feature sections, and this section will start with the Insert Mold feature. So it is the very first thing, which is a good practice to do, is to insert a mold folder which will include the mold parts such as cavity, core, and so on. So in this tutorial we will talk about the Insert Mold folder, which it is the first command, and see where to locate the mold folder, and then we will talk about some terms which are included in the Insert Mold folders, like core, cavity, and parting line. And then we will see some reference pages to read more about molding before continue making a mold. Here is our mobile cover, which we made in one previous tutorial, and we see how to perform draft analysis and added draft which is required, and also we perform undercut analysis and parting line analysis on the same part. And after fixing what is required, now it's time to create a mold for this mobile cover. As we said before, we need to insert a mold folder. It's kind of arrangement which will include the mold parts. So click on the Insert Mold, and you will notice nothing changed or nothing is shown here, but it is actually a mold folder is inserted, and it is under the surface folder. And also you'll notice that the Insert Mold command is deactivated. So let's now show the inserted mold folder. We need to show the surface folder, which we can find it under the Feature Manager. Go to Option, Feature Manager, and here you have the Surface Bodies folder. So here you can click Automatic or Show. In this case we'll make it Show. Click OK, and if you notice, here is the Surface Bodies folder, and if you expand it, you will get the mold folder, which include the cavity surface bodies, core, and parting bodies. So that's why it is important. If you don't have any background in molding or new, it's good practice to read a little bit about the cavity, core, parting surfaces, and I have some reference pages on Wikipedia. I will attach it in the description below to read about it, so it will be when we continue creating the mold. For example, here is a page which contains many good information, and here I have a picture which is found on the same page
if we notice here, you will see the cavity which is located over there, and the parting line which we talked about it earlier over there. And there are more terms as well. And for the core surface body, the core actually is the secondary mold side, which will be used to cover the side cuts, which we talked about it in the previous tutorial about the undercut analysis. And about the parting surfaces, we use the parting line analysis to locate or to view where to locate the parting lines, and later on it will be a parting surface when we move on with the features or the commands in the next tutorials. Here, if we go back to the face, which we talked about in the previous tutorial, and we said if we made a parting line analysis and we took the direction of pull, we got two parting lines over there. So you may wonder how to be molded. So in this case, there is a mold called a three-plated mold. We can see a preview over there. But we said instead we can do it when we pick the front line as the direction of pull. This is only an example. This can be produced by other cheaper ways. This is tutorial number 182. In this tutorial, we will talk about the next section or the next command, the parting lines. And it is different than the parting line analysis. And we will talk about them, and we will see how to insert the parting lines in two cases. The first case is the mobile cover, where the product in one block. And the second example will be the face, where the product is lying between two blocks, mold blocks. And then we will have a look at some parting line issues and how to solve them, and how to select the edges, and have a look again at the mold folder and how it changed. So here we have the mobile cover, which we made in one of the previous tutorials, and we perform a parting line analysis. The parting line analysis will give you a preview where the parting line will be located. We run the parting line analysis for this mobile cover, and we selected the top plane as the direction of pull, but we didn't see any parting line. So this is not an issue because SolidWorks considered this product or this part will be included in the first block of the mold. So the parting line will be on the edge over there. So now we can select the parting line, which insert the actual or the real parting line for our mold. So click on the parting line, and here you get the options. So the direction of pull is the top plane, but before we inserting the parting line, we need to insert the mold folder, which we said about in the previous tutorial. Click on the insert mold folder. And here we have the insert or the mold folder. So now after selecting the insert mold folder, pick the parting line. The direction of pull is the top plane. And then the draft angle, which we said about it in the draft analysis tutorial. As you remember, we already performed a draft analysis and it is ready for this process. So we said we pick it half degree, and then here you can perform a draft analysis one more time. As you notice, we don't have any issues with this product because we already performed the draft analysis before. And if you notice the parting line, which are the edges selected automatically over here, and you can see them in purple over there. If you have a look to the edge, you can see the parting line, which we couldn't see in the parting line analysis. So this is the place of the parting line. And when you are done, and about the colors, we already talked about them in the draft analysis tutorial. And here is no need for splitting the faces because the parting line on the edge. And we will have a case in the next example where we need to use the split faces. And when you are done, click OK. So now we have the parting line, and we know that the top part of this product will be laying on the upper half of the mold or the in one block of the mold. And here what I mean, as we said in the tutorial before, when we showed you this picture, the mobile cover will be laying on, let's say, the left side of the block, and the parting line will be, you can imagine, over there. And if you look to the feature trees, you will see the parting line option is over there, and you can edit it anytime. So now let's have a look at the next example, the face where the product will be laying between two blocks. So we have to insert the mold folder, and then go to the parting line and select the direction of pull. The direction of pull is the front plane, and let's say 1 degree draft, or let's make it 0 in this case. This is only an example just to avoid seeing faces that they need draft. And let's run a draft analysis. You'll see that there is no any parting line is selected. So in this case, you need to use split faces, and then you are able to select the parting line. Select over there and over there. Click OK. We already knew that the parting line should be laying over there because we run the parting line analysis before. But as you notice, we have a parting line warning that not all the parting line are selected. If we edit again, here you are not able to select any parting line on the top side or on the, but on the bottom we can select this edge, click OK, but still we are not able to select on the top over there. So I'm going to delete this parting line and see how we can solve it. So delete, and here we have a fillet. I would suppress this feature and suppress the dome under there or down there, but we can make it a bit easier, but still you can have them and split them as well. And here we will try to insert parting line again, front plane, draft analysis, and split faces, and this time you don't see any line or any edge to select in the bottom. So exit from here, and we will start a sketch on this face and draw a line parallel to the front plane, making sure that it is covering or exceeding the product, and go to the mold tools and split line feature, which we talked about, and here it comes handy. So here is the current sketch and faces to split, this face and this face. Click OK. So now we have to split it faces. Hide this line or this sketch, and run the parting line analysis one more time and pick the front plane, run the draft analysis, split faces, and now we are able to select this edge and this edge, and here we have the top edge and in the bottom edge, and when you are done, click OK, and here we have the parting line is working or showing without any warnings. And here, if we go back to the mold folders and have a look, you will see that the cavity surface body, we have one body, and the core surface body is again another body. So you can see that the cavity body is the green one and the core body is the red over there. So you can imagine that one side is one block and the other side on the second block. Welcome to tutorial number 183. In this tutorial we will talk about the shut off surfaces, the next feature in the mold tool section. In this tutorial we will talk about what the shut off surfaces and why we need them, and we will see how to insert them and have a look at the selection manager options and surfaces types, and look at the cases when we need to insert the shut off surfaces manually, and then have a look at the mold folders. So simply the shut off surfaces are shutting the holes in the products. For example, we have holes representing the buttons and the speaker holes. So closing these holes are the shut off surfaces. But why we need to add the shut off surfaces? As you remember, from the previous tutorial, we inserted the parting line for this mobile cover, which represent the lines between the core and cavity, the mold parts. But if you again edit the parting line feature, you would notice a message over there. The parting line is complete, but the mold cannot be separated. So the reason why we need to add a shut off surface is to add more parting or parting surfaces to separate between the border of the mold parts, the core and cavity, so you will know which part will do the cavity and which part will do the core. So let's see how it works. Here is the shut off surfaces. If you click on the shut off surfaces, it will automatically shuts the holes over there because they are simple holes. And if you notice, the shut off surfaces, they are not shown. If you go down in the selection manager, click show preview, so you'll see a preview for the shot. Well, now we are shutting these holes, so you can imagine the part to the right of the surface is in the part of the core, and the holes or to the left are in the cavity part. So the cavity will be responsible for creating these holes, or in otherwise, and that we will see when we creating this mold. And here you have the edges which are selected. You can change which part will do which. For example, we can clear selection and select the edges over here. So you'll notice the sides to the left of the surface are in the part of the core. In other words, we can call them parting surfaces. But we still have the rest of the hole need to be selected in order to the mold to recognize the part of the core and the cavity. And here you have the knit option in case if there are many surfaces, so you will decrease the number of surfaces. So I will close the shut of surfaces, and I will suppress the fillet option in the mobile cover, fillet 5, and to make it easier for selection, and you can still have fillet and select them manually. Here we'll click on the parting line again. You'll notice the shut of surfaces selected all the holes. And now if you go down over there, we can show preview and knit surfaces, and here are the types of the surfaces. So in this side, if you notice, this face is straight, so it can be enough to have the contact option. But in case there are some curves and you need the surface to match this curve, you can change the type into tangent. You can click on the window over there and change it to tangent. And here we have also the type over there. You have no fill, and you have all contact and all tangent. If we click on the all tangent, it will convert all the types to be tangent, and if you click on the all contact, will convert all the type into contact. And here we can show callouts or hide them to make it easier to see. So now I will keep the default selection, and when I'm done, I click OK. So now we have the shot of surfaces are there, so you can see a better, you can imagine the shape of the mold or the core and the shape of the cavity. But in some cases, maybe this mobile cover might be simple, have straight faces, but in some cases the shot of surface can be difficult to make or to be selected by default, and you need in that case to make them manually. And we will have an example about that later on in the case when we create the shot of surface manually, and how we can use the surface commands over there to create our shot of surfaces. And now let's check if we succeed to create the shot of surface and the parting line. If we go back, edit the shot of surface, here you'll notice we get a green message. The mold can be separated and
SolidWorks can differentiate between the mold parts, the core, and the cavity. So a few steps remaining to create the actual mold. One last thing, for the surface which we created, they are only surfaces and they are not affecting the solid body, and they are just borders. And if you need to have a look at these surfaces, you can find them under the mold folders. Expand it over there, and here you have the cavity surfaces and the surface bodies and the parting bodies. So here you can see the core surfaces, which are in red. You can see them, and these are the core side of the surfaces, and here are the cavity side of the surfaces. So the cavity represents the green color and the core surface the red color, and they are equal in the number. Tutorial number 184. In this tutorial, we'll talk about the next command in the Mold Tools menu, the parting surface. And we will see what are the parting surfaces and why we need them, and see how to insert parting surfaces, and have a look at the selection manager options and the surfaces types. And then we will see how to edit the parting surface manually, when and why, and then have a look at the end at the mold folders. Here we have the mobile cover from the previous tutorial, where when we performed the shot of surfaces, which are now ready. And you may wonder, this shot of surfaces are the parting surface between the mold parts, cavity and core, but on the border of the mobile, but the mold exceeding the border of the mold. So that is the work of the parting surface, is to extend the shot of surfaces. So in other words, the parting surfaces are extend to the shot of surfaces. We called also the shot of surfaces as well parting surfaces, but on the mobile area. And for the parting surface, it takes the parting lines as a reference from where it will extend. So as you notice here, we have the red shot of surface on the mobile, and here it ends on the parting lines. And now we will extend that surface to cover the mold blocks. To insert a parting surface, click on the parting surface over there, and here you will get the options. In this case, we will pick the perpendicular to pulled surface, because we know the pulled surface for that mobile cover, which was the top plane, which is already selected over there. But in some products, you need to choose normal to surface or tangent to surface. So in case if we pick the tangent to surface, you will not notice any difference, because it will be already tangent to the pull surface. But if we pick the normal to surface, you will see the difference over there. But in this case, we don't have any complicated product, and this might be easy to extract, and it is enough to use perpendicular to the pole. And here the parting line, as we said, it is the edges or from where you extend the surface. And the parting surface, here you can reverse the direction of the parting surface, but this is not the right case. We need to reverse the direction, and here we can make it more, for example, 10 size. Here make it 50, and here you have the angle. In case if we use normal to surface, here you are able to change as well the angle of the surface related to the parting line. Here, for example, if we increase it, but as we said, we will pick the perpendicular to the pole. And here you select the type of smoothing. If you pick the two plane, you might not see any difference because we don't have any sharp edges or open edges, so you'll not notice any difference. We will try to have an example with another case where the parting surface is separated. And in the last options, we have need all surfaces. In this case, we have only one surface, and there is no more than any surface, so that will not make any difference. Here is the preview and the manual mode. Here you can modify or edit the parting surface if you have a more complicated shape. But in this case, we don't need to use the manual mode because this is the default shape, and as we said, we will have another case where we need to edit the parting surface manually. So this look fine, and when you are done, click OK. So here we have the parting surface, which is going to separate between the core and cavity outside the parting line. And now let's have a look at the mold folders. From the previous tutorial, you remember we have 22 cavity surface bodies, which represent the inside over there, and 22 for the core, and we have one more surface, so the total number of surfaces are 45, and all of them will have a purpose to separate between the core and cavity. And here is the parting surface which we added in this tutorial.
Tutorial 185. In this tutorial we'll talk about the next command, the tooling split, or in other words, creating the mold blocks, the core and cavity. And we will see how to select the face and see some cases about it, and then after creating the blocks, see how to move them and see the effect of shut off surfaces on the blocks, and then see how we can separate them and save them in separate parts for further editing. Here we have our mobile cover from the previous tutorial where we made the parting surface, and we selected this surface to be perpendicular to the direction of pull, so we already know that this surface is perpendicular to the parting line. So now let's try to add a tooling split, which in other words are the mold cubes. Click on the tooling split, and here you have two options to select the plane and or if there is an existing plane or sketch. So here we need to select a face. There are many ways to select the face. The first option we know that this surface is perpendicular to the direction of pull, so you are able to sketch on it. But this is not the case, because sometimes this surface, as we said, can be with an angle. If we go to editing the parting surface, our option was perpendicular to the pole, but in some cases it can has an angle, as we talked about in the previous tutorial. So there is another way to select this surface to create the tooling split, because we already know that this face is perpendicular to the parting line. And third option, which I will choose, because when we started to design this mobile cover, we added in mind that this face will be matching the top plane and will be the splitting surface, or the plane which will separate the mold blocks. So I'm going to select the top plane, so here I will select the top plane and start a sketch, normal to, and here again, when we designed, we made it that the origin to be in the center of the mobile. So here I'm going to select directly a center point rectangle from the center of the mobile and draw a rectangle which represent the mold blocks. And here I can add a dimension according to the design. So this is an example. We can make 150 and 100. Click OK, and now I can exit from the sketch. So we have our existing sketch, and go to tooling split, and the sketch is selected, and here you can specify the block size. I'll make it 50 in each direction. And here, if you would like to add an extra face to interlock surface to be between the blocks, but I will uncheck this for now. And here we have the shot of surfaces, the 22, which we made in the previous tutorial when we talked about the shot of surfaces. So all of these surfaces are included in the mold blocks, and as you remember, we have 22 surfaces, the core surfaces. If we expand the surface body, here we have 22 for the core, which are selected over there, and the same for the cavity surfaces. And for the parting surface, which we made in the previous tutorial, is also selected. So all the surfaces under the surface body are selected, and when you are done, click OK. And here we have the mold blocks, the core and the cavity. I'll just assign some appearance. Here, if you click on the tooling split, you'll see the mold blocks are selected at once, but the whole file is including 3 bodies: the core, the cavity, and the mobile cover. And if we go to the solid bodies, you'll see the bodies over there. And here is the mobile cover, and here we have the core, and the top is the cavity. For now, I will suppress this feature, and we'll get back to it again. Suppress, but in this case we will try to make a tooling split on a different face, and select the sketch directly. Click on tooling split, select this face. You'll notice and sketch has been opened. Click normal to, and quickly make the rectangle, and as you notice, click OK,
here we created a block but on the wrong face. So according to the face which you are going to select, SolidWorks going to create the mold. If you try to hide the upper block, you will still see that the block is laying between the parting surface, but this is not the correct positioning of the sketch, because if we again show the block, you will see they are not equal in size. Here we have 55 and here the length is 45, and if we go to the feature we have here 50 and 50. So if you select the wrong plane, SolidWorks still will pick the parting surface as the splitting between the molds, but you will get a wrong positioning of the block. So I will suppress or delete this process and show our first block over there, and here hide this sketch. Now let's try to move the blocks. Move, select on the block, and you can simply drag, click OK, and again we move the core and we'll have a look at the mold from inside. So as we remember, we picked the shut off surfaces, and now you can see that on the cavity of the mold. So as you remember, we picked the shut off surfaces to be in the bottom side of the cover, and here you see here on the cavity over there. So we can also hide the parting surface over there. So here we have our mold blocks. So one last thing in this tutorial, if you would like to save the blocks in separated files for further editing, for example making runners and or fixing holes, click on the solid bodies folder and save bodies in order to save each body in a separated file. You can select the body you need and then save it in a separated part file. This is tutorial 186. In this tutorial we'll talk about the next feature in the mold tools, the core feature. And we will see what is the core and why, and then we will perform an undercut analysis, and then again we'll make a new mold for a new case. That will be also a good review for the previous steps, and then see how to make a core. The core simply is another side of the mold. As we said before, there are two parts of the mold, the core and cavity, and there is also a side core. And the purpose for it is to reach the areas that can be difficult to be made by the core and the cavity. For example, for this bucket, and if you see the handle over there, and you can imagine how we can extract from the mold, so that will be kind of impossible, and you need either to solve this issue or add a core to the mold or a side core. So first, let's go to our previous example, the mobile cover, and roll back to the previous steps before performing any parting line. And as you remember, we performed an undercut analysis for this mobile, and we picked the top plane as the direction of pull. And if you notice, we don't have any issues or red areas which represent any problem with the undercut faces. So for that reason, we will create another part and show you where we have an undercut issues that they need to be fixed or to create a core for it. So let me show you quickly with this pocket I have here, and we will create it later on this tutorial, but here I will show you an undercut analysis. For this part, pick the undercut analysis, and here is the direction of pull. You'll notice the red areas over there which represent the undercut faces which we need to fix in order to make this bucket producible with the injection molding. So click OK. One way to fix this issue is to eliminate these handles. For example, if we go to this undercut and suppress and run the undercut analysis, pick the direction of pull. Here we don't have any red areas, but we still need the handles. Click exit and unsuppress the handle. Also, one way is to create another cut or to expand the cut. Edit sketch, and for example, make it something like this, but we will still have undercut under there. If we go to undercut analysis, pick the direction of pull, you'll see you have under there, exit, normal to, and here you can make this point to be over there and give a dimension and if we perform undercut analysis, here we solve this issue. So you have a view. So you have a view right now. What we mean with undercut analysis, they are the faces which are difficult to be extracted and which can be represented with red color with the undercut analysis. So now let's create this bucket to make a mold for it and then create a core to solve the handle issues. I'll start new part, go to the top plane and draw center point rectangle, give the dimension 200 by 400 millimeter and fillet the corners with 40 millimeter, extrude it to 200 millimeter and give it a draft of 10 degrees angle, and here make a fillet of 20 millimeter and chill it for 20 millimeter. It might be thick, but I made it thick on purpose to make it clear in previewing the undercut areas. So now let's create the handle cuts. Pick the right plane, start a sketch, center point
slot and give it a dimension of 40 by 100 or 80. This point, the origin vertical, and here 35 millimeter, and extruded cut from the both sides. So here we have our bucket, and now let's perform a draft or start again making a mold and review the previous options. Go to the mold tools menu, start with the draft analysis. The direction of pull is this face, and we have the minimum draft we need is 3 degrees, and here is fully green. So this face will have no problem to be extracted, but here we have still some issues under the handles. But the draft analysis for this part is okay. Now we need to perform undercut analysis. Is this face here? You will notice the red areas. So with the undercut analysis, we know that the handles now need to be fixed later on when we start creating a mold. So let's perform under a parting line analysis and click this face. We don't see any preview, but we will see that later when we start creating a mold. So now let's make a parting line or insert a parting line. Click on the parting line, click on that face, and the minimum we said 3 degrees for the angle. Perform a draft. Here we have the green over there. Click OK, and there is no faces need to be split. We have our parting line. Then now the next step, the shot of surfaces. Click on shot of surfaces, the edges to be closed. Let's select them manually here. And here we can make show preview and make it all contact, and again select the edges of this handle, and here we have the green message over there. Click OK. Now the shot of surfaces are done. The next command, the parting surfaces, and here we'll keep the option perpendicular to pull, and here we can giving the parting surface distance of 300. Click OK. Now creating the core and cavity by tooling split. Select the surface. A sketch has been opened, and create the center point rectangle and give it a dimension 500 by 70, and here we give it 350 for the core and 200 for the cavity. Click OK, and here we have the mold. So until this step, you should be familiar with all the previous processes because we discussed them in the previous tutorials. Here we can expand the solid bodies folder and hide the core or the cavity of the mold. which it is the upper side of the mold. So now we have the bucket is showing over there, and now time to create a core for the handle. Click on the core, and here it will ask you to select the plane where you need to create the core. So it is clear that we need to create a core for this handle. So we're going to select this face, and a sketch have been opened. Make it normal too. And now we will draw that have an angle so that the side core can be fixed in a place in the upper side of the block or on the core. Here I will select the line and draw this shape, center point, and here give it a dimension of 100, and here you can give it a dimension of 175, and this distance to this distance can make it 120, and here we can make a symmetric relation, and the side as you can see the upper line is on the edge of the bucket, and here we have the sketch is fully defined. Here we can add a fillet 10, and here as well click OK, and when you click OK, exit, you'll notice SolidWorks will automatically generate the side core, and you will see the sketch which we made is selected, and the direction it selected a face inside, but to be sure with the direction we select this edge, because you can imagine the side core will be dragged in that direction. And here for the core or the cavity, you need to specify from where the core will be extracted. So in this case will be the upper side of the mold or the cavity, which we hide it over there. We can here select, and the tooling or the upper side of the mold is selected, and here we can specify a draft and direction. We need to reverse the direction over there, so that is the direction, and here we need to give a dimensions for the extrusion. For the first direction, we need to make sure that the extrusion is exceeding the mold block, and for the other direction we need to make sure that it is meeting the part. We can make it, there is no need for end cap because the side will be matching the block. Click OK, and here we have the core is generated. So now we can show the upper side of the mold. And if you notice on the solid bodies, we have a core bodies folder. So the same core process can be repeated on the other handle. And for now, let's try to move the mold blocks. The core and the cavity, and then the side core. So here is the shape of the side core, which will be added to the mold in order to create this handle. Hello and welcome to a new tutorial in SolidWorks Learning Series. This is tutorial number 187 in Mold Tools. In this tutorial, we will talk about the cavity feature. In the previous tutorial, we talked about the core feature, so it will come to your mind that there should be a cavity feature as well, but it is not shown or activated in the Mold Tools menu. The cavity feature is not a main method for making molds. It aims to make fast blocks and molds for presentations, and there is no need to follow the previous mold commands or instruction which we talked about in the previous tutorials. So let's start a new assembly, or let's first start making a product. I will make a fast bottle. So here is the bottle. We need to make a mold for it, so we have to be in the assembly mold. If we go to the mold, and here we can search for the cavity, and it's still not activated, so we need to be in the assembly mode. We can start an assembly from the part. So here we can insert the part in the origin, and to make the two blocks of the mold, we need to first insert the first block, insert component, new part. So here we can call it upper block, go to open or edit part. Here we can select the plane, the right plane, and start a sketch. So we need not to include the cap section of this bottle. Here we can draw with the rough dimensions. So here's the first block of the mold. Now if we go to the cavity, save the part, then here we can delete the internal side. Go to insert feature and then delete or keep bodies. Here we can select the inside cavity. Okay. So here you can try to hide the bottle. Then we have created the cavity. Since this is a symmetrical bottle, so we can duplicate the block, hold the control, and here we have the lower part of the cavity, or the second part, so we can try to mate. So here is a fast method to create the two blocks of the mold without the need of following the previous commands, and this is only for fast molds.